Let's begin by answering the question, what is Spring Framework? Spring is the most popular application development framework for enterprise Java. Millions of developers use Spring to create high-performing, easily testable, reusable code without any vendor lock-in. Here is what Wikipedia says. The Spring Framework is an application framework and inversion of control container for the Java platform. The framework's core features can be used by any Java application, but there are extensions for building web applications on top of the Java EE platform. Although the framework does not impose any specific programming model, it has become popular in the Java community as an addition to or even replacement for the Enterprise Java Beans or EJB model. The Spring Framework is open source. The first version was written by Roderick Johnson, or popularly known as Rod Johnson, who released the framework with the publication of his book Expert One-on-One J2E Design and Development in October 2002. Since then, many versions of Spring came, each time bringing newest features to the framework. As of this recording, the version of Spring is 5.2.3.release. Currently, Spring is maintained by Pivotal Software, and the official website is spring.io. Spring is modular in nature, providing the developer freedom to pick and choose the needed services. This was a great contrast to the then popular J2EE applications, where whether you need or not, all the services were packed up in the J2E server, making it very heavy. The core Spring API provides a container of so-called beans, which are nothing but plain ordinary Java objects. In this container is where Spring's magic happens. Spring not only manufactures and maintains these beans, but also identifies the dependencies among them and wires one with another. Although the initial goal was to make J2EE applications easier to use, today Spring has grown to an extent where there is no alternate to this framework. The framework itself has adopted almost all design patterns, and the number of lines of code we have to write is very less, so that we can focus on the domain problems. To get started with this course, all you need is Java 8 and Eclipse. There are a couple of other software requirements also, such as a database management system, which we will see a little bit later. In my case, I already have Java version 8 installed. To check the same, so we're going to go to a command prompt on Windows terminal on Linux and Mac. And if I type here java-version, you'll see that I have JDK 1.8 update 0231. If you don't have Java 1.8, you can go to Google Chrome, search for Java 8 download. The first one comes from Oracle, so you can use the same thing. Scroll down to Accept License Agreement radio button, select the same thing. Once you do that, based on your operating system, select the appropriate build. Once you download the build, finish up the installation and then check the Java version installed on your computer. The second software required for our training is Eclipse. If you are comfortable using other IDEs such as NetBeans or IntelliJ IDEA, please go ahead and use the same thing. However, I'll be using Eclipse for Java EE. So in another Google Chrome tab, search for Eclipse download, and then the first link that you get, open the same. Scroll down to download packages over here, and this shows a lot of options for us, and the one that we want to use is Eclipse IDE for enterprise Java developers. Again, based on the operating system, select the appropriate build. Once you download, again it's the same thing. On Windows it's a zip file, unzip the same, and then there is an eclipse.exe, you can start running the same. On Mac it is going to be a DMG file, and on Linux it's going to be a tar.gz file, which you have to unzip and start using. In my case, I already have this Eclipse up and running. I already have created a new workspace under desktop where I'll be creating all the Spring projects corresponding to this particular course. Apart from so many features that Spring provides, one of the main features of Spring is that it behaves like a factory of beans, which means it is going to manufacture objects of Java classes, which we call as beans, and then maintain them in a container and then provide to us whenever we want. To understand the same, let's take this example. Imagine you want to create a Java application. So let's call this as app. Typically this could be a servlet, or it could be a service tier class, or it could be a simple public static void main program. And this has a dependency on, let's consider an interface called product DAO. So the product DAO interface has got some functions that my application wants to make use of. That being an interface, at the runtime, we need objects of some concrete class. Assume that the product DAO has two implementations. Let's say one of them is for mocking purposes. Let's call it as a dummy implementation. And let's assume that we have one real implementation of JDBC. So at the runtime, app depends on an object of dummy implementation or a JDBC implementation. And in the future, you may have another implementation which makes use of Hibernate or JPA. Typically, the way you would probably get an object of any of these implementation is in the app.java, you may say product DAO equals to new dummy product DAO or new JDBC product DAO. And this means that you have a runtime dependency on a dummy or JDBC, which you're trying to achieve by creating a new object in the app. And this leads to a concept of tight coupling. So the problem is that this kind of object requirement may be there in hundreds of places. If you are hard coding those new object creations in hundreds of places, and if you want to switch to a different implementation, this becomes a very tedious task. And that is the reason we would like to avoid this. And instead of we creating an object of this dummy or JDBC implementations, we want someone else to create the same thing. Now, general practice is that you create another class or an abstraction called as a factory that knows how to manufacture an object of any of these implementations. In our case, we're going to use Spring Framework for the same thing. So the Spring Framework maintains a container, and based on either an XML or annotation based configurations, Spring is going to create objects of this dummy or JDBC IMPLs and then maintains them. So our application now depends on the Spring rather than the actual implementations of this. So this is the concept of Spring as a factory of beans, where we configure Spring such that it has access to objects of dummy implementation, JDBC implementation, or if need be tomorrow some other implementation. All we are going to do is at the runtime, our app is going to talk to Spring and get an object of an appropriate implementation that's configured. So I'm going to create an interface called product DAO and two implementations of the same called dummy product DAO as well as JDBC product DAO. For this demonstration, we're going to use annotation based configuration for Spring Container, and then we're going to write a public static void main program to test out everything. Let's go to Eclipse, where I have few options here that says create a Maven project. If you don't see that, no problem. You can always go to File, New Maven Project. If you still don't see here, that's probably because of the perspective. Currently, I am in Java EE perspective here. If you are not seeing the Java EE perspective, you can always click this button. And notice that Java EE is the default. And if you don't see Java EE, then you have a wrong version of Eclipse. Go ahead and download the Java EE Eclipse and then come back again. Let me create a new Maven project. And the reason we are going for Maven is it is a fantastic tool for managing all your Java library dependencies. And the very first thing that we want to do is to create a simple project by skipping archetype selection. Click on the next button. Maven has a repository of lots of projects where you can make your project part of that repository. And to organize projects properly, Maven expects you to give group ID, which typically represents your organization, and artifact ID, which represents the kind of project that you're working on. For example, if you're part of Apache Software Foundation, your group ID would be org.apache. If you're from Microsoft, you may have com.microsoft. Since my website is vinod.co, a typical group ID would be co.vinod, and artifact ID would be name of the project that you would be working with. Now currently I'm creating a project for learning the basics of Spring, so I'm going to call it as Spring-Basics, and the packaging can be a jar, var, or pom. For now we are not working with web applications, so we're going to simply create a jar project. Later we will also be using a var project, which is web archive. You can give additional name and description. For example, this is going to be a Spring Basics. There's no other next option. You can click on finish and the project gets created. The project also has one file here called pom.xml, which is project object model XML. Let's open the same, and that brings up a XML file, but you can see a GUI version of the same here. At the bottom, there's a tab here for overview, dependencies, dependency hierarchy, etc. At this time, since our pom.xml is pretty much empty, there's nothing over here. One other thing that you can observe here is for the project when we created using new Maven project, Eclipse has a plugin called M2E plugin, which creates this entire project, but somehow it uses a Java version 1.5. If you go to project properties, Java build path, under libraries, you will see that JRE system library, it has taken it as J2SE 1.5. One thing we can do is we can just double click this to choose a different version of Java like this. But I'll not be doing that primarily because each time you do a Maven update by right click on your project, and then there is an option called Maven update project, it will be reset to 1.5. So to permanently make this as 1.5, we will be specifying here a plugin. So we have an option called build. Under build, you have something called plugins. And one other plugin that we would be adding is the compiler plugin, which specifies that the Java version is 1.8. So we'll have to add a plugin, and the plugin has something called artifact ID, and this is Maven compiler plugin. And the configuration for the same is where we say that the source code version is supposed to be 1.8, and then target version is also 1.8. And now that I've done this, let me save this file. And at this time, you can see there are a couple of errors over here. There's one is it says Java runtime environment compiler compliance problem. Let's update our project. So right click on this project, do a Maven update project. I click on OK, and you can see that the errors are gone. Plus, I can also go to project properties, and you can see under Java build path libraries, it has taken Java SE 1.8 automatically. So this is a one-time setup for the project, so let's keep this as it is. And now let's add a couple of libraries which are required for working with Spring. So for this, open a new Chrome tab and then go to a website called mvnrepository.com, which is also called Maven Central, where all the libraries required for your Java projects would be available. And we will heavily depend on this particular repository to get the required libraries. And the libraries required, you simply search by keyword. For example, if I type here Spring, I should be able to get lots of libraries related to the Spring. Typically, one library will have dependency on another one, and that probably may have dependency on another one. Maven can resolve all those dependencies and download all the necessary jar files. For example, if I select this Spring context and choose an appropriate version, let's select the latest release, which is released in December 2019, a month back. So I'm going to select this, and you can see there is an XML for Maven, there's Gradle, SBT, and a couple of other dependency management tools. I'm going to click on this, and that automatically copies to your clipboard. No need to select and press Ctrl C, but it gets automatically copied. So I come back to my Maven pom.xml, and after the build, I'm going to add here a section called dependencies, and then I just paste it. Press Command Shift F on Mac, Control Shift F on Windows and Linux, and that gets formatted. So once again, if you see that the dependency here represents a group ID org.spring framework. So somewhere there will be a folder called org/spring framework /spring context /5.2.2.release, and inside that there will be a jar file. Note that I have not saved the file yet, but as soon as I save the file, you will start seeing some download activity at the right bottom of your Eclipse. In my case, I've used this version of Spring earlier, so it is already available locally, and you'll see that there'll be a new entry here called Maven dependencies. And that might come quickly in my case because I have used this earlier. So as soon as I save it, you can see in a few seconds you should see Maven dependencies, and when you expand that you will see a couple of jars. This is the one that we have specified here, but if you look at the dependency hierarchy tab under pom.xml, you'll see that the Spring context is what we mentioned, but that has a dependency on Spring AOP, Spring Beans, Spring Core, Spring Expression. Spring AOP has a dependency on Spring Beans, Spring Core, and Spring Core has a dependency on Spring JCL, and because of that, you see all the jars over here. Now that we got the Spring libraries, let's bring our actual application, which is this. We want to create a product DAO interface with a couple of implementations. For now, both the dummy implementation as well as the JDBC implementation, let's return some hard-coded values. And later in the subsequent videos, we will get the actual data from the database tables. So let's go to our code. Let's close this pom.xml. Let's right click on src main Java. This is where all your Java files go. And this is where you may want to put your XML or properties files, etc. over here. And these are related to test. In case if you're writing some JUnit test cases, that's going to go in here. And the resources corresponding to your test would go to this location. In any case, I'm going to right click on this src main Java, new interface. And as a good practice, let's give the proper package names, even if it's lengthier. Let's give it as co.vinod.dao because this interface is a product DAO which is supposed to deal with the database objects, and the name of the interface is product DAO. Press enter. Let me increase the font size a bit further. Typically this must have something like CRUD operations and queries, but for the time being let's add only a single query function which is supposed to return a count of all the products that we have. And in general, as a good practice, every DAO function must throw a DAO exception, which is supposed to be a user-defined class. For the time being, let's simply put a semicolon here saying that whenever you call this function, you're going to get a long, which is the count of products that you have in your database tables. Let's go and create two implementations for this. One is a class. Let's call this as dummy product DAO. Now if you observe the name, there are two parts to that. Number one says how does this implement, and the number two is what does it implement. So in this case it's a dummy implementation of a interface called product DAO. So let's add the interface product DAO here and click on finish. We get this basic functionality. Let's get rid of this to do. You can press Command D on Mac, Control D on Windows to delete the line. This being a dummy product DAO, let's return 0 as its value. Let's save this. Now I want to create one more class, but instead of creating a new class, I can click on this, copy this by pressing Command C and paste it using Command V, Control C, Control V for Windows. This will bring a dialog box saying that the name conflict, so do you want to rename? And this time I want to create a new file called JDBC product DAO. I click on OK, and you can see that we got another class. Double click that to open. And for the time being, let's return a value of 100, a hard-coded value, because we don't want to really work with the database at this point in time. We just want to make sure that we have a product DAO and we have two implementations, and Spring can give me an object of either one of them depending on the configuration that we have. Let's go back and create a configuration file. For that, I'm going to right click on this package and I say new class. Since this is about configuration, let's change the package to CFG or config or whatever you feel like. And then let's call this as app config. In the course of this training, we're going to write different configuration files. So let's name them as appconfig1, 2, 3, etc. Let's click finish. Eclipse automatically creates a new package for me, and inside that we have this class. The very first thing that you want to give here is an annotation called @configuration, and you can import that by pressing Control space, or you can press Command Shift O on Mac, Control Shift O on Windows, and that actually organizes our packages. At this point in time, this annotation @configuration doesn't add any value. So even if you don't have this, your application would still work. But as we go forward, when we start working with aspect-oriented programming or transaction management or security, without at configuration, your application may not work. So since this being a class, and inside a class you typically declare variables and functions, the configuration class expects you to write functions that return bean objects. For example, I can write a function here called public dummy product DAO. This is the return type. Let's call it as dummy DAO, where it returns a new dummy product DAO object like this. In order for Spring to make sense, you have to annotate this with @bean. Once again, to import, I'm going to press Command Shift O or Control Shift O on Windows. And I'll also write another function that returns a JDBC product DAO. Let's call it as JDBC DAO and return new JDBC product DAO like this. So if you do not annotate this function with @bean, Spring doesn't care about this function at all. But if you add @bean, Spring gives a different treatment to this function. We'll see that in a few minutes time. But now our configuration is ready. So we supply this class information to Spring. Spring automatically calls all the functions that are annotated as @bean. And this is where a concept of inversion of control also comes into picture, where we do not call this function, but Spring automatically calls this function when it feels necessary. Let's go back to our picture to have a clear understanding of what we have done so far. So we have this product DAO interface, we have this dummy implementation, we have a JDBC implementation, and we have this annotation based configuration. Now all we have to do is to go to the app.java, where we want to create Spring container making use of this annotation based configuration. And then we ask Spring that, hey, I depend on a product DAO, give me an instance of product DAO. So let's go back to Eclipse, create a new Java class, which is a program. Let's right click and then say new class. Since this is a program, let's put the same in a package called programs. And let's call it as P01 get product count. We'll also add a public static void main and say finish. So we do get this particular program. Let's minimize this section. Let's get rid of this to do by pressing Command D on Mac, Control D on Windows. And this is where we want to say that our application depends on product DAO. So let's create a variable of that type. Let's call this as our dependency. But in order to provide the dependency, we need the Spring container. So this is what we want. A Spring container is represented by an interface called as application context. So if you press Command Shift H or Control Shift H on Windows, you get this called open type hierarchy, and then you type whatever the data type that you're looking for. I'm going to type as APPLCON, and you can see you get applet context, application context. This is what I'm looking for. It's an interface, and that interface has got few implementations. Application context is an interface. There is a sub interface called configurable application context. If you expand that, you will see that there is an abstract class, there's another abstract class, there's another abstract class. But if you see somewhere down the line, you have two files here or two classes called class path XML application context and file system XML application context. So basically what this represents is it represents an application context using an XML configuration found in the class path. Likewise, this is an application context, meaning it's a Spring container which is based on an XML file which is found in the file system. Since we are not using XML, these two classes are of no use to us. Let's expand this one, generic application context, and you will see that there are few implementations here. The number one is the annotation config application context. That is exactly what we want. So we want to create an application context or a Spring container using annotation configuration. If you add more libraries, for example, Spring Web Modules, then you will get more such Spring containers also. In other words, an object of any of these classes represents our Spring container. Since we're going to use this annotation config application context, let's go here, define a variable representing the Spring container, and that's done by using annotation config application context. You can see that I'm typing the first letter of each word of the class and then press Control space. You will see that you get an annotation config application context. Let's call it as CTX. Now you need to initialize that, and this is where we get an object of Spring container, and you say CTX equals to new annotation config application context. You can see that there are different types of constructors here. The one that I'm looking for is this, where I can supply one or more classes that are configuration classes. We created something called app-config1 here. We're going to supply that here by typing AC1 control space dot class. So now we have here a Spring container that is defined based on a configuration here. Let's full screen our editor, put a semicolon here. Now we have this Spring container. You also see a warning here because creating a new Spring container has some resources that are opened. Now if you don't close this context, there is a probable resource leak. So somewhere at the end, you make sure that ctx.close is called, and now the warning is gone. Now the Spring container is going to read the beans defined in this app config class, and in the app config class we have defined two beans. So that means at this point in time, Spring is going to collect the return value from these two functions, because Spring is going to call these two functions and then keeps that in the memory. So at this time, if you run the program, our application creates a JVM, which is the area where we have all our objects. And there is this CTX, which is a reference variable. This particular section, when we say new annotation config application context, creates a Spring container. Now the Spring container is like any other containers like ArrayList or HashMap, where it maintains objects. But this time we supplied a configuration class called app-config1. The app-config1 is right here. So Spring instantiates app-config1 first, and using that object, it's going to call every function that is annotated as @bean. So which means it's going to call this function and collects this return value called dummy product DAO. You can think of Spring container is almost like a hash map where there is a key, and the key will be the name of the function or a bean name that you can specify over here. So by default is the function name. So the name dummy DAO refers to an object of dummy product DAO. So what we have here is an object, and let me call it as dummy here, and another object called JDBC. Of course, it's called dummy DAO and JDBC DAO, and then comes back over here. And that newly constructed Spring container is assigned to CTX. So our CTX refers to this object at this time. So I can say that this is our Spring container. But now that we have the Spring container, we also have a variable called DAO, which is again another reference variable. That reference variable, I can say here DAO equals to ctx.getBean, and then I can supply either the data type, like simply say give me a product DAO. But since in our case there are two product DAO objects, Spring gets confused, there's an ambiguity. So we can supply a name of the bean, dummy DAO or JDBC DAO, but in which case it's going to return a generic object. You may have to do a casting, but in Spring 3 onwards, you can supply the name of the bean as well as the required data type. This is what we want to use. So the name is going to be dummy DAO, and the required type is product DAO.class. So the casting not required. And now that I have the DAO, we can check what kind of object it is referring to. So I'll say DAO is an instance of, and then say DAO.getClass.getName. And then I can also say here there are DAO.count products. And that's the whole idea. We want to get the product count. So let's save this and run the application. So before running the application, let's have a look at what actually we have done. So we have created an app. This is our program right now. We created a Spring container. So our application depends on a Spring container. The Spring container has manufactured objects of dummy and JDBC implementations, and those are defined in the annotation based configuration. And our application simply depends on the product DAO and doesn't depend on either of them at the compile time. So if you go back over here, you see that we have not used any imports related to dummy product DAO or JDBC product DAO. So this is what actually we have achieved: 100% loose coupling. Our application depends on an interface type, not on an implementation. Of course, at the runtime, we need an implementation, but that is resolved by the Spring container. So since the Spring container is acting as a factory here, to factory we supply something called discriminator over here, and this defines what kind of implementation currently we are interested in. So if I run this right now, you're going to say there are 0 products, and DAO is an instance of dummy product DAO. But if I change this to JDBC over here and then run the same, notice that I've not saved the file, so it's going to ask me, do you want to save? There's a checkbox that says always save resources so that we don't run uncompiled files. So when I say OK, we're going to get a different instance this time. It's an instance of JDBC product DAO, and there are 100 products. Of course, this is a hard-coded value, but we are getting an object of a different kind and method from that object. One other thing that you can also check out is that at this time, when we supplied the app config 1, let's put a constructor over here. You can press Control space. You'll see that there's a constructor. Delete this by pressing Command D or Control D, and then let's put a system.out.println app config 1 instantiated. So we'll see that at this particular very moment, you will see that the app config 1 gets instantiated, and not only that, these functions are also going to be called. So let me copy this and paste over here. Let's say dummy DAO called. Let's put a message saying that app config 1 dummy DAO called, and the other one we'll put here as JDBC DAO called, so that we know that with the @bean this specific function would be called. So let's go and run the application. You will see that there is a sequence that says app config 1 instantiated, dummy DAO called, then JDBC DAO called. All those things are called right here itself. For example, if I put some kind of a marker over here, you will see that before printing this line, you would see those messages. So let's run the application again. You can see that before the line, app config 1 is instantiated, dummy DAO called, JDBC DAO called, and then we are getting this. However, if I go and remove this or comment this part, this function is just an ordinary function and Spring doesn't care about this. Spring will never call this function. You may have to call this function. Whereas Spring is having no problem in calling this function because it has been marked as a bean. So let's save this, run the program again, and see that the dummy product DAO is never called. Let's get rid of this comment, save this, go back to the picture. And this is the first aspect of Spring, which is the Spring as a factory of beans is what we have seen. Spring manufactures and collects all the beans and then keeps it in the container. Whenever we want, we are only going to ask for the same. So when we ran the application, we saw that before printing this line, that is at line number 20, at line number 18 itself, these 3 lines were printed, which means that the function dummy DAO as well as JDBC DAO have already been called. When we say in line number 22, give me a bean object over here, Spring is not going to call the dummy DAO or JDBC DAO again, but instead it's simply going to return the object from here. So as you can see at this time, DAO already corresponds to JDBC DAO, and we are simply getting the reference of this. Just to prove the point, if I go here and then call this one more time, let's say this time I'll say DAO2 equals to ctx.getBean, and we'll call JDBC DAO itself here, and we want an instance of product DAO.class. One of the error that you will see is that DAO2 has not been created. In Java, every variable must be declared, so we can press Command 1 on Mac, Control 1 on other computers to get an IntelliSense to create a local variable. This is called quick fix. To get a quick fix, press Ctrl 1 or Command 1 depending on your computer, press enter. You'll see that automatically it says product DAO variable because the return value of this happens to be a product DAO. Anyways, if you happen to look at this, now what has happened is that we got a DAO2 here, which is also referencing to the same object. So there are two references, single object. So if I type here DAO2 is equals to DAO is, and then you can check DAO2 double equals to DAO. This should give me true because both of them are pointing to the same location. So just to check this out, let's run the program. And you will see that it says DAO2 equals to DAO is true. But sometimes you may want to have it otherwise. For example, every time you say give me a bean, you want a new bean object. This is only possible if you mark the bean JDBC DAO or whichever the bean you are looking for as a prototype. Now the way you do is you go to app config 1 and let's say this is the one that we are looking at. We can annotate this as at scope, and the scope has two options here at this time. We can say singleton, which is the default value for scope at this time, and the other option is prototype. Now since we are working on a annotation config application context, these are the only two scopes that are there. But when you're working with Spring Web applications, then you will also have scopes like request, session, and global session. So now the scope is prototype. There'll be a significant change in its behavior. Let's save this, go back to our program, run the same. Now keep an eye on this line. You will see that the JDBC DAO is not printed before this particular line. And that's because when the Spring container was manufactured, there is only dummy DAO that got created. And because JDBC DAO is a prototype, it is not even inside this particular container. So DAO refers to one single object and DAO2 corresponds to another object. So these two don't exist and this object also doesn't exist anymore. So Spring will not be maintaining the life cycle of prototype beans. Meaning of that is if you say DAO equals to null, then this object is ready for garbage collection. DAO2 equals to null or DAO2 equals to something else, this object will also be ready for garbage collection. Whereas in the previous case, when it's a singleton, if DAO equals to null, Spring would still maintain a copy of the bean object itself. You can also see here DAO2 equals to DAO is also false because it corresponds to two different objects right now. When a bean is singleton, let's go back to our code here and change this to singleton, which is by default. You can also say that the bean has to be instantiated only on first request. For example, at this time, if you go here and run the application, you will see that irrespective of whether you asked or not, dummy DAO was called, JDBC DAO also was called, but we never made use of this dummy DAO at all. In order to tell the Spring container that, hey, create the bean only if it is needed, but still it is a singleton, you can mark a singleton bean as at lazy, which makes the bean qualified for lazy instantiation. So let's save this and then go back over here and then run this. You will see that before the line there is no dummy DAO, but before the line there is a JDBC DAO because this is an eager instantiation. But if I go to the app config 1, copy and paste the same thing for the second bean also, you will see that before this particular line, that is when the Spring container is created, no beans are created even though they are singleton. But on the first request here, JDBC DAO function gets called, which means that we get a reference of the singleton bean here. But when I call this second time, the bean already exists. This being a singleton, the same reference is given to this again. But all those things happen at later point in time when you actually ask for a bean. So let's run the same thing again and check it out. And you will see that the JDBC DAO is called only once. DAO2 is same as DAO because there are two references, single object. Now that we have got a fair idea of how Spring works, Let's go and look at some more aspects such as dependency injection, wiring, manual versus auto wiring, and few other aspects. For this, let's implement the JDBC product DO with the actual JDBC code, which means you have to connect to a database and get the data from database. If you already have other databases such as MySQL or Postgres, feel free to use the same thing. I want to use a database called H2 database, which is a free, it's completely written in Java and it has few advantages. And this is very lightweight. Also, it can be an in-memory database also, which means within the same JVM as your Java application, you can host a full-fledged RDBMS, typically used for testing purposes, but it also can be used as a standalone database. Now today at the time of recording, the version happens to be 14200. For some reason, this doesn't seem to work as a standalone server. It may require lots of configuration to be done. So I won't be downloading it from here, but I will be using an older version from Maven. Anyway, we need the jar file for our class path because it also represents a type 4 JDBC driver. So let's go close all these files, go to our pom.xml and add a dependency for H2. And the H2 dependency, let's go to our Maven Central, search for H2, press enter. And the first one that we get com.h2 database and then say H2. So that's the one that we are looking for. And the latest version that works properly for standalone mode is this 1.4.197. So I select this and then click on this to copy and then come back to my Maven pom.xml, paste here, format it by pressing Ctrl Shift F on Windows, Command Shift F on Mac. Very importantly, the scope is limited to test here, but we want this to be used even for our regular Java program as well. So let's delete that by pressing Command D on Mac, Control D on Windows. Save this file and the dependency will be resolved. You can see under my Maven dependencies, I see H2 14197 jar. Now literally you can see where it is placed. Under your home directory, in my case /user/Vinod Kumar, that's my home directory. There's a .m2 folder, repository. There's a folder called com/h2 database/h2, and that's nothing but your group ID here and artifact ID, followed by the version information, so which is 1.4.197. This file hosts many things, such as it represents a full-fledged RDBMS. It also has a web server and a web client so that we can interact with the database. And it is also a type 4 JDBC driver, which means that we will refer to a driver class from within the same jar file itself. To start the H2 database server, all you do is you right click on this file over here and then say copy qualified name. So it's actually going to copy this entire path and then go to a terminal or command prompt and then simply type java -jar and paste this entire path. On Windows, you can locate this file and simply double click this jar file. That will also do. But this command anyway works. Let's press enter and you can see it actually starts a database server and comes up with this UI running at localhost 8082. The first thing that you have to change here is from the saved setting, instead of generic H2 embedded, that is what it is popularly known for, we want to use generic H2 server. So now it becomes a standalone server. I can access it from any application. The driver class remains same, org-h2 driver. Let's keep an eye on this because we're going to use this later. The JDBC URL has a protocol, JDBC, that's the client protocol. H2:TCP is the server protocol. Localhost is the computer on which you have the server running. And then there is a tilde here, so ignore that. And then there is this test, which is going to be the name of our DB. Now, since I want to create a new database for this particular training, I'm going to call this as Spring Training. If this database exists already, it's going to use that. If the database is not there, it's going to create a new one. And it will also create a credential for this username as SA, password is blank. So since we are creating a new database, we can give a different username and different password, but I will be leaving this as it is. You can check if connection is succeeded by testing it, and it says connection successful. You click on connect. Since we are creating for the first time, it connects and opens the database content. Right now we don't have anything over here, but we can create or import data such as tables and records. What it has done is it has created a new file with the name of the DB under your home directory. So if I go to my home directory here, you'll see that this is my home directory, Vinod Kumar. And you can see that it has created a file here called spring-training.mv.db. And this is the new database, and every content that you create here, that would be added to this particular file, which H2 is able to open when it is required and display the content over here. I have a file on my desktop called dbscript.sql, and this file contains around 11 different tables with lots of data. We will be using some of those tables for our project. We want to import all the tables and records from this particular dbscript.sql onto our Spring Training database. The command for the same is run script from, and then the path to that particular file in single quotes. So it is under users, Vinod Kumar, desktop, and then it's dbscript.sql. Make sure that the path to your file is appropriate and click the run button. Supposed to import 11 tables like this. I can clear the screen over here and then look into one other table called products. I click on the products, it says select stuff from products, run that, and you will see that I have lots of products over here. And if I say here select count of star from products, run the same, you'll see that we have 77 products. And this is what we want when we actually run our application. We want to get the number of products as 77 instead of 100. Project Lombok is a Java library that is supposed to be plugged into your Eclipse or any other IDEs that you're using. And Lombok helps us automatically generate the getters, setters, and lots of boilerplate codes that we may require to work with. To add this to our Eclipse, let's go to Maven repository and look for Lombok. Press enter and let's click the very first one and select the latest version, which is 1.18.10, and then copy this by clicking on it, go back to our Eclipse, add to our project dependencies. Control Shift F or Command Shift F to format, save it, and if it's already not there, it's going to download from the net and stores that in our local M2 repository here. Once this is done, copy this qualified name by right click on that and go to a terminal or command prompt. I have to open a new tab over here and run the command java -jar followed by the Lombok jar. This brings up a GUI which scans your entire computer for prominent directories where Eclipse can be found, and then it shows the list of Eclipse that you have. I have only one, and in case if it is not found, you can always go to the specify location and identify the eclipse.ini file, and that would be added over here too. If Lombok has already been updated to your IDE, this symbol will also appear right next to this, but right now you can see that I don't have. I have to click on install/update, and it is done now. Basically what it has done is it has added an entry in the eclipse.ini. So if I have to run this again, for example, you'll see that my Eclipse right now has already been installed with Lombok, so I don't have to do anything. So I quit installer, but this will only take effect if you close Eclipse and open again. Now do not click on file restart, that will not help. So you have to close Eclipse and open again. So I'm going to quit Eclipse, say S, and then open Eclipse once more. Once the Eclipse is completely quit, let's open Eclipse again. And this reads the content of eclipse.ini fresh. I'm opening my Spring project folder. My previous Spring workspace is already there, so I click on launch. You won't see any difference here, but to see if our Lombok has done the job or not, let's go to our JDBC product DAO, which is under DAO. Let's say we want to create a couple of variables here. So since we want to work with databases, we also may want to have some variables. Let's create here private string driver class name. Let's say private string URL private string user and password. Now, as you can see, there are 4 warnings here. The warnings are there because these are private variables. We don't have any getters and setters. Obviously, they are useless for an external application. If I look at this outline over here, at this time you can see there are only 4 variables, but by going to our class here and adding an annotation called @getter, press control space, and you will see that I got an annotation from lombok.getter. Lombok instructs Eclipse compiler to add getters for all the private variables. You can see that I already have getter functions over here, which are the standard getter functions. Likewise, I can also say @setter. Now you can see that I also have the setters for all these. If I add one more variable here, even for that variable also you would be seeing those setters and getters. You can add constructors. For example, if I want a default constructor, I can always say @noarg constructor. You see that I got a no argument constructor. So without having to write many lines of code, we already have getters, setters, and no argument constructor. So this is the use of this fantastic tool called Lombok. Now that our DB is up and running and we also have Lombok added to our Eclipse, let's go and implement this function where we actually want to get the product count from the database. We have declared 4 variables here, which represents the driver, class name, URL, username, password. So whoever is creating an object of this class have to supply these dependencies. In our case, Spring instantiates this. So let's ask Spring to pass on these dependencies over here. And the dependencies are supplied using the setter or constructor. I don't have a constructor that takes these parameters, but if I have one, I can actually make use of the same. Let's also add a function here, which is going to be used by maybe many other functions, because every function that this DAO will have eventually needs a DB connection. Let's add a function that returns a java.sql.connection. Let's call it as create connection. And this is supposed to load this driver class name into the VM. Thereby it registers with the driver manager. And then using this URL user password, it's supposed to return a new connection. Eventually we'll also use DB connection pool, but for the time being, let's make use of this function. So the first code here I might want to write is class.forName driver class name. This is to load the JDBC driver into the VM so that the driver object will be registered automatically with the driver manager. The second line is to return a new DB connection by using driver manager.getConnection. There's a function that takes URL, user, and password. We'll supply the same. Both of them throw exceptions. They are checked exceptions. Let's throw them away from the function. So since there is an error, I can click on that line where there is an error, press Command 1 or Control 1 on Windows and press Enter. It will add the appropriate exception here. Again, I'm doing the same thing. Or since this quick fix came over here, I can click on the add throws declarations over here as well. Now this function being private and not being used, there is a warning, but that will go off as soon as we implement this function. So to implement the function, what we will do is we will create a try with resources block. Let's go here and type try and catch any exception we have. Let's for the time being throw new runtime exception so that we don't have to really worry about what actually is the exception. Now this section here is where we can create some objects. They get automatically closed by the time you exit this try catch block. And this is a good practice. This was introduced in Java 1.7. So the very first thing that I want to declare here is a connection variable. So I'll say here connection con equals to create connection, the function that we just now wrote here. So this function is now being called. We got a connection object. And using the connection object, let's create a prepared statement. Let's call it as stmt equals to con.prepare statement of some SQL. I don't have this SQL. It's a very simple SQL command. So select count of star from products. Then we say here result set rs equals to stmt.execute query. Now, since I declared all these 3 variables in the try block over here, they get automatically closed So we don't have to worry about the resource leak. Now that we have got that result set over here, we'll say rs.next to make it move to the first record available and the only record, because your select count of star gives you one row, one column. And what we want to return is a return rs.getLong 1. 1 corresponds to the first and only column that we have in our select statement. But either there is a return value or there is a exception being thrown. So this return is of no use. Let's get rid of that by deleting them. Save it. Now our application is ready. Let's go to our app config, where we have created an instance of JDBC product DAO here. Now instead of returning a new JDBC product DAO straight away like this, we will assign this to a variable. Let's call it as DAO equals to. Since DAO has not been declared, it's giving me an error. I'm going to press command 1 and get a quick fix. Press enter. On Windows, you press control 1 to do the same thing. Now that I got DAO, I can say here return DAO. But before returning, I would like to initialize some values for those setters. So I'll say DAO.set driver class name. This happens to be arg.h2.dCapital_driver. DAO.set URL. Now the URL, either you can type it manually or you can copy it from our H2 console. If you're using Mac, you will see that on the menu bar here, there is an icon that says H2 database engine. On Windows, it will be on the notification area at the right bottom. So if you right click on that on Windows or click on that here on Mac, you'll see that there's something called H2 console. When you click on that, it opens the same in your default browser, and now you can copy this from here. So this is my JDBC URL. I come back to Eclipse, paste the same thing over here. This is your JDBC, which is a client protocol. H2:TCP is the server protocol. / server location. Tilde here corresponds to the home directory of your computer. Typically on Unix platforms, that's what it represents. So since this particular file, Spring Training, is there in that particular location, it's picking up from there. So let's also type here DAO.set user, which is SA, and DAO.set password. Even if it's an empty string, you still have to give, otherwise it will assume null, which is wrong. Now, whenever we ask for JDBC DAO, Spring will call this function, and Spring calls this function means that we are creating an object and returning fully initialized bean object. So this is where the dependencies have been set. And once the dependency have been set, whenever we call the count function, it's making use of this create connection function where the actual dependencies are used at that point in time. Eventually, we get the product count. So let's go to the program that we wrote earlier and then run the same. Make sure that you are getting the JDBC DAO, not the dummy DAO. So when I run the code, you should now see that there are 77 products instead of 100 products, which is actually coming from the database itself. Let's have a look at the app config 1, where we have hard-coded the values of these in a Java program, so which is not a good practice. The best practice is to externalize these values into a properties file so that they can be changed without having to recompile our programs, as well as we can supply them at the runtime via the runtime parameters. To do the same, first let's go to our SRC main resources. Let's create a new properties file. So I don't see a properties file or new file over here. I go to other, and under general we have a file option. I can click on next, and since I selected that SRC main resources, that's what is shown over here. We can give any name we want. Let's give the name as jdbc.properties. Finish. And here we will give some key value pairs that represent these values. Let's give the key as jdbc.driver equals to org.h2.driver, jdbc.url equals to jdbc:/tcp:/localhost / your home directory /spring-training, that's the name of the DB. jdbc.user equals to SA, jdbc.password equals to blank string. The keys are totally your choice. You can give anything you want, but this is the practice that I have developed. So now I can go to my app config one and tell that there is a properties file called jdbc.properties in our class path, and we have to load these keys from there. To do that, we go to app config one and add an annotation called property source. The property source annotation can be configured with an array of strings or a single string. In my case, I have a single properties file here, and the property file is found in the class path, and the name is jdbc.properties. So this file now contains all the key value pairs. So it has already loaded using something like a resource bundle, but we now want to get those things into these functions here. So to do that, let's declare a couple of variables. Let's declare the variables, whatever the variables that we want corresponding to these property keys here. So I have here driver, URL, user, password. So I'm going to use the same thing over here. I'll say private string, I can say driver, or I can use driver class name, which is what is the parameter of this setter here. We also have string URL. We have here private string user, private string password. To read the value from these properties and assign an appropriate value from the key, we can say here @value, which is an annotation from Spring, not from Lombok, and then specify that it is supposed to get jdbc.driver, which is the actual key for which there is a value called arg.h2.driver, and this is a value that we want to inject into this variable. Likewise, I can now copy this and paste for all of them. So I'm going to change this to URL. This is going to be your user, and then the last one is the password. So now I have all the values read from the JDBC properties to these member variables. We can now make use of the same over here. So by just typing here driver class name, this is going to be the URL, this is user and password. And now that we have made the changes, we can verify whether this is actually working or not by going to our application, run the same. Since there is no error, I should simply get the result. But in case if I give a wrong password, for example, let's say I give here Vinod, save it, run the code. Since the password is wrong, this should give me an error saying that wrong username or password. So that's the message that I'm getting over here. Let's go back, change that to an empty string, save this, run the code, get the output once again properly. Now let's have a look at the dependency injection and wiring. Let's go to our JDBC product DAO, and let's say we want to create a variable here called connection of type connection. This becomes a dependency of this particular class, and because of the @setter, we also have a set connection as a function over here. You can see that there's a set connection because of the setter. Now I can alter my create connection function such that create a new connection only if this connection is equals to null. So I can come down here and I can say if connection not equals to null, as well as connection dot is closed equals to false, then we will return connection. But in case if the connection is either null or has it been closed, then we create a new connection using these member variables. If you run the code as is, you will see that it is not going to give you any errors. You will still see that there are 77 products. That's because using app config one, we are able to supply this particular DAO where we have manually initialized all the values. Obviously, the connection is null. So this condition is false. So this whole thing is skipped. Based on the driver class name URL user, it's manufacturing a new one. What we will do now is we'll make a new app config. So we're going to copy this app config 1 and paste it as app config 2. Let's use that app config 2. We don't want these constructors. We don't want this dummy DAO here. We don't want lazy and all those stuff. So let's just keep everything simple. We'll also delete this system.out.println. We'll also remove these setters because what we want to do is to assign a connection object. Now what if connection itself is a different bean? For example, if I have public connection, let's say we'll call it as connection class dot for name of driver class name, and then we say here return driver manager dot get connection of URL username password. Both of them throw exception. First of all, connection needs to be imported, so let's just import it from java.sql, and then we will also throw away all the exceptions that we get over here. So since Spring is going to call this function, so Spring will handle the exceptions by breaking our application. But for that to work, we have to say @bean. When you actually create a Spring container using app-config2, Spring calls this function automatically and loads the driver class name, creates a new DB connection, and then keeps it with a name called connection. That's one bean. And the second bean happens to be this, where we say that this bean can make use of this bean. In other words, there is a dependency of a connection type over here, and this bean object can be wired to this bean. There are a couple of ways you can do. Number one is you can say DAO.setConnection and then call this function over here, just like that, where I am calling the function and that function is going to return a connection object. We're going to set it up over here. And the error here is because of these two checked exceptions we are not handling over here. The second method is, since this particular function is called by Spring, you can ask Spring to supply any other beans that you want. For example, if I declare a variable called connection here like this. Now, since Spring is going to call this function, Spring looks at this parameter type and then checks, hey, you need a connection. And I do have a connection over here. Now, what if I have two functions that return connection object? This is the dependency injection that Spring resolves by making use of this name of the bean. Name of the variable that you've got here is called connection, and the name of the bean is connection over here. So there won't be a problem in resolving that. So Spring does a dependency injection here. Now that I got this connection, I can supply that to my setter. And now you see we are doing a wiring. So at this place, it's called the injection of dependency. And this is basically the wiring, which is actually manually done because I'm doing the wiring, not automatically done. Let's save this, go back to our program. Our program is making use of app-config1. Make sure that it's coming from app-config2 now. So let's import that and run the code. We should still get the same result as that there are 77 products. And let's go to app-config2 and have a look at this. This is called manual wiring. Now, Spring can also do an automatic wiring. For example, let's say we comment out these lines and then say here, return new JDBC product DAO. At this time, whenever we ask for the JDBC DAO in our program like this, we are actually getting an instance of this, which is an object of this class over here. And all these 5 member variables are null. So when actually create connection is called, connection is null, so this fails. And class.forName null will result into a null pointer exception. So if you run the code now, you should see a null pointer exception, right? Alternately, we can ask Spring to do an automatic wiring. So at this time, the application JVM looks like this. You have a CTX as a reference variable that points to a Spring container. And the Spring container has been loaded with these two beans. So the bean number 1 is the connection, bean number 2 is the JDBC DAO. But they are not wired with each other because we are not doing any manual wiring. And when we go to the program over here, when we said DAO equals to ctx.getBean, this is the actual object that we are getting. However, the object is not initialized with any member variables, so they're all nulls, and then we are eventually getting the null pointer exception. What we want to do is we want Spring to automatically wire this connection with this particular bean object. So this is supposed to be done. To do that, I can go to JDBC product DAO and then mark this particular variable with an annotation of @autowired. So I'll say here @autowired, save it. Now if I go back to the program and note that app-config2 still has no connection between these two bean objects, no wiring, but my program should still work because of the auto wiring. And you can see that our application is working and it says there are 77 products. While we are able to successfully get the result, there is one problem. Let's go to our code here and then call this particular function once again, and you will see that there will be an error. So I'm copying and pasting, and let's run the code here now. When I run this, you'll see first time we get an output, there are 77 products. The second time we are getting an error saying that there is a null pointer exception in the create connection function of our JDBC product DAO. So if I go over there, you will see that it is trying to load the driver class name. While we never injected the driver class name, we injected a connection. The reason for this is, so first time when we call this particular function DAO.count, it goes to the JDBC product DAO count function and calls the create connection, where the connection is an object that we got dependency injected, and since we are using that inside the try with resources block, as soon as you come out of this try catch block, the connection gets closed. So the next time when you are calling this function DAO.count again the control comes here, and when the connection is being obtained using create connection, you will see that the if condition fails because connection is not null but connection has been closed. So because of this, now the if condition is failed and it's trying to load the driver class name where we didn't supply the driver class name. So if you look at the app config 2, we don't have the driver class name injected to our JDBC product DAO at all. So the JDBC product DAO is automatically wired with a connection object because of the auto-wired annotation, and hence we are getting the null pointer exception over here. So if you want to pictorially represent the same, first time when we called the DAO.count, the count function was called over here, and that count used the connection which is open and there was no problem. But as soon as we hit the database and got the product count, the connection got closed. So the connection object still exists, but it is closed. And next time when I call the count function again, it is trying to use a connection which is now stale because the connection has been closed. So there are a couple of solutions that you can come across with. Every time you want a connection, you manufacture a new connection like this. So make it as a prototype. But unfortunately, auto wiring is done only once and you would only get a single prototype object. So this will not help. So if I go to app config 2 over here, and then annotate this as a prototype bean by typing @scope of prototype and importing the same. This is a prototype bean, but this is a singleton. When we got the DAO object, we got a singleton over here. So DAO2 also corresponds to the same thing. When I say DAO.count, it uses a new connection object, but the same connection object is also there in DAO2. For example, if I make this as DAO2 now, both DAO and DAO2 reference variables refer to the same DAO object because DAO is a singleton. When that singleton object was constructed, a new connection was injected. It's the same connection, still you will have the same problem. The other solution would be, for example, if I go to app config 2 and then annotate even the DAO bean also as a prototype, this may solve the problem temporarily. Let's go and run the same. You'll see that now I do not have that problem. I got it. But if I make use of the same DAO object and call this another time, I might run into problem. And that's because now here we are using the same DAO object, the connection is not recreated. So even making the objects as prototypes also is not a solution. There is also another issue when you are using the common connection object. If there are multiple clients trying to make use of the same connection, then all of them will be working under the same transactions, which means that if one of the client commits the transaction, it affects the other clients also. So the solution is to use a connection pool where an application creates a bunch of connection objects that can be reused. Instead of destroying those connection objects, a connection object is used by the client and then connection is closed, but the connection gets recycled and will be available in the pool once again. So there are a lot of advantages of using the connection pool. Number one, every client gets its own connection object, which means that there will be a separate transaction. There won't be any transaction conflicts. Number two, creating a connection object is a background process. That means it won't affect the application's performance. Number three, each time a connection is closed, the connection gets recycled and no new object has to be constructed or no connection object gets destroyed and garbage collected. So this improves the performance. Plus, a client doesn't have to spend any time in opening a new connection, because on an average it takes almost a second to open a new connection. As well as if you close the connection and destroy that connection object, there will be an impact on garbage collection also. In Java, a connection pool is represented using an interface called data source from Java x.sql package, which has a function called as get connection. So all we need to do is find an implementation for a connection pool and make use of that. While there are many connection pool implementations, the most popular one is one from Apache, which is called basic data source. So first, let's add the relevant libraries to our pom.xml. So let's go to mbnrepository.com, look for dbcp, which stands for database connection pool. And the most common one is the Apache Commons DBCP, and the artifact ID is Commons DBCP2. Click on the same. And let's take the latest version 2.7.0. Here we have a XML. We copy the dependency, come back to our pom.xml and scroll down somewhere here, paste after the lombok, format it and save it. As soon as I save, the jars will be downloaded from the net. So now if I go to Maven dependencies, you will see that there's a Commons DBCP2, its dependency, the Commons pool 2 and the logging jar. Now that it is done, let's do one thing. Let's create a new app config by copying app config 2 and pasting it as app config 3. Let's open the same. While we need the DB information, we don't need the connection anymore, but instead we will create a new bean here which returns something called data source, which is from Java x.sql package. Let's call it as data source and create a variable of type basic data source from Apache package. Let's call it as BDS equals to new basic data source, and we need to return this particular object. But in between, we have to initialize this object also. Let's not forget to mark this as @bean. There are two sets of properties you want to initialize for the basic data source. The number one is the DB connectivity information, which is a bunch of these values. The second one is about the pool configuration. So first, let us set the DB connectivity information. So if I type here bds.set, you'll see that you get a lot of setters, and one of them is set driver class name is the variable that we have here. bds.set URL, we have the URL, bds.set user name, and the variable we have is called user. Then we have bds.set password, and we have the variable called password. We also want to specify how many connections you want in advance. For example, I can say when the connection pool is constructed, what is the number of connections to be present initially? So I can say here bds.set initial size. Let's say I want initially 10 connections to be ready. As in when a client is asking for a connection is given from the pool, and so the number of active connections starts reducing. And once it becomes 0, then new connections are added automatically. This means that there will be more number of connections in the connection pool, but you can also set a cap to this by typing bds.set max total and then supply. Let's say, for example, I want a maximum of 100 connections, not more than that. That means if there are at a time 100 clients that are consuming the connections, the 101st client will have to wait. You can also specify how long that has to wait. You have something called max wait in milliseconds. Let's say the max wait period is 500 milliseconds. That means half a second a client will have to wait before getting an exception. But within that half a second, if there is a connection being released, that connection can be reused by the new client. Now, once all the clients that are consuming the connection starts closing the connection, they all come back to the connection pool as idle, because initially there was 10, but now maximum of 100 have been reached. Now the connections being closed will become idle, and you can always say how many idle connections you want to keep. So I can say bds.set max idle, and then I can say 50, for example. Now likewise, you also have few other options such as bds.setMinIdle. For example, I can say at any given point in time, I always want two connections to be idle so that in a background process, connection pool creates new connection objects. Depending on which implementation of a connection pool you are using, these properties may change. So for the most common basic data source, these are the most popular settings that you may want to do. Now that we have a connection pool ready, we do have here an object of a JDBC product DAO, but the JDBC product DAO has no dependency on this particular bean. Let's get rid of this scope also. We don't want this to be a prototype. Both of these are singleton beans, but every time a JDBC product DAO function is called, such as count function is called, I want the count function to use a new connection from this particular pool. To do that, let's go to the JDBC product DAO. We probably may not use this particular variable at all, but just to make sure that our previous programs work, let us keep this. We also will say this time a private data source, and let's call it as data source itself as the variable. We have to import it. I'm going to press Command Shift O to import the same from javax.sql package. And we want this to be automatically wired. So I'm going to copy this and paste over here. While the data source gets injected because of my app config 3 here. So there is a bean, there is a bean. And when Spring collects this particular bean object, it realizes that there is an autowire dependency. This qualifies for the dependency and this object gets injected automatically over here. The auto-wiring also first is done based on the name. For example, Spring will look in the container whether do we have a bean whose name is data source, and look at this, we have the exact same name here. But in case if the function name here is different, then it's going to check is there an object of this data type, and the object data type here is a data source. Even if you had written basic data source implements data source, it qualifies as an instance of data source that gets injected. So it's always a good practice to maintain the same name for both the bean as well as the variable here. We may run into one problem with this one. We will come back to that in a minute. But we'll first modify our create connection function such that if there is a data source and it is not equal to null, so I'll say here if data source not equals to null, then we will simply return data source dot get connection. So that is a function that we would be using to retrieve an idle connection, and that connection object is going to be returned, and that is going to be used over here. At the end of this try catch, the connection gets closed, which means the connection is returned back to the pool. Pool will automatically clear its resources and then reset, and it's ready for new client as well. Let's go save all our files. One last thing we have to do is to make sure that our program uses app config 3 now. So I'm going to import the same. When we run this code, we may come across an unusual error. Let's give it a try. When I run this code here, you'll see that we have an exception. Let's figure out what is the problem. And the problem is in the line here. It says error creating bean with name JDBC DAO defined in app config 3. Unsatisfied dependency expressed through the method JDBC DAO. Parameter 0. Nested exception is it's going to say here no qualifying bean of type connection available. And it says expected at least one bean. Now the meaning of this is when Spring is trying to resolve the dependencies of this, it finds that it has dependency on two of these particular variables, whereas it finds a matching bean only for this particular auto wiring, not for this. And hence it is giving an exception saying auto wire dependency injection is failing. I can just get rid of this @autowired and the problem would be solved. But in case if I go back to the program and then change here to app config 2, then it will fail because then autowired is not present for this. So in practice, we don't come across with this problem because if at all we have declared a variable and it needs to be wired, we need to have connection. So somewhere we would be having a connection object also. However, in this case, I want to maintain this for my compatibility with other programs. But I really don't need a connection in case if connection is not available. So what I can do is I can go ahead and I can give an element here called required equals to false. indicating that, hey, if you find a connection, inject. If you don't find a connection, don't throw me an error. Now the same thing I also would like to give it to this one, because if I'm running the previous program with appconfig2, this is what is used and there is no connection pool with appconfig2, and this would cause the problem. So I'm going to copy this required equals to false, and then I'm going to paste over here. Now in practice, we generally don't use this, but this is a peculiar situation because we are learning with different configurations and I don't want to really delete this code. So let's go back here now and then run the code, and I should be getting an output without a problem. But I think I still see an error, probably because when I copy pasted the appconfig2 to appconfig3, I forgot to delete this one where it was trying to inject the dependency. Now I don't have any dependency over here. So obviously this is an independent bean. This is another independent bean. But Spring collects this bean object and finds that it has a dependency on a data source, and it automatically injects that or automatically wires the same. So let's save all the code and then run our program and see that we get an output without a problem. Of course, if I uncomment this, I should still be able to get the result, because this time I have a dependency here, but it's really not required and Spring will not cause any problem at all. So one last time I'm going to run the code and see that I get the result without any problem. In our appconfig3, if you look at this particular bean, the only thing that we have done is that we created a bean object and returned the same. There's no dependency injection done here, as well as there's no wiring done here. Spring is smart enough to automatically do all these things also. For example, if I get rid of this and if I try to run the program, of course the application is going to fail, because at this point in time, our program, which is using appconfig3, is trying to look for a bean whose name is JDBC DAO, and in this appconfig3 we don't have any bean matching that particular name or data type. This is where we have to tell Spring that, hey, go and look in a package such as this co.vinod.dao and load all the beans from there. Now how does the Spring know which class to load from here? For that, we have to go to this particular class and annotate the same with @component. And we can optionally give a name, such as, for example, I can say JDBC DAO like this. If I don't give the name over here, it'll take the same name as the class name, but starting with a lowercase letter. So since we are looking for a specific name here, let's give this name as JDBC DAO. And in order to tell Spring that you have to scan all the components from this package, we go to our appconfig3 and add an annotation here @component scan, and then say here base packages equals to an array of strings representing different packages. Now since it says base package, I can simply say co.vinod, but then it will start scanning everywhere, including CFG, DAO programs and other places. It is always a good practice to narrow it down to specific packages. So I'm going to give co.vinod.dao. And now Spring, looking at this particular component scan, goes to this particular package co.vinod.dao and any other sub packages if exist, and then try to load all the components. Now the components are nothing but the classes that are annotated as @component. So dummy product DAO is not a component because it's not been marked over here, but the JDBC product DAO is marked with @component, so this qualifies. And also it has got a couple of auto wirings done, which means that one of the bean like data source is automatically wired to this, and connection is not found, so there is no dependency injection done over here. And now I should be able to run the code, access this bean JDBC DAO, while we did not instantiate, Spring automatically created the same. So let's save the code and go back to our application, run the application to see the result. Let's go back to the JDBC product DAO. A component is a very generic name depending on what kind of class this is. For example, is this a class that belongs to the service tier, which contains business logic, or does it contain data access logic? So that means it belongs to a repository or DAO layer, or is it a web controller? Based on that, you have specific type of component annotations, So instead of giving this, I can also give @controller, though it doesn't make any sense here because it's not a controller, but this would still work. So let's go and check it out by running the code and notice it works. So instead of controller, I can also give as a repository, which is nothing but a DAO. So I'm going to run the code. It still works. I can also give here service. Typically services are nothing but business logic classes. And this is not a business logic class, but @service also qualify for component scan. You can also give a @configuration, and absolutely this is not a configuration class, but still this is going to work. And if you're working with a web application, you also have another annotation called REST controller, and that also would work. But the best suited for this particular class, because this being a DAO, which is nothing but a repository, the annotation that you should be using is a repository. Now, as we saw earlier, it does not matter what annotation you used, it still is qualified for component scan. However, depending on the environment that your application is running, a specific annotation that you use may have a specific impact. For example, in an MVC application, a class annotated as @controller has some special privileges. So it's a good practice to identify what kind of class that you have and then annotate them accordingly as @controller, @service, or @repository. When you're working with JDBC applications, there are a lot of boilerplate code that you can avoid. For example, if you want to get the list of all the products from a database, you first have to obtain a DB connection. Then you have to create a prepared statement. If the SQL command has a lot of question marks or parameters, you have to set all the parameters. Then you have to execute that. Then you have to collect the result set. Then you have to iterate over the result set. And then for every row, you have to convert that row into a domain object or an entity object. And then you have to collect them into an array list or some kind of a data structure. And then you have to close the result set, close the statement, close the connection, handle all exceptions, and then return the list of data that you collected. If you observe all these, a lot of things are common for getting a list of employees or getting a list of customers. The only thing that changes here would be what is the SQL command, what are the parameters that we need to assign, and how I can convert a row into a product or an employee or a customer object. The rest of the things are called boilerplate code, which are like a template. Since Spring follows almost all kinds of design patterns, Spring follows one other pattern called template pattern and has given a class called JDBC template. In order to make use of this JDBC template, first we have to add the JDBC dependency. So you can simply copy this particular section, paste it right next to that, and change this context to JDBC and save this. As soon as you save, you will see that there is some download activity. And if I expand my Maven dependencies, you will see that there is a Spring JDBC dependency has been added, as well as the Spring transaction APIs also are in our build path. Now if I press Command-Shift-H or Control-Shift-H on Windows, you get the open type in hierarchy, and then type here JDBC template, click open, and you will see the members of the JDBC template class. Let's say we want to see only the public members of the same. Number one, you can see that there are a couple of constructors over here. The constructor here takes data source as a dependency. Coming from the JDBC accessor, there is also a set data source. So in other words, you can say JDBC template depends on data source. That's a dependency that we can ask Spring to inject. But apart from that, if you have a look at the functions, there are a lot of functions which help us execute SQL commands. For example, here there's an execute command. There's a bunch of query functions, which are nothing but functions to execute SQL select statements. There is also a function called update, which is used for executing any insert, update, delete statements. Basically, almost all the boilerplate code is handled by this particular template class. Only the things that Spring is not aware of, such as SQL commands, the parameters, and the way Spring has to convert a result into a domain object, that we have to supply. So let's create a new app configuration where I have a data source and a JDBC template wired with each other. So let's copy this app config 3 to app config 4, open the same. And I don't need this time the component scan because I'm not going to make use of the DAO at this point in time. So let's get rid of that. We need all these JDBC values. We need a data source and we want to inject this data source to a JDBC template class. So let's go and create a bean. So I'll say here public JDBC template and let's call this as JDBC template itself. And let's ask for a data source here so we can wire them manually. Let's call it as data source and we'll say return new JDBC template of data source. We have to annotate this as at bean, otherwise Spring doesn't care about this particular function. So basically what we have done is we have defined a bean over here, we have injected that over here, and then we are wired with this JDBC template using the constructor. And in our programs, we're going to ask for this particular JDBC template and test the functionalities in the subsequent videos. Now that we have the JDBC template, let's go on and test out the same thing using a program. Let's go create a new program this time. I'm going to create a new class under programs package. Let's call it as P02 testing JDBC template. Press enter. I forgot to add the main function, but I can always type main control space enter to add the main. Now since we want to test out many features of this JDBC template, let's write smaller functions to do the same thing. And in all the functions, we want to make use of the JDBC template. So let's create a static variable of type JDBC template called template and initialize that over here so we can use the same template in other functions. I'm going to use the annotation config application context ctx equals to new annotation config application context and supply this AC4, which is appconfig4.class. Now we have a Spring container ready. Somewhere down the line we want to close that, otherwise we will have a cause of a resource leak. And now that we have the Spring container, we can ask for an object of this JDBC template. So I'm going to say here template equals to ctx.getBean. And this time I'm only going to simply supply the data type and not the name. So we now have no ambiguity because there's only one single instance of JDBC template in the entire Spring container, which is this. And that is actually going to be retrieved and given to me over here. Suppose we want to add a new record to our database table. Let's go to our H2 console and have a look at this table called shippers. There are only 3 columns there, so it's easy for me to add a new record. Let's assume that we want to insert a new record with ID as 4, some company name, some dummy phone number. In typical JDBC, it would have taken at least around 10 lines of code, whereas now I can do that with the help of this template in a single line. For example, I'm going to call a non-existing function called insert shipper. And this gives me an error. Whenever you get an error, you can move the cursor on that to see what's the error and quick fix. But since I knew that this is a non-existing function, I know that Eclipse is also telling me the same thing. I can simply press Command 1 or Control 1 and get the quick fix. Press enter. You'll see that it creates me a new function. See here, there's some boxes. You can move around those boxes by pressing Tab. And if there are some options available, Eclipse will suggest, and we want a package level here. The function is void, it's no problem. Insert shipper, do you want to rename? No. And then I can delete this to do and then add my code over here. So basically, we are now going to call this function and transfer the control over here where I have access to this template, and using this template, I want to insert a new record. And it's as simple as calling template.update, equivalent of execute update in prepared statement. So I say template.update. The actual SQL command is insert into shippers values, and I'll supply question mark, comma, question mark, comma, question mark. These are the 3 parameters, and I can now supply the parameters like this. Say ID is 4, Let's assume that I have here something called K Vinod Transports, and let's say a phone number, something like this, and close the bracket. So as you can see, I have a single function call over here, and I supplied an SQL command which has three parameters, and I'm supplying the values for those three parameters. And of course, I can always give a message saying that data inserted. I'll say new shipper data inserted. Let's give it a try by running the code. Let's save all of them and then click the run button. And it should simply say new shipper data inserted. If I go back over here and then click the run button, you'll see that the new record has been added successfully as well. You can use the same template.update for updating records. For example, let's say I want to change the phone number of a shipper. For example, let's say this is the shipper ID and I want to supply a new phone number. Let's write a function. I'm going to comment this one so that I don't want to really call that. Let's call it as update shipper phone, and I want to supply a shipper ID which is 4 and a new phone number. Let's give the same thing in a different format. Let's give something like this, 1424-784, something like that. And this function also doesn't exist. Eclipse is giving me an error. Again, I press command 1 enter, tab, I select the package. I don't need to change the return type, no need to change the function name. The data type int is fine, but this is instead of I can type here as shipper ID or just ID, and then string is fine, but this is supposed to be phone. Let's get rid of this to do, and now we simply call the template.update function. We supply the SQL and then ID and phone. We don't have the SQL. Let's create a new variable called SQL, which is update shippers. I can say set phone equals to question mark, where shipper underscore ID equals to question mark. Now I have a small issue here because the first question mark corresponds to phone. I have to change this. So I'm going to cut this from here and paste over here. So template.update takes an SQL command and the values for all the question marks that SQL command has. And let's give a message over here saying that phone updated. Save this, run the code, and you'll see that it simply says phone updated. If I go here and run the same once again, you'll see that we got the result similarly, and I should have given 3-digit hyphen 4-digit, no problem. I can just go here and change this like this, run the code, and the phone got updated. So let's go refresh. You'll see that we got our new phone number. Template.update can also be used for deleting a record as well, but generally we don't do a hard delete. We do something called soft delete, where the actual record exists, but there'll be a flag which indicates that the record is inactive. Based on the number of rows that a select statement outputs, we can categorize them into three types. Number one is a query that returns one row, one column. For example, if I say here select count of star from products, press Ctrl Enter, you'll see that we get a one row, one column, which shows number of records of products table. Similarly, I can say here select company underscore name from shippers, where shipper underscore ID equals to 4. This will give me one row, one column, because based on an ID there's only one record and we are only looking for company name. The second type of select statements would produce one row but multiple columns. For example, I can say here select star from employees, where employee underscore ID equals to 1. This particular query will result into one row but multiple columns in it because we are querying it based on primary key. And the third type of SQL select statements would produce multiple rows, multiple columns. For example, I can say here select star from shippers or select star from products, where category underscore ID equals to 1. So these kind of statements will produce multiple rows, multiple columns. In this lecture, let us focus on the first type of commands where you get one row, one column. So let's go to our Eclipse and write a function here where we want to produce the number of records in the products table. So let's call this as print product count. Since we don't have this function, we are getting an error. Let's move the cursor on top of that error and click on create method. I can press tab to navigate and choose the appropriate options. String SQL equals to select count of star from products. Since we know that this produces one row, one column, we want to know what kind of data type is that. This could be treated as an integer or long. So I can say here template.query for object and then say here the SQL and the required data type is integer.class. So the return value of this particular function now automatically becomes an integer. So I can simply assign this to a variable like PC. PC has not been declared, so we can create a local variable PC and note that it becomes automatically integer. Had this been long, then this would have been automatically a long. So now I can print here something like there are PC products. Let's test it out by running the code and you should see that there are 77 products. Let's give another example. Let's say we want to find the name of the shipper based on the ID. Let's say here print shipper name, where we'll supply the ID of 4. This function again doesn't exist, so we're going to create a new one. Press tab to navigate to those boxes and choose appropriate option. We want to have it as void, function name is fine, int is fine, but this is going to be a shipper ID. Let's get rid of this particular to do. And then say here string SQL equals to select company underscore name from shippers, where shipper underscore ID equals to question mark. And now I have this parameter. So unlike the previous example where we supplied only the SQL and the data type, this time we also have to supply the parameter. And the way we do is we say here template.query for object. And this time we're going to select this one where we have the third parameter, which is the parameter list. So I'm going to select SQL. Required type this time is a company name, which is a string. So I can say string.class. And then args is a where args here. So if you have 5 question marks, you may give 5 values over here. I have only 1 question mark, so I have to supply the value for that. The return value of this now has dynamically changed to string. So if I assign this to a variable called name equals to, and name automatically becomes a string here. So let's go and print the same thing. Shipper name equals to plus name and execute the same to see the result. And it says K Vinod Transports. Let's execute this query that says select star from products, where product underscore ID is equals to 33. Product underscore ID is the primary key. Obviously, if at all there are records for this ID, there's going to be only one. So when I run this selected query, this is how the output looks like. And you can see that the output is nothing but a bunch of key value pairs, where key is the string column names. And for each key, there is a value of different types. So this can be an integer, this is a string, here is a double, there could be a date or boolean. When we execute this query using the JDBC template, a JDBC template converts the result into a map, because map is also a key value pair. Basically, Spring collects the result set, which has exactly one row with multiple columns, and constructs a map object, puts all these column names as keys and the corresponding values as the values of the keys. To test the same, let's go back to our code and comment this line and then create a new function here, and let's call it as print product details, and let's supply the ID 33 just like the SQL select statement there, and let's create a new function with that name called print product details, which takes an int. We can say that this is a package level function. Variable name is going to be called product ID. Let's get rid of this particular to do. Let's create a string variable called SQL, which is equals to select star from products, where product underscore ID equals to question mark. And this time I cannot use query for object because Spring doesn't know how to treat this as an object, because this is a bunch of values. So we use a different function this time. So that's called template.query for map. We can supply the string itself, or we can supply the string SQL followed by the parameter values, which is a var_args, which is an array of values. So let's select that. SQL we have here. The arguments are nothing but one single argument here, which is the product ID. And let's assign this to a variable called data. And data has not been created. Let's create that variable called data. Spring knows what is the return data type of this function, and accordingly it creates that variable. Now that we have the map, we can straight away print it like this, or we can say data.get and get the appropriate column names, or we can loop over the keys and then get the individual values. First, let's give it a try, and you should see a result of a map, and you can see it says product ID equals to 33 and so on and so forth. So let's remove this and then print it in a different way. So let's use a for loop where we can say for key, which happens to be a string, in data.keySet. So that's going to be a set of keys that we are looping over. And for each key, I want to print the key along with the value. Let's give a system.out.println key plus whatever the value corresponding to that is data.get. And then we have the key as the parameter. And this should give me a bunch of key value pairs in a different style. Let's execute and see the result in a different way. If one row with multiple columns can be treated as a map, then if you have a query that returns multiple rows, they can be treated as a bunch of maps, and a bunch of maps can be represented as a list of maps. So in order to collect the values from JDBC template gives me a function that returns a list of maps. So let's make use of that to get the list of shippers. So let's go here, comment this line, and let's say we call it as print all shippers. And the function print all shippers doesn't exist. Let's go and create the same. We'll make this as the package level function. And the actual query is going to be now string SQL equals to select star from shippers. And when I call template.query for list, I can supply just a string or string SQL with what kind of data type. For example, if I had given here select company name from shipper, I would have got a list of strings. That's the reason why we have this data type. And if the query has question marks or parameters, you can supply them also, and a few other variants along with this. So I'm going to select this one and supply the SQL alone. Let's say we want to assign this to a variable called list, and the list doesn't exist, so it's going to be created by Eclipse for me when I click on this create local variable list. And notice automatically it becomes list of map. But had I given here a data type called string, then I would have got list of string. Now that I got the list, I can loop over the list. Let's say I give here for, and I can simply say data in list without creating the variable data. It's giving me an error, and I can say create the loop variable data. Based on the individual elements data type, this variable gets created. So I'm going to create this loop variable data, and you can see it is a map. And I can print the name and phone of each of the shippers like this, data.get. The get takes a key. I can type here company underscore name. That's the name of the shipper. Plus I can give the phone number like data.get phone. And let's give it a try now. So we should get the list of all the name and phone numbers of the shipper. And we got the same. Let's write one more example where I want only the name of the shippers. So I can say here print all shipper names. This time, let's create another function, and the SQL select statement is going to be string SQL equals to select company name from shippers. And I can say here template.query for list. This time I'm going to select the second variant where I say SQL, but the element type is a string.class, and assign this to list just like the previous one. But this time the list is not going to be a list of map, but it's going to be a list of string, because we explicitly mentioned that the element here is a string. And now we got that. So let's loop over and print all of them by just typing for string name in list. Let's just print the name. like this. Execute the code and we should get the list of all the company names of shippers. While Spring is able to give a map or a list of map, in many practical applications such as multi-tiered architectures where the presentation layer depends on the domain objects. For example, instead of getting a list of categories as a list of map, we would like to have a list of category objects where a category class represents the columns of a categories table. What I mean is, the categories table has category ID as a field, category name, description, picture. For this, we want to create a class called category with the respective field names, getter setters, and we want the objects of category class for every record in the categories table. Since Spring uses the template design pattern, we can ask Spring to generate such objects, providing the logic for converting the result set into the category object. In this demo, let's have a look at the same thing. Spring provides an interface called row mapper. To have a look at the same, let's press Command Shift H or Control Shift H on Windows and then type row mapper. You'll see that there are two interfaces. One comes from Java X.Swing, the other one comes from arc.spring framework. So let's select the same. When you say open, you'll see that there is a single method called mapRow, which takes a result set as a parameter, int which corresponds to the row number, and then supposed to return a custom object. So the way we can use is we can create a class that implements row mapper of an entity type and then override this function where Spring will supply the result set being processed with the current row, and then we have to convert that into a custom domain object and return the same. An object of such a class can be given to JDBC template for further use. Alternately, you can create an anonymous object and then supply the same. To understand this, let's take an example. Let's say we want to first create a class called category so that we can get a category object based on an ID. So let's go to our Project Explorer. Let's create a class under a package called entity, and I don't have here. So let's right click on any of the package and say new class. Package name, let's change this to entity, and the name of the class is category. We give singular names for classes while the table has plural. This is just an entity class. There is nothing other than the fields over here. Private, integer or int. Integer is better because this allows null values also. However, category ID happens to be a primary key, so there is no scope of a null value here. But in general, for the rest of the fields, it's a good idea to use wrapper types rather than primitive types. So I'm going to add a second one, string category name. Third one, string description. The fourth one here is a blob, which is represented as a byte array. So I can go here and then type private byte array picture. We will add annotations to generate the constructor. So we'll say no arg constructor. Let's add a getter and setter. So we have now a class that contains all the required fields corresponding getter, setters and constructors. We want Spring to give an object of this class whenever we query a record from the table. Going back to our program where we were trying to test out the same, let's write a function saying that get category for an ID of, let's say, 1. So we don't have this function. Let's create one quickly. Make this as a package level. Let the variable name be called as category ID and get rid of this to do. The SQL statement is going to be select star from categories where category underscore ID equals to question mark. And what I need to do here is we can say template dot query for object because I want an object of category type. And if you look at the variants, this is the variant that I can make use of. The first parameter is the SQL, which is our select statement here. The second one is an object of a row mapper interface. I have to create one. And the third one is basically an object array as varargs, which is the bunch of parameters that you can supply. Let's select that. And I have here SQL, no problem. Let's keep the row mapper as is because we don't have it. We will create one now. And the argument is a bunch of arguments for each question mark. I have only one question mark. So that's the category ID. Since I don't have a row mapper, it's giving me an error. Let's manually create this row mapper as an anonymous object. And the way you do is you say row mapper. Let's press Control space to get the data type from Spring Framework. And the generic data type I want to supply here as category. Let's call it as row mapper equals to, I can create an anonymous object by typing new row mapper of category type. Open and close the bracket such that we are creating an object. And we know that row mapper is an interface, you cannot instantiate that, and hence Eclipse is giving me an error. So if I point out on that error, it says cannot instantiate the type row mapper of category. It is not suggesting a quick fix over here, but basically what it expects is an object of a class. So I can simply open and close the bracket over here saying that, hey, this is the class that implements this interface, and this is an object of that particular class. So now you see the error is different, and it says that the anonymous type has to have the unimplemented method. So now I'm getting a quick fix saying that add unimplemented method. So if I select that, you see now we have an entire class being instantiated over here. Let's put a semicolon. This is the overridden function where you can see that the map row is the function which takes a result set. So Spring supplies the result set object in its current state. For example, it would have moved the result set to the first row and then passes that object to me. This will be of practically no use. It's the row number. We won't be making use of that at all. All we're going to do is to convert the current row of this result set, assuming that it contains all the values for categories, and then create an object of category and returning the same thing. So let's get rid of this to do. Add a category C equals to new category. C.set category ID of rs.getInt of, I can say 1, or I can use category underscore ID. Likewise, C.set category name, rs.getString of category underscore name. C.set description of rs.getString of description. And then C.set picture, rs.getBytes of picture. Then return the C instead of null. Now we have a row mapper as an object, and that object we are supplying over here. When you call this particular function, Spring collects these values and then gets a connection from the pool that template maintains. And using the connection, it creates a prepared statement, and the prepared statement is supplied with this SQL. We supplied few parameters over here. Prepared statement parameters have been initialized. Prepared statement gets executed. The result set is collected. Then the result set is checked whether there is any record or not, because we are looking for a single object. And once the record exists, the JDBC template is going to make use of my row mapper, which has a function called mapRow, supplies that result set and the row number, which happens to be 1. This is my logic. So Spring is invoking my logic, and then my logic is converting the result set into a category object that is being returned. Then it comes back to this function, and inside the function, result set gets closed, statement gets closed, connection gets closed, and then the return value, what this function returned, is now returned from this particular template. So if I assign this to a variable called, say, cat equals to, you'll see that cat is a variable of category. And now that I have the category, I want to print the details of the category. So I can say here sysout and then say cat.getCategoryID. Probably I can add a label here saying that ID equals to plus. Second one, name of the category is cat.getCategoryName. Third is description equals to cat.getDescription. I won't be able to print the picture. I have to probably save it as a file and open and see. Right now this should be good enough. Let's save this and run the code, and I should be able to see an entire category object's information printed over here. Now this can be further simplified, because creating an anonymous object every time I need is something that we don't want. So what I can do is I can cut this from here and then paste it over here to make it as a member variable. The only thing I have to do is to mark this as static, otherwise I'll not be able to use it in static functions. So now you see I don't have a problem. So we can test the same by running the code. and we are able to successfully get the output. Since we are using Java 8, this whole expression of an anonymous object can be converted into a lambda expression because row mapper is an interface which has exactly one function, hence it is called as a functional interface, which means I can convert this entire anonymous object expression into just an arrow function so that this can be a function instead of an actual interface object. So this is possible only if you're using Java 8. So to do that, instead of assigning an entire new row mapper object, I just have to assign this function. So I'm going to cut this from here and then paste instead of this. But that's not the way you do it. So what you have to do for that is you have to remove this public, the return type, the function, and instead you need to assign an arrow over here. The arrow is nothing but a hyphen and a greater than symbol. Now you can see we have a function being assigned to row mapper. This function can further be simplified by removing the data types because the only function that is available in the row mapper interface has these two parameters. Java compilers are able to identify that this is a result set and this is an int. And now that I have the function simplified, I can organize my imports by getting rid of the unused imports. You press Command Shift O on Mac, Control Shift O on Windows, and you can see my imports are also removed. And now I have a simpler code, and let's try this one last time. Execute, and I get the same result without any change. Let's take one more example to list out categories in our table. So I'm going to comment this one and write a new function called get all categories. I don't have this function. I'm getting an error. I'm going to create a new one. Package level function. Let's get rid of this to do. Now that I have this row mapper as a static member variable of this class, I can reuse that over here. So I can say template.query, and then I can supply SQL statement and row mapper object. If I have any parameter, I can supply, but my SQL statement is going to be very simple. So I can straight away type here select star from categories. And this is the function that takes an SQL statement and a row mapper object and optional parameters, gives me a list of category objects. And how does Spring know that this is supposed to return a list of categories? You can see that the row mapper that we have created is based on a category data type. All I have to do is to assign this to a list. And if you see that list is going to be a variable of list of category objects. I can loop over this now by typing for category C in list and print the details of C. I can say here sysout C. I do not have a toString over here for this category object. So if I run this, it's simply going to say that they are objects of category types. But if I want the information of these to be printed, I can go to the category.java, add here @toString. But this will print all of these, and pictures are a big byte array. There will be a lot of junk characters being printed. If I want to exclude that here, I have an element. I can say here control space, and I can say exclude an array of values or include field names. So I'm going to say exclude equals to picture. So this is the field that I don't want to include. Let's go back to our program and run the same, and I should be able to get the details of the category using the toString that we added right now. Now that we have a fair idea of how JDBC template works, let us go and add more functionalities to our DAO interface, the product DAO. Typically, you write CRUD operations and queries, as I mentioned earlier. We will add many functions over here, which will be used throughout this particular training, and we will also follow best practices. So the number one function I want to have here is public void add product. This is supposed to take product as a object and supposed to throw an exception called DAO exception. We don't have the product class or the DAO exception class. That's why we're getting an error. And the product class that we should create, which represents a record from the products table over here. And this has got the fields like product ID, product name, supplier ID, category ID. Supplier ID is a foreign key to the suppliers table here, and the category ID is a foreign key to the categories table. So let's go and create these fields over there. So I'm going to go create a product class first, and this is going to be an entity class, not a DAO. So since I already have that package, I can browse and say that this is going to belong to the entity. And this is just a regular class with fields. So I'm going to add the fields, private integer product ID, and then we have a product name. We have integer supplier ID and a category ID, which is also a integer. Apart from that, we have a string that represents the quantity per unit. We have a private double unit price. Then we have private integer units in stock. We have units on order. There is also a reorder level. I believe we have one more, which is a integer discontinued. I have all the fields now. Let's add a default no argument constructor. And then we'll add a getter. We'll add setter. I don't need anything else other than the constructor getter setter. So this should be good enough for me. So I'm going to save this, come back to the product DAO, and you will see that that error is gone, but there is a throw. It's supposed to be throws over here, and now it says that DAO exception is not found. So let's go and create a new class called DAO exception. This is an exception that each of these functions should throw, so that the layer, the service layer that actually calls this function will be able to collect the DAO exception without having to worry about the underlying exception. For example, the underlying exception may be an IO exception or a XML exception or a Hibernate exception or an SQL exception. So your service layer doesn't have to worry about that. Service layer will only worry about that it's a DAO exception. Of course, we will be creating a DAO exception using a root cause. So create the class DAO exception, and this is going to be part of the DAO or DAO, so that's fine. The super class is exception. You can also make it as a runtime exception. As a good practice, application developers should throw checked exceptions. We can enable this constructors from superclass here, or I can add this later also. Let's go and finish this first. First thing is there is a warning. Let's get rid of the warning. We say add default serial version UID, and that's one required for serialization purposes. Then we want to add some constructors. Every other built-in exception classes are nothing but classes with some constructors. So somebody can construct an object of that class and throw it. So everything is in the name. There is nothing else in the exception classes. So how do we allow the users to construct an object? An implementer of a DAO class may create new DAO exception by not supplying any arguments, or by supplying some string messages, or by supplying already existing exception object so that we can convert that into a DAO exception. So to add customized constructors, we can go to source menu, generate constructors using superclass, and then choose what constructors we want. We want to be able to create a DAO exception without any argument. This is not required. This is also not required. This one allows us to create a new DAO exception using a string message. But if you're receiving an exception and constructing a DAO exception out of that, this is the most important one. So let's go and click on generate, and we don't need these to do. Let's get rid of each of these to dos. You can also press Ctrl D to delete a line. So I'm going to save this, and my DAO exception is ready. Let's go back to the product DAO. The errors are gone. Let's come back and add a second function, which is going to be public void. If I already have a product object and I made some changes, I should be able to supply and update the product. Let's call it as update product. We receive a product object, throws DAO exception, and we also should be able to get a product based on an ID. Let's call it as get product. We simply supply integer product ID and throws DAO exception. Let's write a public void delete product, which takes a integer product ID and throws DAO exception. Let's create some queries now. Number one, I should be able to get the list of all the products. So we're going to have a public list from java.util of product type. Let's call it as get all products. and throws dog exception. Get a list of get products by, let's say, price range. So we supply a min and max, throws dog exception. Let's have one more, public list of product, get products in category. We'll supply the category ID here. So we'll say int or integer category ID and throws dog exception again. We'll also have one more function. Let's copy the whole thing, paste it so that we don't have to type again. So the name of the function, let's say, for example, we want get products not in stock. So obviously I don't need a parameter, so just want to get the list of products which are currently not in stock. Let's write one more function that says, let's change this to get products on order. So how many products are on hold, on order? So they throw an exception. Let's say we want to get the list of discontinued products. So let's say get discontinued products. So I don't need this part. I think for our project, this should be good enough. If we require some more, we'll come back, add these functions again. Let's format this by pressing Command Shift F or Control Shift F, save it. And now our interface is ready. But this would now cause problems in two of the implementations we have. You can see that the dummy product DAO says that the class has many functions that it doesn't implement. Likewise, even the JDBC product DAO also doesn't have those functions. Now, there are two things that I can do. Number one, I can mark this as an abstract class. The problem is solved, but you will not be able to instantiate that in our very first program. When we try to use Spring as a factory, that program would fail. So let's not make this as abstract. The second solution to this is in the interface product DAO, I can add a body here and say provide a default. So I can say here public default void add, then that function need not be implemented in the dummy product DAO. Alternately, we can go to the dummy product DAO and then implement all the functions. So we have three choices. What we'll do is we'll go to the product DAO interface and make this as a default function. And when you make this as a default function, you should provide a method body. And the method body that I'm only going to do is to throw new exception or a dog exception, saying that this function is not implemented, method not implemented. So this kind of body we can add for all these functions. So I'm going to copy this, make this as the default, and then paste over here for each one of them. And now that I have done for all this, let's save this. One small problem may still exist, that whenever we are calling the count function in the program one, we are calling that throws a dog exception, which we have not done. So we're going to go back over here, and wherever count is that we have to handle. So I'm simply going to say here throws dog exception. Save this, and our application is now error free. In the next video, let us implement product DAO using JDBC template, provide all the functions of the product DAO interface. Now that we have this product DAO with lots of functions, let's create a new implementation using JDBC template. So first, let's get rid of everything other than this. Let's create a new class under the package core.vinod.dao. Let's call it as JDBC template product DAO. So we give an indication that it's implemented using this and it implements this. The interface is product DAO, so I can select the product DAO from the history here. Even though there is inherited abstract methods, because we have added default for each of the functions in the product DAO, we did not get that. But what we can do is we can now go to source and then say override implement methods, and then select probably all of them from that interface like this, and then say okay. We got the functions now. Each of these functions must be implemented using the JDBC template. So we want Spring to automatically inject a JDBC template object. And if you remember previously in app config 4, we do have a JDBC template over here. And if I can add a component scan annotation over here, it can even scan the DAO classes that are over here. JDBC product DAO is a component because we marked it as @repository, but its name is JDBC DAO. Let's also give a name here, probably just DAO or JT DAO. So let's give here @repository and let's give it as JT DAO. Import the same. And now I can do an auto wiring here for JDBC template. Let's give a private JDBC template. Let's call it as template. Let's import the same first and then add an @auto wired annotation. You can say for the sake of demonstration required equals to false, but in practice we don't want to give this at all. Let's keep that in mind and go back to app config 4 and say that we want to scan the DAO package. So we say @component scan base packages equals to an array of packages, but the only package that I want to mention over here is co.vinod.dao at this time. Later we will add more packages as we go forward. Let's go back to our JDBC template product DAO, and now that we have this template as a private variable, I want to use them in each of these functions. The first function that I want to make use of that is this, where I want to add a new product. To do that, let's get rid of the to do and the default code that got generated over here. Let's call the template.update function, which takes an SQL command and a bunch of parameters. So first let's create the SQL command, which is nothing but insert into products and values. I have 10 columns. I have to give 10 question marks separated by comma. So I got 5 here. So I'm going to copy this and paste the same. So this is my actual insert command, which can be used in the template.update. Let's give SQL here. The values for each of the question marks come from this product. Let me rename this as P so I can easily call that with P dot. So I'll say P dot get product ID. That's the first one. Second one is P dot get product name. Now the sequence of these values that I give must match the columns that are there in the products. If you're not sure of that, then you can also give the list of columns over here like this. But let's go back to our DB and see that it's the product ID, product name, supplier ID, category ID is the next two values. So I'm going to give here P dot get supplier ID, P dot get category ID. Then we have P dot get quantity per unit. After that, unit price, units in stock, units on order. P dot get unit price, P dot get units in stock, P dot get units on order. Then we have P dot get reorder level and P dot get discontinued. So these are the values for 10 question marks that I have given over here, and my add product function is complete. One thing you also have to see that our function says it throws a DAO exception, but the only two lines that I have here, they don't throw any exception of that kind. In fact, if you look at the template.update function, the update function signature says that it throws an exception called data access exception. So let's have a look at the same in type hierarchy. So I'm going to press Command Shift H and type data access exception. This is coming from org.springframework.dao package. And if you see that there is a bunch of subclasses for that. In fact, this is the exception that is thrown by any of the Spring data related classes such as JDBC template, Hibernate template, or in the older version something called JPA template. All of them, any function you call, they actually create an object of data access exception and throw that. For example, if you have a primary key violation, there'll be a more specific exception involved, but that exception is inheriting from data access exception, which inherits somewhere from runtime exception, making it as an unchecked exception. So what typically we have to do is to surround these two lines with a try catch block, catch that exception, and then rethrow that exception as a new DAO exception. So that becomes very redundant code in all these functions. So the try catch block is something that becomes duplicate code or redundant code, which we can avoid by using a concept called aspect oriented programming. Now notice that it is only the product DAO implementation here, but in our application we may have 10 to 25 different DAO implementations, each of them having 10 to 25 functions themselves. In each one of them, writing try catch block only to rethrow that as DAO exception is an unnecessary code, which Spring can handle that automatically. That we will look into when we cover aspect oriented programming. So for now, even though the lines of code that I write here, they do not throw DAO exception, our signature still says DAO exception, which we need to fix, which we will do during our AOP session. So let's move on to the update product. The update product, first let's come with a SQL statement for update products set. I want to set each of the columns like product underscore name equals to question mark, supplier underscore ID equals to question mark, and for all the columns where the primary key value equals to question mark. Now that I have the complete SQL update command, let's say template.update and supply the SQL command. And the parameters for this is almost the same as this, but except that it starts with a product name and then ends with the product ID. So I'm going to copy this one, paste over here, put a comma, and then the p.getProductID. So I'm going to paste it over here, put a semicolon. Now my update command is also ready, except that I have here the variable called product. It's supposed to be p. Let's go and see if I can get the product. To get a product, I need the row mapper. So what I can do is I can create a row mapper object as a member variable over here. So let's create a private row mapper of product type. Let's import this from Spring, and this is the product type. Let's call it as PRM for product row mapper equals to, I can say RS for result set and I for the current row number, arrow and a curly bracket to represent something. I need to return a value from here. Let's first create a product P equals to new product and then copy the value from RS to this P. At the end somewhere we say return P. You can see that the row mapper is not giving an error, except that I have to copy the values from the result set to this P, which I'll do now by typing p.setProductID rs.getInt of product underscore ID, and the same thing I have to do for the rest of the fields. So now we have this PRM, which is a product row mapper. We can now supply this to all our queries and the get function over here. Spring can make use of that product row mapper, convert the current row into a product object and give me the product object which I can further return from here. So let's go and add the select statement first. String SQL equals to select star from products, where product underscore ID equals to question mark. And now I can simply say here return template.query for object and then supply this SQL row mapper and the ID. That's this over here, SQL PRM and the product ID as the argument. So this will automatically construct a product object based on this particular result set data and the prm.mapRow function. Let's add the delete product. And we want to make sure that the delete product only does a soft delete, not a hard delete. For this, it's not going to be a delete command. Typically, if you want to use a hard delete, you would say delete from products where product ID equals to so and so. In our case, we're going to say discontinued equals to true, which is nothing but 1. So we'll just use here and string SQL equals to update products set discontinued equals to 1, where product underscore ID equals to question mark. And now I can say here template.update and then the SQL command and then the parameter which is product ID. So this will actually do the soft delete, meaning the product record exists, but it's been discontinued. So typically when you get the list of all the products, we should not get the list of products which are discontinued. But in our next function over here, where we are supposed to get the list of all the products, we do send the list of all the products, including the ones that are discontinued. But in case if you want to use this function for displaying the data to an end user, such as a customer who is planning to buy the products, you should not be displaying the discontinued products. We're going to develop an application for the back office operations where an organization employee is going to work with these products, not the actual customers. So let's go and write the SQL select statement. So string SQL equals to select star from products. And then we say template dot query, and then simply supply this SQL and then the PRM, which is the product row mapper. We do have to return the value that this function returns, which is nothing but the list of products itself. The next one is an extension of the same, so I'm going to copy and paste this over here. But I also have to say here where unit underscore price between two question marks, like this. The SQL has parameters, so after the product row mapper, we can supply this min and max, and we get the list of products between those two price ranges. That is what we are further returning from here. What about the get products in category? It's pretty much the same as this, so I'm going to copy and paste this over here. And then this query will change as where category underscore ID equals to question mark. And the category ID, whatever I receive here, will be the parameter for this template.query. The function is over. This one, get products not in stock, is another extension of the previous one. Let's copy paste the same over here. This time the query is select star from products where units in stock equals to 0. So that is when it says products are not in stock. So we'll add that over here. No parameters required because the query doesn't have any question marks. The same thing I can copy and paste for the next one, which is the get products in order. Let's copy paste. The only change here is where units on order is greater than 0. That means there are some customers who have placed orders. That's why these products have a units on order greater than 0. No question marks. There is a small typo here. It is supposed to be units in stock, not unit in stock. That is done. Discontinued product again is pretty much same as this. Copy paste over here. So select star from products where discontinued is true. So discontinued equals to 1 and no parameters over here. The last one is a bit different here. So let's first write the SQL command. So string SQL equals to select count of star from products. But when you return, it is not the template.query, but it's the query for object because we want a single value this time. And the SQL is that the required type is long.class. That way, JDBC template converts this numerical value into a long and returns the same thing over here. Let's save this and ensure that there is no syntax errors over here. In order to test this, let's go and create a new program. So let's go to the Project Explorer. Under Programs, let's create a new class. Let's call it as P03 testing JDBC template product DAO. And this is supposed to have a public static void main where we're going to create a new Spring container by typing annotation config application context ctx equals to new annotation config application context. But the class name that we're going to supply here is going to be appconfig4.class, which is the modified version now. So if I go to the appconfig4, we are doing a component scan here. So DAO package has got two components right now. So this is one component because we have got a at repository. This is another component because we have a at repository there also. But this one is actually the JT DAO. That's the new one that we have created. The dummy product DAO is not a repository or a component, so that doesn't qualify for component scan. So appconfig4 does the component scan, and then it also creates two beans, data source and the JDBC template. JDBC template, we are doing a manual wiring of the data source. However, the JDBC template itself is wired automatically to our JDBC template product DAO class, using which we are doing all these operations. So we'll test one or two functions of this particular class. So let's go to our new program and close the rest of them. Let's say somewhere down the line we have to say ctx.close. Now here we will call a couple of functions. First thing we want to do is to say we want a DAO from ctx. So let's say ctx.getBean. The name of the bean is called JTDAO and the required type is product DAO.class. And we have to create a new variable. I press command 1, enter, and that creates a product DAO. So let's get one product from the DAO by calling get product, supply an ID. Let's give 1, create the P, which is the product object now. I have to either handle the exception by putting a try catch, or I can throw away all the exceptions from the main function. So for the time being, I'm going to just throw away the exceptions, not worrying about what happens over there. Let's print system.out.println P, but I don't have a toString. So let's go to the product.java and add a toString. So I'll say at toString. All these will be included in the resultant toString function. So if I save this and run the code, you should see the details of product number 1, which is chai, supplier ID, category ID is 1, product quantity per unit is 10 boxes into 20 bags, and so on and so forth. So we got the product. Well, let's say I want to update the product price. So if you look at the product price right now happens to be $18, and I want to see if I can update that to $19. I'm going to say here p.set unit price to whatever its unit price is there, plus $1, so that's going to be $19. And then I have to say here DAO.update product of P. Although the implementation here is updating all the fields, we are only interested in updating the unit price. The rest of them are already available in the product P. We did not change any of them. That everything else remains the same, only the price got changed. So this is supposed to update the product price alone. Now what we'll do is I'll give a sys out here saying that price updated, but we will go and check in the DB console whether it is updated. So I'm going to just run this once, and it says here the current value is $18. You can see that it says $18 there, and it says price updated. Let's go to the browser and check the same. So I'm going to click on the products over here. So that gives me a select star from products. Click on run. The very first one, you can see that the unit price is $19. One thing you may see here is that I did not do any commit, but it got automatically committed. This would be a scope of a problem because I won't be able to customize the transactions. For example, what if I want to update 3 or 4 different products using 3 or 4 different DAO.update functions and commit all of them together? If one of them fails, I want to roll back all of them. Now this is where the transaction manager comes into picture. But at this point in time, there is an auto commit enabled. That's why we are able to see. Let's go and run this one more time and see if that is increased to $20. So let's go back and run this again. And you can see that it's been updated to $20. Let's also get the list of products between a price range. Let's try here by typing list equals to DAO.get products by price range. Let's give as $50 to say $200. The list is supposed to be created. Let's press Control 1 or Command 1 and get that done. We got the list. I can say something like there are list.size, that will give me the number of records, products between $50 and $200. Let's execute that and check it out. So it's supposed to tell me something like around 6 products, I guess. So there are 6 products between $50 and $200. We can just check it out over here where unit price between 50 and 200. Control enter will actually execute that query here, and these are the products that belong to that price range. One last thing we will check is list equals to DAO.get discontinued products. sysout, there are list.size discontinued products. So save this, execute the same, and it says there are 8 products that have been discontinued. And let's go back to the browser and verify the same, where discontinued equals to 1, execute, and you can see there are 8 rows where the discontinued happens to be 1. As a small exercise, I would like you to try testing the rest of the code, and I hope I have not made any mistakes in this particular implementation, and you will be getting the output for each one of them. Let's take a very simple example to understand the working of Hibernate. To start with, we have to add Hibernate jars to our project. So let's go to our pom.xml, scroll down to the list of dependencies we have. This is the last one. Let's go to mvnrepository.com and search for Hibernate. And the very first one that I see here is the Hibernate core. I'm going to select that. In that, the latest stable version that I want to select is the 5.4.10. Click this to copy, come back to my pom.xml, paste it, format it, and save it. As soon as I save, the relevant jars are downloaded from the net or from my local repository to my project. So you can see that the Maven dependencies now have the Hibernate related jar files. With these jar files, we also have access to the Java Persistence API annotations, which we're going to apply to our category and product. For now, let's go and select the category.java and make this as an entity class by typing @entity, Command-Shift-O or Control-Shift-O on Windows to import. Notice that there are 2 entity annotations. One comes from Hibernate, which is deprecated, so we don't want to use that. The other one is the JPA annotation. We want to use that. In case if your class name is different than the table name, in our case it is true, we have to use another annotation called @table. Again, import it from JPA, where we'll say name equals to categories, which is the actual name of the table. Every entity class must have at least one of the field mapped to the primary key. In our case, the field category ID is supposed to be mapped to the primary key category underscore ID. So we'll say @ID. And then to say that the column name is different than the field name, we'll use @column. Name equals to category underscore ID. The same thing we also have to do it for category name. Description and picture, however, are same as the column name, so we don't have to do anything else. Let's save this and close this file. Now let's create a program to retrieve the list of categories or probably add a new category. So let's go to the programs package, right click, new class. I'm going to name it as P04 Hibernate example. Add the main function, say finish. Let's full screen this and get rid of the to do. Hibernate depends on a file called Hibernate CFG.xml, which contains properties of the DB information. Instead of using a Hibernate CFG.xml, we can supply the same properties using the properties object. So let's create a properties props equals to new properties. The properties comes from java.util package. Let's add those properties. Props.set property. One of the key is hibernate.connection.driver underscore class. The value is arg.h2.driver. Similarly, you have props.set property, hibernate.connection.url. The value happens to be the URL of your DB, which I can get from my H2 console, and then copy the value from here. Come back to Eclipse and paste the same thing over here. Another one is basically the username. I can say hibernate.connection.user. The value is SA. Props.set property, hibernate.connection.password, which is blank string in our case. Apart from this, one important Hibernate property we have to supply is the dialect class, which takes care of generating the relevant SQL commands for each of the operation that we do. And that happens to be props.set property, hibernate.dialect. And for H2, it is arg.hibernate.dialect.h2dialect. So these are the minimum properties that we have to supply. Once you do this, you create a configuration object. Let's call it as CFG equals to new configuration object. This represents a Hibernate configuration. It is an empty object. We have to supply these properties by typing set properties, and props is the argument. Now we have told Hibernate about the database information. We also have to say what are the entity classes that Hibernate should manage. So we'll say cfg.add annotated class, and then we say here category.class, which is coming from our entity package. And now that our configuration is ready, we can create a factory. Let's call it as cfg.build session factory, which returns an object of an interface called session factory. Let's create the same. Now, once you have the factory, you can always say session equals to factory.open session. This returns a session object, which is equivalent of a DB connection. Once you have the session, now you can start retrieving either one single object or a bunch of objects using query, or you can use a transaction to add a new category, etc. So let's take 3 different examples over here. First, I want to get a single record. So I'll call it as get. The category object is what I want. The ID is 1. So for which I get the category object. So I can type here C1 equals to, press command 1 or control 1, press enter, and you see you get the category object. Let's print out the same and see if this is okay. At the end of your program, you always have to close the open resources such as session and factory. Let's save this, execute the program to see if we get the result, and we got it. Let's say we want to get the list of all category objects. Let's put some separator here between 2 outputs. Now I say here QRY equals to session.create query. We'll select the string HQL and the result type. The HQL is going to be very simple. I'll say from category. Result type is category.class. The query object is now going to give me a list of category objects whenever we say give me the result, which is what we do now by typing qry.getResultList. The return value, let's assign this to a variable called list and create the same by pressing command 1 or control 1. Once you got the list of category, we can say here now for each category C in list, let's print out C itself. Save it, run the code, and you can see we got the list of all 8 categories that we have. Let's say we want to add a new category. Let's create category C2 equals to new category. Let's add C2.setCategory ID of 9. C2.setCategory name of, let's call it as stationaries. And C2.setDescription of, let's say paper, clips, etc. Now I want to save this C2 to the database. First thing you have to do is to say session.beginTransaction. This creates a transaction object which you can assign to tx, which is going to be a new variable. Press command 1 or control 1 on Windows to get this auto-generated. Tx represents the active transaction. Somewhere I have to commit. What I can do is I can say try executing session.persist of C2. If this is successfully done, let's call tx.commit. But in case of an exception, let's handle that exception by going to the catch block and then say tx.rollback. And let's also give appropriate messages saying that new category added, or I can say there was an error while adding new category. So if I run this first time, I should get this message. If I run the same thing again, because this is a primary key, I will not be able to add it second time, and it should go to the catch block and tell me that there was an error. Let's also add this separator after the list being printed. Let's save it, run the code, and see the result. So you can see that I got new category added. I can go and verify the same thing in our DB. I'll check what are the various categories that I have here. And you can see the 9th one is stationaries, paper, clips, etc. Let's go back here and run the same thing again. And this time, because the primary key violation happens, there will be an exception, and it says that there was an error while adding new category. So these are the typical steps involved in working with a Hibernate application. In the subsequent videos, let us see how Spring can help simplify this Hibernate code. To continue with our project, let's add annotations to our product.java, as well as let's create another entity class for the suppliers table, and let's call it as supplier.java. So let's go back to our Eclipse, close this program, right click on entity and create a new Java class called supplier. Press enter. This is going to have fields corresponding to column names in the suppliers table. Let's go and create the same private integer supplier ID. That's the primary key. Then we have a company name. We also have contact name, contact title, address, city, region, postal code, phone, fax, homepage. Now that I have all the fields corresponding to the column names, let's also add the annotations such as @no-args constructor, @setter, @getter. Now let us add annotations that are required for Hibernate. So @entity and @table name equals to suppliers. Let's import the same from javax.persistence package. Let's make supplier ID as the ID column, as well as since the column name and the field names are different, let's add @column name equals to supplier underscore ID. Let's import @column and copy paste the same thing for maybe rest of the fields. So here it's going to be company underscore name. This is the contact underscore name, contact underscore title. Address city is same. Postal code happens to be postal underscore code. Region, country, phone, fax are okay. The home page happens to be home underscore page. Now that we have got all of them, let's go to the product.java. So let's first add @entity and import the same. @table, import the same. Table name equals to products. Let's also add @id for the product ID. Then we have here @column, because the name of the column here is product underscore ID. Let's copy this, paste over here. This is basically product name. We will also add to supplier ID and category ID because they are anyway columns. So let's add here supplier underscore ID as well as category underscore ID. This is quantity per unit, unit underscore price, units in stock and units on order. And one last is reorder level. And the column discontinued has the same name as the field discontinued over here. So we don't need to have @column. Now this should be okay. However, we wanted to actually have category object as well as supplier object instead of supplier ID and category ID. We can also have both of them mapped to the same column, but we may have to make one small change. First, let's add a field corresponding to the supplier. Let's create a private supplier. This is not a column mapping, but it's a many to one column mapping. We say that many products have been supplied by one supplier. So we can say @many to one. We also have to say @join column. Name of the join column happens to be supplier underscore ID. Now this is where we will run into problem because both @column and @join column, both of them correspond to the same column, which is a problem. In which case we can always say, hey, one of them is read only. It cannot be used for insert and update. So it's your choice. Generally, we will give it to the column mapping here. We say insertable equals to false, updatable equals to false. Without this, there'll be an error while running the code. The same way, I'm also going to have here one more private category object of type category. We'll also say this is a many to one, and we'll also say @join column. Name of the join column happens to be category underscore ID. Once again, we have the conflict of column mapping over here. So one of them have to be made read only. So the same thing I'm going to copy and paste to @column over here, so that the conflict of column mapping is resolved. Now that our annotated classes are ready, let's create a Hibernate template to work with Hibernate in our Spring applications. In order to work with Hibernate template, we have to first add required jar files to our project. So we open the pom.xml and copy one of these Spring dependencies and paste it, and change this to Spring ORM, save the file, and now you'll see that Maven dependencies have been updated with Spring ORM also. With Spring ORM in our build path, if you press Command-Shift-H or Control-Shift-H on Windows and look for Hibernate template, you see that there is a class called Hibernate template coming from Arc Spring Framework orm.hibernate 5. This means that the current version of Hibernate template that we're using works with Hibernate 5, and that is what we actually have used also. So if I open this in the type hierarchy, you will see that the Hibernate template has many functionalities. One of that you can straight away see here is that Hibernate template takes session factory as an object or as a dependency. There must be a set session factory somewhere at the down. You can see it's here. Basically, a Hibernate template depends on session factory. Without supplying a session factory, even if you create a Hibernate template object, you will not be able to use that. In Spring 5.2 onwards, there are a lot of changes and a lot of functions have been deprecated over here. That might be a bit of challenge for us. We will see how to overcome the same. But first, let's create an object of Hibernate template which depends on session factory. We know that the session factory is an interface. So Spring provides a mechanism to create an instance of session factory. And this is done via the class called local session factory bean. So again, if I press Command-Shift-H and type local session factory bean, you see that there is a class which works with Hibernate 5, and this one can produce a session factory object. In fact, this one has a function called getObject which returns a session factory. So once you configure this in your app config, Spring will automatically collect this bean object. Wherever session factory is required as a dependency, Spring will inject the return value of this getObject function. To understand the same, let's go to our app config 4 and create a local session factory bean somewhere at the bottom. Let's write a function public local session factory bean. Let's call it as session factory. This session factory can be injected with a data source because somewhere we have to specify the DB information to the session factory. We can simply say here data source, which becomes a dependency. So Spring will automatically inject a data source which we have right here into this variable called data source. We have to create an object of this type. Let's create a variable. Let's call it as LSFB equals to new local session factory bean and return the same object. Let's make some space over here and configure this local session factory bean with the Hibernate configuration. So the first thing I can say is lsfb.set data source to the one that we got. We got the dependency injection over here and we are doing a manual wiring. Next, we can say lsfb.set annotated classes. You can see it takes a varargs of annotated classes. Right now I have 3 of them. Let me full screen by pressing Ctrl M. The first one, let's say category.class, product.class, as well as supplier from the entity package. So we have added 3 of them. Just in case if you have multiple, you can go on adding more and more annotated classes over here. We also have to set additional Hibernate properties such as the dialect and optional show SQL format SQL. For this, let's take properties, props equals to new properties. And then I say props.set property. Now the key here would be hibernate.dialect. The value is arg.hibernate.dialect. dialect.h2 dialect. In case if you are changing your DB, make sure to change this dialect also. Props.set property hibernate dot show underscore SQL. The value of true will display the SQL commands. Props.set property hibernate dot format underscore SQL. Let's set this to true for the time being. Now we can say lsfb dot set hibernate properties and then supply this props as an argument. We now have a fully configured local session factory bean object. All I have to do is to annotate this as @bean so that Spring during the container creation will collect this value and keeps it in the memory. And whenever you need a session factory as a dependency, Spring will call the get object function of this bean and injects that to your dependency. So let's go and use this in a Hibernate template. Let's create a public Hibernate template. Let's call it as Hibernate template, which has a dependency on session factory. Let's call it as session factory. All I have to do is to return new Hibernate template and supply this session factory as an argument. Make sure to import the session factory by pressing Command-Shift-O or Control-Shift-O. And one last thing, @bean, so that Spring collects the Hibernate template object, and whenever you want, it can give it to you. Now, typically, this Hibernate template will be injected to our DAO implementation. Just to check if our Hibernate template can give the data from the DB, let's go create a new program under the programs package, new class. Let's call it as P05 testing Hibernate template. Let's add the public static void main functions, get rid of this to do. First, let's create a Spring container by creating a variable of annotation config application context. Let's call it as CTX, and CTX equals to new annotation config application context. We have to supply an app config. Let's supply the app config 4.class. Let's say ht equals to ctx.getBean, and then say here we want a bean of Hibernate template type. Since there is only one bean of Hibernate template, there is no conflict and it simply gives me an object of Hibernate template. Somewhere we have to close the CTX. Let's close it in advance. Using this ht, we can now call the Hibernate template functions like get, for example, to get an object of an entity class based on a given ID. Let's give 1 as the ID, which is supposed to give me a category object. Let's press Command 1 or Control 1 to auto-generate this variable. And then we say here sysout C1. If everything is okay, we should be able to get the category 1 details. Let's run this and check it out. And now you can see we are able to see the generated SQL command because we said show SQL true. It has been nicely formatted because of format underscore SQL. Finally, we are able to see the category 1 whose details are retrieved from the database. Now that we have a fully configured Hibernate template object, let us create an implementation for our product DAO using the Hibernate template. Let's right click on our package, new class, and let's name this as the Hibernate template implementation of product DAO. Add the interface called product DAO. Click on OK, finish. Since all the members of product DAO have default access modifier, none of them have been generated automatically. So let's go to the source menu, override implement methods, and choose that we want all the functions of product DAO to be implemented over here. Let's go up, add @repository so that this is qualified for component scan. And we will also give this as htDAO this time. We'll also inject or auto-wire the Hibernate template that we have. Let's call it as private Hibernate template. Let's give a name called template itself, and we'll add @auto-wired. Once again, for the demonstration purpose only, we say required equals to false so that our other programs work without any problem. In practice, we will not be using this at all. The first thing that we want to do here is to add a new product, and it's as simple as template.persist and then supply the product object. Just one liner. The only thing that we have to take care is exception handling, since the persist function throws data access exception, which is a Spring exception, whereas we are saying our function throws DAO exception, which has never been thrown from here. We will handle this using aspect-oriented programming, but for now, let's just leave that as it is. Updating a product is very simple. You simply have to say template.merge and then supply the entity, which is our product. Getting a product, let's do a return template.get. The class is product.class. ID is nothing but the argument that we got, which is the product ID. Here, let us do a soft delete. For that, first I'm going to say p equals to get product of product ID. So we have a function here. We are calling that function that's supposed to return a product object. So p is going to be a product object. All we are going to do is to say p dot set discontinued as 1, and then we'll say template dot merge and supply this p, which is the entity object. So we basically say that this product is no longer going to be continued when we update this, and this way we have achieved the soft deletion of the product. To get the list of products, we can have many functionalities. First, let's have a look at Hibernate template in our type hierarchy. If I go to the type hierarchy here and look at the history here, so we have the Hibernate template. There are functions like find. This takes HQL as an argument, and in case HQL has question marks, it takes those as parameters. However, you can see that it has been deprecated from, I believe, version 5.2 onwards. So we can't use the Hibernate query language at all, but we can use something called criteria API. Since this is deprecated, let us use something called find by criteria. So I'm going to get rid of this code over here. Let's create a detached criteria. Let's call it as DC equals to detached criteria, and we have to supply an entity class here. So the entity class here is the product.class. So whenever we execute this criteria, the criteria is going to give me a list of products. And all I have to do is to template.find by criteria and then supply this DC, return this value, which gives me a list of products, but it says here that the return value is a list of object, whereas I have a list of products. So it says that you have to cast it. Let's do a casting, and the problem is solved. Even though this is a warning, we can suppress that for sure, because we know that our detached criteria is always going to give me a list of product. Since this warning is going to be there in almost all these functions, I'm going to cut this from here, paste it at the class level so that the warnings are suppressed all over. Now let's copy paste the same thing for the next function, where we want to get the list of products between a price range, min and max. So before actually we say give me the list of products, we will set those parameters also here. We have to say here now dc dot add, and we can say restrictions dot between. The property is unit price. Note that it is a property, not a column. And this is the min and max. So we basically say that we are adding a condition to this detached criteria. So while it is supposed to give me all the products, now it is going to filter out based on this condition. So when you actually execute this criteria, the criteria has one condition that will be added as a where condition in our SQL select statement. To get the list of products in a given category, we'll copy the same and paste over here. We do have a property called category ID. So I can simply say here EQ, this is going to be category ID. And the value here is nothing but the argument that I received. I'm going to supply the same thing over here. Same way, I can also specify units in stock. So the units in stock is the field, and the value happens to be 0. The next one is get products on order. So wherever the units on order is greater than 0, so I can say here greater than, so GT for greater than. Here I'll say units on order greater than 0. If you want greater than or equal to 0, you will say GE instead of GT. In this case, GT makes sense. The discontinued products, once again, it's equals to is the condition that we want. We're going to copy paste over here. This is discontinued is the property. The value is 1. In case if it's discontinued, it's going to be like true. So we are saying select star from products where discontinued equals to 1, and then we get this result. The last one is a little bit different, so let's make some space over here. Let's get rid of this to do. We want to first create a detached criteria, so let's copy that one. But this includes a projection because we are not interested in the entire product object. We are only interested in the row count. So we can say here dc dot set projection, and then we can say here projections dot row count. That will actually give you the number of rows in the product. Now we have this. We can execute this query by typing template.find by criteria. But its return value is not going to be a list of product. It's going to be a list of long. Even though I have a 1 row, 1 column, find by criteria always is going to give a list. But since our row count is a long, so it's going to give you a long. So I have to get this object. So let's call this first. This is going to be a list. So I can say here get of 0, which is nothing but a long. We can actually cast this by pressing Ctrl 1 or Command 1, add cast to long. You can see now almost all the functions here are implemented with just 1 or 2 lines of code. And that's how Spring makes Hibernate code very simple. In the next video, let us test out this DAO implementation and check out the results. Now that we have a Hibernate template product DAO, let's test the same by creating a new program under the programs package. Let's right click on the package, new class, and let's call it as P06 testing Hibernate template product DAO. Let's also add the public static void main here. Click finish and get rid of this to do. Let's start by creating an annotation config application context, which is the Spring container. Let's call it as CTX. And let's also initialize the same using app-config4. So CTX equals to new annotation config application context. The argument to that is app-config4.class. And somewhere down the line, we have to close this. Let's close this in advance, ctx.close. CTX contains different implementations of product DAO. So we'll get one of the implementation, will supply the name as htDAO and the required type is product DAO. So we don't have to do the casting. Let's assign this to a variable called DAO and press Command 1 or Control 1 on Windows to auto-generate this data type. Now that we have DAO, let's test some of its functionality. So to start with, let's say list equals to DAO.getAllProducts. GetAllProducts is going to return a list of product objects. So that's what actually it says. The error now is about exception. All of our DAO methods throw DAO exception, which is a checked exception. Right now we will throw all the exceptions, but later at some point in time we will handle them. We got the list of products. Let's just print out saying there are so many products in our database. So there are list.size products. Let's check it out by running the code. And it says that there are 77 products. Let's say we want to declare two variables, min equals to, let's say 50.0, max equals to 200.0. And then we want to say list equals to DAO.get products by price range, and then min and max we will supply. Let's print a message saying there are list.size products between, let's say $min and $max. I can use the printf here, but sometimes because the logs are printed in a different thread, they get mixed up. So I'm just concatenating and printing it as one single string. Let's run this and check. And it's supposed to say there are 6 products between the price of $50 and $200 range. Let's get the discontinued products. So list equals to DAO.get discontinued products. I can again copy this and paste and say there are so many discontinued products. Check it out by running the same. So we're getting 8 discontinued products. Let's get the total product count using the count function, although we printed that over here. Let's say PC equals to DAO.count. PC is a long, let's create that. And again, I'm going to paste the same, but instead of list.size, I'm going to just say PC. Once again, we should get, there are 77 products. And we did get the output. Let's retrieve a single product. So I can say P equals to DAO.getProduct. The ID, let's apply 1. Press Command 1 or Control 1 to auto-generate the declaration. Now I'll say here P.getProductName, and the price of that happens to be P.getUnitPrice. Let's run the same to see if we get the chai with $20. So it's 22 because we increased a couple of times in the previous programs. And you can check the rest of the functions also. But if you try any of the insert, update, delete operations, you may run into a problem. Let's give it a try by typing P.setUnitPrice to P.getUnitPrice plus 1. Let's increase it one more time. And then I want to update this product. So I can say here DAO.updateProduct P and try running the code. So at line number 37, you should see an exception. So you can see that the line number 37 has a problem. And it says that write operations are not allowed in read-only mode. Basically, it says that you haven't enabled the transaction management. For example, if I go to the update product function over here, you can see that we never begin the transaction and we haven't committed or rolled back the transactions. So we simply call the template.merge. The template.merge is a Hibernate template function which internally maintains a session factory because we have injected that. And via the session factory, it will obtain a session, and that session has not started any transaction, because of which we are getting an error. Unfortunately, we don't have access to the session object over here, so we can't say session.begin transaction or session.commit transaction. Now, there are workarounds to do that, but basically we don't want to do the transaction over here, because if I do the transaction over here, then we have to do the transaction here also. The transaction has to be done even here also. And the transaction have to be done in all other kinds of DAO like customer DAO, supplier DAO, employee DAO. And in case if my application has 25 to 50 different DAOs, in every other place I have to handle the transactions. So this is called code scattering, because the same type of code where begin transaction, commit transaction, rollback transaction is now scattered in n number of places. Also, the transaction management code is being tangled with your code. In addition, there might be other aspects such as security or logging or data type conversions, error handling. So many things get mixed up over here, which is called code tangling. So there are two problems in these scenarios. One is called code scattering and the other is called code tangling. We can avoid both of these problems using the concept of aspect-oriented programming, which is the topic of our next section. So for the time being, let us just comment these two lines and not worry about the transactions. Once we understand the aspect-oriented programming, we will understand what is transaction, how actually AOP helps that, and then handle all transactions of our applications. Aspect-oriented programming is about separation of concerns. To understand the basic concept of AOP, let's run this program again. But before that, let's also add a print statement here saying DAO is an instance of what kind of class. So let's type here system.out.println. I'll say DAO is an instance of, and then I'll type DAO.getClass.getName. It should ideally say that it's an instance of Hibernate template product DAO. Let's run the same and check it out. As you can see that it's giving me a result saying DAO is an instance of core.vinod.dao.hibernate template product DAO. Let's first pictorially represent the same. So when we run the application, we do have a Spring container inside of JVM. So this is, let's assume it's a JVM. And we have here a CTX, which is a reference variable that refers to a Spring container. And inside the Spring container, we have here something called DAO. So an instance of our Hibernate template product DAO, which we named as HT DAO. And we also have a reference of DAO type or a product DAO that currently refers to this particular object. And that's the reason why it says that DAO is an instance of co.vinod.dao.hibernate template product DAO. With aspect-oriented programming, what we do is we want to make this DAO refer to an object which we call as a proxy object. So this proxy object is automatically going to be created, which will internally have a reference to this product DAO that we have already pointed to. So which means that DAO is no longer pointing to the HTDAO directly. DAO will refer to a proxy object. The proxy object also maintains references to another object called as an aspect, and aspect maintains functions which we call as advisors. So while the HTDAO object is called a target object here, which has the actual business logic functions that we have, such as update product or count, etc. Whenever we call the DAO dot a business logic function or a actual implementation function, let's say I call DAO dot count. Now the function is delegated to the proxy. The proxy checks this aspect. Is there any advice that it has to execute? If the answer is yes, first the advice function will be called, then the actual control is given to the count function. Once the count function is finished, it's going to come back to the proxy. Proxy checks again, do we have any other advice? If there is any advice, that is a function that gets called. Once that function is called, comes back to the proxy. Proxy then will give the return value of the original count function back to the DAO. So what it has done is it has intercepted the DAO.count function and has done some jobs. This is where it is important for us to understand some of the keywords. Let's start with a terminology called aspect. Now, aspect is a modularization of a concern that cuts across multiple classes. Transaction management is a good example of a cross-cutting concern. In Spring AOP, aspects are implemented as just regular classes annotated with @aspect. The terminology join point is a point during the execution of a program, such as the execution of a method or handling of an exception. In Spring AOP, a join point always represents a method execution. While aspect is represented as a class has a bunch of functions. Advice is an action taken by an aspect at a particular join point. Different types of advices include around advice, before advice, after advice, as well as after throwing advice. Many AOP frameworks, including Spring, model an advice as an interceptor, maintaining a chain of interceptors around the join point. You can think of join points as a bunch of functions, but in our implementation class, you may have n number of functions. We're only going to apply our advisors to certain functions. The point cut is a predicate that matches the join points. Advice is associated with a point cut expression and runs at any join point matched by the point cut. For example, the execution of a method with a certain name or certain parameters or certain return values. The concept of join points as matched by point cut expressions is central to AOP, and Spring uses AspectJ point cut expression language by default. So in Spring AOP, there are two objects coming into picture. Number one is the actual target object. Target object is an object which is advised by one or more aspects, also referred as the advised object. Since Spring AOP is implemented using runtime proxies, this object will always be a proxied object. And what is a proxy? AOP proxy is an object created by the AOP framework in order to implement the aspect contracts such as advice method executions and so on. In the Spring framework, an AOP proxy will be JDK dynamic proxy or a CG-lib proxy. Depending on when exactly an advice is applied on a particular target function, the advices are divided into four types. Number one is the before advice. This is an advice that executes before a join point, but it does not have the ability to prevent execution flow proceeding to the join point unless it throws an exception. Number two, after returning advice. This is an advice to be executed after a join point completes normally. For example, if a method returns without throwing an exception, then this advice gets executed. Number three, after throwing advice. This is an advice to be executed if a method exits by throwing an exception. Now, if you remember in our Hibernate template product DAO and even the JDBC template product DAO, I mentioned that each of these functions must have a try-catch block where I receive an exception of data access exception thrown by a particular function here, and then I have to rethrow that as a DAO exception. Now, this can be handled by using the after throwing advice. Another advice is the around advice. The advice that surrounds a join point, such as a method invocation. This is the most powerful kind of advice. Around advice can perform custom behavior before and after the method invocation. It is also responsible for choosing whether to proceed to the join point or to shortcut the advised method execution. So let's come back to our Eclipse and then configure aspect-oriented programming such that when we get the product DAO, we get the proxy object. Now, once we get the proxy object, we will also intercept the method calls, such as, for example, I may be interested in intercepting all the functions that start with get, or probably I want to intercept a function which takes two double parameters, and in case if min is greater than max, I want to swap it and then pass it onto the actual target function, and few other examples. The very first thing that you have to do is to add the aspect-oriented programming libraries. If you expand the Maven dependencies, you can see that Spring AOP is already there, and that's because Spring internally uses AOP for all its functionalities. However, we also need few more jars which are related to AspectJ libraries. So let's go to the pom.xml. And we want to add some dependencies. Let's go somewhere at the end. Go to the mvnrepository.com, look for AspectJ and press enter. Now you can see that there is an AspectJ viewer, AspectJ RT. Those are the two things that we require. So let's open them in separate tabs. Let's select the latest version 1.9.5. I copied this one, go back over here, paste it. Come back to Maven repository, select the AspectJ runtime, latest version, come back to Eclipse, paste it, format it, and save it. And in a minute, you should be able to get all the jars related to AspectJ, AspectJ Viewer, AspectJ RT, both of them have come. So now that the AspectJ jar files are there, in the next video, let us create a simple method call logger aspect and test out the same thing. First, let's create our aspect class under a new package called aspects or AOP. So let's right click on an existing package, new class, but let's change the package to, let's say, aspect or aspects. I'm going to write different advisors over here. So they are very generic. So I'm going to give it as my custom aspect. Click on finish. And that's our regular Java class. But if I want Spring to instantiate this automatically, I have to mark this as a component and also should make this particular package as part of the component scan. So we'll say @component, and let's go to app-config4 and add the aspects package in our list of base packages. So I'm going to type here core.vinod.aspects, save this. Just to check if this instance is created, let's add a constructor over here, delete the to-do and put a sysout statement saying that my custom aspect is instantiated. Let's run the program to see if you are able to see that output. And you can see it says my custom aspect is instantiated. So Spring is able to scan to that package, finds that this is a component and loads that instance. Now that we got it, let's get rid of this one. We'll also mark this as @aspect. This is required by the aspect J runtime so that it can create an interceptor or a proxy and give that to your DAO whenever you're asking for. Now the aspect class contains functions which are called advisors. So let's write a public void. Let's say we want to just type in a function called log before, which takes no parameter at this time, and we'll simply type in a message saying that logging before target method execution. We also want to print out what is the actual target method that is being intercepted, but let's do that a bit later. Now, in order to mark this as an advice, you have to first identify what kind of an advice is this going to be. Is this a before advice, after returning advice, after throwing advice, or an around advice? Since I mentioned in my function that it's supposed to be a log before, I can say here that this is a before advice, and there is an annotation called before. That's what you have to use. This is supposed to be supplied with what is called as a point cut expression. A point cut expression is given by aspect J expression. Now the aspect J expression is very simple. You simply have to type here execution of a method. That method is identified by this expression here. The expression identifies or narrows down to a function. In this expression, the first thing we have to specify is what kind of modifier we have. Is it a public, private, etc.? And if you're not sure, you can just put a star. So a star indicates that irrespective of the method's modifier, it will be executed. An optional return type also can be given here. If you don't mention, it is okay. It will assume that you are intercepting any method of any return type. Alternately, if I type here int, that means you are only going to intercept a method which returns an int type. So I'm going to skip that part. The next part in this expression is the declaring data type. For example, you have a function you want to execute, but where has it been declared? In our case, it's part of the product DAO. But you also specify that the product DAO is part of the co.vinod.dao package. You can simply say co.vinod ... to indicate it could be a co.vinod package itself, co.vinod.dao, co.vinod.dao.impl. So, or you can be more specific and say it is inside the DAO package. Then the declaring type, which is product DAO. If you want to intercept any function of any DAO, then we can say here star DAO instead of product DAO. That's why these naming conventions are very important. But for the time being, let's give it as product DAO because that's the only DAO we have. And inside this, what function you want to intercept. If you want, you can be very specific and say count, or you can say here star, or you can say get star, or probably any other wildcard combination that you want to use, you can try. In this case, I'm going to use only count to start with. Later, we want to intercept all the functions and also print the name of the functions. One last thing you have to mention is the argument type for count. If you don't know what arguments for count, you can simply put 2 dots to indicate there could be 0 or more arguments. But if you know and you want to intercept a particular function with a specific type of arguments, you can mention that over here also, which we will take that in another example. But for the time being now, the execution aspect J expression is ready. So if you run the code as of now, you may not see any change at all. So your DAO still corresponds to an instance of Hibernate template product DAO. And this is where we actually call the count function and printed the result. So before this, I should have seen the log, but I didn't see. We know that the aspect has been instantiated, but it's of no use. One last thing we have to do is to tell Spring that it has to load a runtime called aspect J runtime. Once that loads, out of all the beans in the container, it is only going to look for aspects and then starts looking at the advisors. And based on the point cut expressions we are given, it's going to create a proxy for target objects. And the way you do it is by adding an annotation called enable aspect J arrow proxy. Let's save this, run the program once and see the difference this time. And you'll see now DAO is an instance of com.sun.proxy $proxy40. This is a dynamic proxy that got created. and we have an instance of that. And if you see carefully that there are 77 products, this log is coming because of my after long PC equals to DAO.count. This is the one that we got. But just before this, we got this logging before the target method execution. Now, if you want, you can go back to the my custom aspect.java and start playing around here. For example, I can just put a star to indicate I am interested in handling all kinds of functions. So if I run the program now, you should see that it gets printed now 5 times because I have called DAO functions 5 times, 5 different functions. So you can see that for every function I called, it's just printing. Of course, just printing logging before target method execution is of no use. We really want to print or log some very useful information. To do that, let's add a parameter over here called join point. So join point is from aspect.j lang package. Let's call it as JP. Now, since Spring is the one which invokes this function, Spring knows that it has to pass on this dependency, and Spring knows the information about the function being intercepted, which is what is called join point. If you select this join point and press function key 4, it will open in type hierarchy where you can see all the functions and its type hierarchy. You will see that there are some functions like get the arguments being supplied, or get the kind of join point it is, get the method signature itself is another interface, get the target objects reference, and few other functions that you have here. So let's make use of some of these functions over here. I'm going to delete this system.out.println, and let's say first we want to print that we are intercepting a particular function. So I'll say here sysout before executing jp.getSignature getName. So this will give me the name of the function being intercepted. If you also want to print the arguments of that particular function, you can say sysout arguments are, and then type here jp.getArgs. But this is going to give you an array object. You can't just print the array object just like that. So what you can do is you can say here arrays.toString and then supply this jp.getArgs. Let's give it a try by running the previous program. And notice that for every function, we are also getting the name of the function, get all products, and there are no arguments to that. And there is a function being called get products by price range. The arguments are 50 and 200. Here is another function, get product, to which we supplied the product ID 1, and the same thing is being printed over here. Let's take a step back and understand what happens when we run this particular program. So the first thing is I'm creating a Spring container supplying this app config 4. So this is how it's going to look like now. We have a JVM when we run the program. New annotation config application context created this Spring container, and we assigned that reference to CTX. And we are supplying app config 4. So let's go to app config 4 and see what's there. Because of the component scan, we are now loading components from 2 packages, core.vinode.dao, which has got 2 components. Number 1 is Hibernate template product DAO, because we marked it as repository. And the same thing is with respect to JDBC template product DAO. So 2 beans are created over here. Let's call them as JTDAO and HTDAO. Next, we are creating a bean called data source that is required by JTDAO. Let's call it as DS. Then we have a JDBC template. Let's call it as JT. Then we have local session factory bean. Let's call it as LSFB. And then we have here a Hibernate template. Let's call it as HT. Also, because of the package core.vinode.aspects, if you go to the aspects over here, we have my custom aspect.java is also a component that is also loaded somewhere here. Let's call it as aspect. Once all the beans are instantiated, now Spring starts the dependency injection. The first thing is DS, or the data source, is injected to this JDBC template. Then the JDBC template is wired to JTDAO. Similarly, the data source is injected to our local session factory bean, which is then injected to Hibernate template. and then the Hibernate template is injected or wired with our HTDAO. And because of this enable aspect J auto proxy, there'll be another bean here which is from aspect J. Let's call it as AJ. Once it is instantiated, it starts scanning the entire Spring container for only beans marked as aspect, and the only one that is annotated as at aspect is this particular bean. And that bean has some point cut expressions and join points. Aspect J starts looking for any of the beans matching the aspect J expressions. Our HTDAO, JTDAO, both of them match that. A proxy object is now created over here, and the proxy object will now have references to both the JTDAO and the HTDAO, and the proxy also has a reference to the aspect class because it has advisors. So anytime if you are creating a DAO variable here of product DAO, whether you ask for JTDAO or HTDAO, the proxy object is going to be given to you. And every function that you're calling using the DAO, that goes via the proxy. And then the proxy will check in the aspect, do we have any advice for that? If there is any before advice, that gets executed. Then the actual function is delegated to the DAO, comes back, and then checks again, is there any after returning advice? If there is any, that gets executed. After that, the return value is given back to the client. So every time you call a function, because it goes to the proxy, proxy can also change the parameters that is supposed to be supplied to the HTDAO. In this demo, let's have a look at as how we can alter the arguments that is supposed to be passed on to the target object. So let's go to our program first. Here we have a scenario where I'm supposed to supply the min and max, and at this point in time min is 50, max is 200, and when we run this actual code, you will see that it's going to say there are around 6 products within that particular price range. And this is where we see that before executing get products by price range, the arguments are 50 and 200. There are 6 products between $50 and $200. So if I say here min equals to $200 and max equals to $50, and then make the same function call again and print the result, this time when Hibernate actually executes the query, the Hibernate queries are converted into SQL queries, and SQL expects the min to be smaller than or equals to max. Since that is not so here, it's going to give me that there are 0 products between that particular price range. Let's give it a try by executing the same. And this time you can see before executing get products by price range, the arguments are 200 and 50, and it says that there are 0 products between $200 and $50. Using AOP, by the time you actually pass the values and it gets received over here, we can ensure that min is always less than or equals to max. So let's go to our my custom aspect.java. So this time the method signature is going to be a little bit different. The function should return an object. This would be the return value from the actual target function. Let's call it as swap inputs. And then we write an argument of something called proceeding join point, which is a subtype of join point. Let's call it as PJP. And for the time being, let's say return null. Let's see what is there in the PJP. So if I select this and press function key 4, you will see the type hierarchy. And in the type hierarchy, you can see that the proceeding join point inherits from join point, and it has a function called proceed. And using this function, you can actually invoke the target function. And using this function, you can invoke the target function with the arguments also. And this is the modified argument that we can do. If you look at the join point, we don't have this function called proceed. So we'll not be able to invoke or delegate the request to the target function. So that is the reason why we are using proceeding join point. If you use the proceeding join point as a dependency, the function must be annotated as @around. Any other annotation you use here will result into an error. So I'm going to say here @around execution of, let's say, the return type, and the modifiers could be anything. co.vinod.dao is the package, product DAO, or you can say star DAO because that's the only one we have. You can even say any function as long as the arguments are of double type, or you can say get star as a wildcard character. And here you can say that the arguments must be of double and double, which means that if there is any other argument and it's not a get function, this particular interceptor will never come into picture. So in our product DAO, the only function that matches this signature happens to be the one get products by price range, which takes two double parameter. Now that we have here, let's import this around by pressing Command Shift O or Control Shift O. Using the proceeding join point, we can now say pjp.getArgs. This is the current arguments. Let's assign this to a variable called args, and args is going to be an object array. Let's move the cursor on the error line and say create a local variable args, or you can press Command 1 or Control 1 and press enter to get the same thing. I know that the individual elements of this args are two double variables. If they are not double, then this particular interception will never happen. So I can take it for granted and then say double min equals to args of 0. That's going to give an error. So I'm going to cast it, and there is no hesitation in terms of casting because this is always going to be a double because of this particular signature here. And the same thing, I'll say double max equals to cast it in advance, and I say args of 1. And I don't have to worry about array index out of bounds exception because if there are no two arguments, it will never come to this particular location at all. So I know that there are always going to be two arguments, arg0 and arg1 exist. And I know that arg0 is a double, arg1 is a double. Now I can check here if min happens to be greater than max, then I'm going to say here args equals to new object array, and then supply here max and min, where I'm creating a new array in the reversed order. Now this is the arguments that I need to supply to the target function. I can now say here return pjp.proceed and then supply this args. The error here says that the proceed function throws an object of throwable. So let's add throws declaration to our function, and the error is now solved. Let's save this code and go to our program, run the same. And this time you will see by the time the target function receives the arguments, it has already been interchanged. And this was the output from the first time. You can see that we got, before executing get products by price range, the arguments were 50 and 200. And that is actually saying 6 products. This is the second time. And notice it is also 50 and 200, even though I have said here 250. And that's because the around advice has already swapped it, and then the before advice gets executed. That's the reason we are seeing. But of course, my output still says that there are 6 products between $200 and $50. So to summarize, proceeding join point allows us to proceed to the actual target function. We can also supply a modified version of the arguments. Plus, the proceeding join point must be used in a around advice and not in any other kind of advice. Let's take another example on aspect-oriented programming. And this time we want to see if I can call this function, and when this throws an exception, we want to see does it really throw a DAO exception as it's supposed to say. For example, if I uncomment this and then move the cursor on update product, you'll see that the signature says the function throws DAO exception. Let's try surrounding this with a try catch block. So I'm going to type try and then this. I'm going to catch a DAO exception because that's what actually the function is supposed to throw me. And let's print a message here saying that there was an error. And the error probably would be ex.getMessage. That's what we want to see. What's the actual error? We know that this requires transaction and we haven't enabled the transaction yet. So this is definitely going to throw an error. We just want to see if the exception thrown here is a DAO exception or not. And if I go to the Hibernate template product DAO, the actual update function calls the template.merge, which does not throw a DAO exception, but instead it throws an unchecked data access exception. So obviously a DAO exception is never thrown. So the catch block is of no use, which means that we don't have a corresponding catch block. It's going to break the execution of the program. So just to prove the point, let's also put one message here saying that end of testing. Save this. And if I run the code, you will see that the end of testing is never printed. As well as you can see that the exception is nothing but invalid data access API usage exception, and our DAO exception is never being thrown. So using AOP now, what we want to do is This, when it throws a data access exception or any kind of exception, by the time the client receives that, it should be transformed into a DAO exception. So this is what we want to do. So to do that, let's go to our my custom aspect.java and let's write one function right in between here. Public void, let's call the function as convert to DAO exception. The argument to this function is going to be an object of throwable, let's call it as t, and whatever the exception we receive, we have to throw this as a DAO exception. So let's type here DAO exception. All I'm going to do is to say throw new DAO exception, and we're going to pass this throwable t as an argument, thereby converting a throwable object into a DAO exception object. In order for AspectJ to invoke this particular function, we have to annotate this as @after throwing. This has got a couple of elements. Now one of the element that you have to use is called throwing equals to some expression, some variable name over here, but that should match this variable. So in case if you want to give it as ex, make sure that this variable is ex. So I'm going to undo and keep it back as t because everywhere I'm using t. The other one is the point cut expression. So I'll say here point cut equals to execution of a method. So the method's return type and access modifier is anything. It's part of code.vinod. It could be in any of the sub packages. It could be any DAO interface. It could be any function of that interface, and it could be taking any parameters at all. Doesn't matter. So whenever you call a function using a DAO, and if it happens to throw an exception, because there was an exception, now this function will receive that exception object, and that exception object is now transformed into a DAO exception and being thrown. Let's save this and check it out. In the program, we are now put a try catch. The actual implementation of this particular function in our Hibernate template product DAO throws a data access exception. More specific exception was something called invalid data access API usage exception. This is the one that was thrown, but that was caught by our function over here, and this rethrows a DAO exception, and the client here we receive a DAO exception, because of which it will go to the catch block unlike the previous case, and then finally it prints this end of testing, which was not printed last time. Let's go and run the code, and hopefully we would get the output as expected. There you go. So you can see that the error which we printed in our catch block is available over here, as well as end of testing is printed because now it went to the catch block, the exception has been negated. Let's now talk about how Spring handles transactions. This is a picture from Spring's documentation page. It's very nicely explained, hence I'm taking the same. As you can see, the client in our main function using the DAO interface, we are calling the DAO.sum function. Let's say the DAO.update product. And this is the actual target function, which is the update product function. When we configure transaction manager, automatically there'll be a proxy. So our DAO would straight away refer to a proxy object, even if we have not configured any of our own aspects. When we configure transaction manager, you will also get something called transaction advisor. The job of this is to create a transaction when we are going towards this particular function. You can think of that's a before advice, which is creating a transaction. If you have any custom AOP advisors, they will be executed, and then it reaches the target method. The target method is supposed to now save the data into the database. In our case, we are using the Hibernate template. Obviously, internally a session.update or session.merge will take place. But remember, the transaction has already begun over here. This is only going to do persist, merge, or delete. Once that is over, if there is no exception, it comes back. Your custom after returning advice will be executed, if any. After that, it comes back to the transaction advisor, which is actually going to commit the transaction because there was no problem. But in case if your target method threw an exception, then it would have been rolled back. So either it is committed on returning, or it is rolled back when the actual target function throws an exception. Whatever the case, the control is now given back to the proxy, and then the proxy will give the control back to the caller. In case if the target method returned a value, then the caller would have got the return value. In case if the target method threw an exception, that exception causes the transaction to be rolled back. But eventually, because you threw an exception, the exception reaches the caller. Let's go back to Eclipse. When we added Spring JDBC jars, we also got the transaction related jars. You can see that the Spring TX is already part of our project. If you press Command Shift H on Mac, Control Shift H on Windows, you get this open type in hierarchy and type something called Platform Transaction Manager, which is an interface. This is the interface that provides the functions such as rollback and commit. But this being an interface, we want a specific implementation that suits our application. So if you see that there is an abstract platform transaction manager, which is a base class for all other types. But if I expand that, you will see a data source transaction manager. This is used if you're using JDBC template. As you can see, it depends on a data source, which is nothing but the connection pool. Whereas since we are using Hibernate template or behind the scene Hibernate, we need to use something called Hibernate Transaction Manager. That depends on a session factory. We have session factory in our app config 4. We can inject the same thing over here. There is also a JPA Transaction Manager, which works with JPA and Entity Managers. But this is only for the backward compatibility. The JPA template has been deprecated, so we don't have to use that anymore. There is also a JTA Transaction Manager in case if you're using EJBs. So the only thing that we have to do is to create an instance or bean of Hibernate Transaction Manager in our app config 4. And in all our DAO functions or service functions, we have to annotate using @transactional. We'll take a look into the same in the subsequent videos. Let's go quickly create a bean of type Transaction Manager. To do so, let's come down somewhere here. Let's create a function public Hibernate Transaction Manager. That's the return type. Let's call it as txmgr. This Hibernate Transaction Manager has a dependency on session factory. So let's just obtain the same thing. So Spring will automatically inject a session factory here. Let's call the variable as session factory. Once we receive this, all I have to do is to return a new Hibernate Transaction Manager with an argument of the session factory. In order for Spring to automatically collect this bean, we have to say @bean. And now our Hibernate Transaction Manager is ready. Any transactional operations executed by Hibernate template, which uses the same session factory, will now be managed by this particular Hibernate Transaction Manager. Just by creating a Hibernate Transaction Manager is not enough. There are two more things that we have to do. Number one, we need to go to our product DAO. Let's press Command Shift R to open the resource, or Control Shift R on Windows. Type product DAO and then select that. In our programs, we are actually using a variable of this data type and calling all these functions. Whenever we want to call the add product, update product, or delete product, we want to ensure that that is a writable transaction. The rest of them are just read-only transactions. To say that these are writable transactions, you can add the annotation at the function level, or if the annotation corresponds to the entire class, you can also do the same thing here. For example, let's add here @transactional. When you press Control space, you get two of them. The one that we want is from Org Spring Framework transaction, not from Java X transaction. So this one has a couple of elements. Number one element is rollback for. This is a collection or an array of all the exception clauses that Hibernate Transaction Manager should roll back the transaction. The only thing that we have to do here is to say DAO exception.class. What it means is whenever any of these functions throw a DAO exception, roll back the current transaction. The second element is read-only equals to true or false. Let's make it as true because majority of the functions in this particular interface are read-only transactions. However, we want to override this particular element for specific functions like add, update, and delete. Let's do the same thing by adding an annotation here, @transactional, and then type read-only equals to false. Let's copy the same thing, paste it to the update function as well as the delete function. So our Hibernate Transaction Manager is ready and our DAO interface has been told that the functions add product, update product, and delete products are writable transactions. The only thing that we have to do now is to set up the AOP for transaction management. This can be done by going to the app config 4 and then add an annotation called @enable transaction management. Save this and go back to the program. When I execute this code, you will see that this is supposed to update the product price. Currently the product price I believe is $22. Let's go and check it out in the DB. Select star from products. The product number 1 has $22. Let's go back here, execute this. Hopefully there is no error. As you can see that there was no exception message. Let's go back here, rerun the SQL select statement, and you can see that the unit price has increased to $23 from $22. In this video, let us understand the working of HTTP client-server communication. As the name suggests, there are two computers involved in a client-server communication. Number one is the client. So this is typically a browser or a mobile application. But generally you can call this as a HTTP client. And another one is the server, which is nothing but a computer with some specialized softwares. So obviously to run a computer you need an operating system. For example, you may be using Windows, I may be using Mac, or someone else may be using Linux. And you might be running some server softwares there, let's say an Oracle RDBMS, or you may be having a, let's say, MySQL, or you may have, let's say, an Apache Tomcat, which is a web server. Let's just call it as Tomcat. Each of these are exposed by the operating system using some port numbers. For example, the port 1521 is for Oracle. So any request via that port number would be redirected to Oracle. Similarly, 3306 is what is used by MySQL, and 8080 is the port that is used by Tomcat. Of course, all these port numbers can be configured, so you can run any server in any of the ports that are available. Now, Tomcat being a web server can host multiple web applications. Each web application you deploy on that will occupy some space called as a context. A context will be accessed using a URL, such as, for example, let's say this one has a URL called app1. There could be multiple applications deployed, hence there could be multiple contexts. So there could be app2, app3, etc. And in each app, there will be resources such as servlets and JSPs. A servlet is a Java object that has a function typically called service. But importantly, this servlet object is mapped to a URL, for example, /hello. So whenever a user makes a HTTP request using a browser, so the user may send a request which says http:// localhost 8080 /app1/hello. So when such a request is sent by a client or a browser or a mobile app, the HTTP is the protocol which is the language of communication between the client and the server. Localhost here corresponds to the same computer where the browser is running. It could be an IP address, it could be a name of a computer, or it could be even a domain name which corresponds to a different IP address altogether in the internet. If the port number is not mentioned, for HTTP protocol, the port 80 is assumed as the default. Whereas in our case, because it is not 80, we have to explicitly mention, so which is 8080. So the request from the client reaches this particular port. Once that is received by the operating system then will forward that to Tomcat because of the port number. So Tomcat receives the request. Once the Tomcat receives, it identifies using this particular /app1 path name to this context. And once that context is identified, within that context, it checks is there any resource mapped to /hello. If the answer is yes, then it's going to forward that particular request to that object. The object has a function called service. There are other variants such as do get, do post, etc. The service function will receive the request. It processes the request, such as, for example, reads all the inputs sent by the client, maybe parameters or cookies, headers, the request body itself. Usually takes the help of other objects such as services and DAO objects, generates an HTML content and gives it back to Tomcat. Tomcat then adds additional headers if any and then gives it to the operating system. The operating system then will give that response back to the client. So this is how a HTTP request that is sent by the client is going to get a HTTP response. The HTTP request is a plain text document that is sent via the network by the client. And HTTP response is also a plain text document that is coming back from the server, which is processed by the client, and the HTTP response body is what is shown to the end user. In this video, let us understand the working of a HTTP client-server communication. For this, we have to configure our Eclipse to work with a web server such as Apache Tomcat. To do this, let's go first download Apache Tomcat. So you go to a new Chrome tab and look for Apache Tomcat 9 download. The very first one is usually the correct one. If you go there, you'll see that there are some downloads, binary distributions. The one that we are interested in is the zip file. So I'm going to download this and keep it on my desktop. Once it is downloaded, it's around 10 MB. You can unzip the same and then probably delete the zip file. So it is on my desktop. I have the Apache Tomcat unzipped here as well as the zip file. I don't need the zip file. I'm going to delete that. Now this directory contains a bin. Bin has all the executables here like shell scripts and batch files. We don't need to run this, but if you are running it in a standalone mode without Eclipse, there is a startup.bat for Windows and startup.sh for Unix based platforms. Let's close this, come back to Eclipse. Since we are using Java EE version of Eclipse, there is a servers tab over here. It says no servers are available. Click this link to create a new server. And as you can see that the plugin for Apache is already available. We don't have to install anything. And the current version of Eclipse supports up to Tomcat 9. Select that. Next. And this is where you have to specify where is your Tomcat, which is in my case desktop. I go to browse and select the desktop, select this Apache Tomcat 9. Just make sure that it is the parent of bin directory. Click on open. In case if you have chosen a wrong directory, you will see an error. For example, if I remove this 0, you'll see that the directory is invalid and it's not allowing me to go forward. One other thing, in case if you have multiple Java installations, make sure that you are using the Java SE8. Since I have only one right now configured with my Eclipse, I don't have to do this, but let's keep it anyways. Click the next button. Here it is asking, do you have any projects that you can add to Tomcat? For this, it only looks for web projects and this is not a web project. So now we need to create a new web project which we can then add to our Tomcat. So let's click finish. You can see that the Apache Tomcat entry has been made over here. If you double click, you get more configuration information. One of the config information you can look into is the port numbers. And by default, Apache Tomcat uses the HTTP 8080 port. That is okay with me, but in case if you have multiple servers running and one of them uses HTTP 8080 already, better change it over here. Apart from that, there is also another option I would like to generally use, window, web browser. Instead of using an internal web browser, I use a default, which happens to be Chrome in my case, so that every time I run my project, the home page of the project will be opened in Chrome. Let's start the server by right click on this and click on the start. You can also do the same thing by clicking this button over here. When I do that, if there is no error, Apache Tomcat starts on port number 8080. You can see the console logs over here. It says that Apache Tomcat is occupying HTTP 8080 port. You can open the browser and go to localhost 8080 and you should be able to see error page 404. because we don't have any applications running on Tomcat at this point in time. But importantly, you can see that the error message comes from Apache Tomcat 9.0.3. Now let's go back to our Eclipse and create a new Maven web project. Meanwhile, I'm going to stop the server. Let's create a new Maven project. I would like to create a simple project, skip all the archetype selection. Next, the group ID happens to be co.vinod as I have been giving. The artifact ID I can say here as Spring MVC Basics. Importantly, the packaging has to be a WAR project, then only it is considered as a web project. Let's click Finish to come out of this. As soon as the project gets created, you may see an error, and this is primarily because every web project must have a web.inf web.xml file. Web.inf is the folder, web.xml is a file. So if I select the markers tab over here, you'll see that the Maven Java EE configuration problem, it says that web.xml is missing. To generate the same, you right click on the project and then say here Java EE tools, generate deployment descriptor stub. That should be okay. We'll add the web.xml in a few minutes. First, let us open the pom.xml of the same so that it will use Java 1.8. If you remember, in the previous project, we had made that entry already. So let me open the pom.xml of the previous project. Copy this section, which says that Java source and target version must be 1.8 and paste over here. In addition, let us also add the Servlet API dependency. And this is where I need to add a dependencies section. And one of the dependency happens to be the Servlet API. So I'm going to go back to Maven repositories, look for Servlet. And if you press enter, you'll see that there is a Java X Servlet API. If I select that, let us select the latest version, copy the dependency, come back over here. We also may want to add the JSP dependency for this. Let's look for JSP. And again, you have here the Servlet JSP API. Select the latest again. Come back, add that over here. As soon as you save your file, you will see that the dependencies are downloaded from the net. Since we added this section as well as a couple of jars, let's go to our project. Do a Maven update once. And when you do that, the Java version should be 1.8. We still have this error related to the WAR file. We'll fix that in a minute. But if I go to project, properties, Java build path, you can see that the Java build path now corresponds to 1.8. Now let's add the web.xml file for which it's giving an error over here. So let's right click the project, Java EE tools, generate deployment descriptor stub. And now I should see the errors are gone. Plus under SRC, you will see that there is a main, web app, web.inf, web.xml. So this is the location where we have to create our HTML, JavaScript, CSS, if you want JSPs, although we would like to keep the JSPs inside this web.inf so that they get hidden. Now let's add a servlet to see how this whole thing works. Let's right click the project, new Java class. And in the new Java class, we're going to write the package as co.vinod.web.servlets, because this is where we are going to keep all our servlets. In fact, in the entire project, this is the only servlet I'm going to write, because when you work with Spring MVC, we don't have to write servlets. Instead, we write something called controllers. But for the time being, let's say we want to give it as a hello servlet as the name. The super class for the servlet would be HTTP servlet. You can press Control space over here to get the IntelliSense. Click the Finish button. You can also generate the servlet by right click on the project and say New Servlet over here. But this also would try to add an entry in the web.xml, and that is the reason I did not choose this. Now every servlet is going to have a URL mapping so that when a client makes a request, that URL will be received by this servlet object and will be passed on to a specific function called service. So let's add that @web servlet. That is the annotation through which you can do a URL mapping. You can simply type here /hello. or you can use an element called URLs equals to and then give an array of URLs. It says here that the servlet extends HTTP servlet, so which inherits from generic servlets. All those classes implement serializable. For that reason, it's asking you to create a serial version UID as a variable. So I'm adding that here. Let's also override a function called doGet, or typically a service also is okay. Let's go to source, override implement methods, and you'll see that there is a varieties of do xyz functions. There is also a service function that we can override. The service function can handle all kinds of requests, whereas doGet is only going to receive the get request. So let's write the doGet, say okay. Now that I have the doGet, all I have to do is to generate a response and then give it to the end user. A request maintains an input stream. For example, if I want to read information from the client, I can always use this HTTP servlet request and its functions. This time, I don't want to read anything from the user, but I want to write information to the end user, for which this response maintains an output stream. Let's use the response.getWriter as a function. Assign this to a variable called out. Out is not created. I'm going to press command 1 or control 1 on Windows and create that local variable. Once I got it, I can say here out.println and then start typing my HTML content. For example, I can say here hello world /h1. I can type another out.println. Let's type here hr. Let's add one more println. Let's add a paragraph. Let's say, for example, demo by Vinod /p. And now I can say out.close. All we have done is we have written some HTML content to an output stream. When this function is invoked by Tomcat and we return the control back to the Tomcat, Tomcat will now collect this response and then give the same thing back to the end user. Let's add the missing semicolons over here. And one other thing that you may also want to mention is before you do this, you can say response.setContentType as text/HTML. Otherwise, HTTP client may treat this as a plain text and even probably display the HTML tags on the browser. Let's save the file and then right click the project, run as, run on server. This is going to bring me a dialog box asking which is the server. I have only one server. Just in case if you have multiple server, you can choose that. But since I'm going to use only this particular server for the entire project, so I'm going to select this, always use this server when running the project. Click the next. It's asking, is there any project you want to add to Tomcat or remove from Tomcat? I don't have any such requirements. I click the finish. Now it's going to open a browser and loads the localhost 8080/Spring MVC Basics, and that is your application name. But our servlet here has a URL mapping of /hello, so we have to add that again here. So hello, and when I press enter, you'll see we got the response from our servlet. But as you can see that generating an HTML content here is really not a good idea. This is where we follow a concept called MVC architecture. We will understand the MVC architecture in the next video. In this video, let us discuss about the model view controller architecture. Now, when a client sends a request, let's see how model view controller works together to produce an output. So we have here a client and we have here web container, which is Tomcat in our case. Model is a bunch of Java objects which could be reused in other applications also, even if it's not a web application. So these include entities or services and DAOs. They don't have any dependency on Servlet API. They're just like helper classes. They can be tested independently as well. So let's write this as model. View, on the other hand, is a templating technology which has the ability to combine Java objects with HTML content and produce a HTML result. So the most popular one and the one that we're going to use is JSP. But there are others such as, for example, Velocity, FreeMarker, or TimeLeaf, and many others as well. So let's name this as view. And the central to MVC is the controller. which is a coordinator between all these things. Since the controller is supposed to coordinate between client, model, and view, the best suited technology here is servlet, because the servlet has access to the servlet container. It has access to resources such as model and view, and also has access to the client request. So servlet has typically four responsibilities. Number one, when a client makes a request, read all inputs such as request parameters, headers, cookies, request body, etc. Number two is to identify an appropriate model method and invoke the same to get the model data. Number three, store that model data in some common storage location. We call it as a scope. There's a request scope, there's a session scope, and there's an application scope. So servlet is supposed to store that model data in one of those scopes. And number four responsibility of the controller is to forward to an appropriate view or a JSP page in our case, where JSP has access to that model data stored in the scope, uses the template HTML and combines the model data to generate an HTML, and that generated HTML is given back to the controller, and controller takes that and simply gives it back to the client. So this way, all components of MVC architecture such as model, view, and controller have their own responsibilities and not overstepping on others' responsibilities. In MVC, a model and view can be reused in other requests also. So this is the working of an MVC application. In the next video, let us understand how this works using an example. In this demo, let's understand the working of an MVC application, which consists of a model, a view, and a controller. A controller is simply a servlet. So let's start by creating a servlet. Let's call this as a greeting servlet. I can start with a servlet here, but I would like to go with the class and call it as greeting controller. This is supposed to be a servlet, so we are going to inherit from HTTP servlet. Let's press Control space and select the first one. Let's also click on finish. As in the previous case, let's add @web servlet and give the URL as /greet. We'll also add the default serial version UID, and we'll also override the do get this time. So you can press Control space and then type DOG. You will see that there is a do get. Let's get rid of this default code and list out the responsibilities of the controller. As a controller, the first responsibility is to read inputs from the request. Number two is invoke a model method to get model data. The third is to store the model data in a scope or a storage location which is accessible to our view. And the fourth responsibility is to forward the request to the view, which is JSP in our case. So first, let's read the input from the user. So I can say here string name equals to request.get parameter of name, so that the user may supply his or her name, which we want to supply to a business logic function. In this case, let's create a new class called as a greeting service, which has a function probably called getMessage, where we supply this parameter and get a customized message. Then we store that message in the appropriate scope, like a request or session or application scope. And then we go to a JSP. So first, let's create a model class. So I'm going to go and right click on my existing package, new class. Let's change the package to co.vinod.service and call this class as greeting service. This is a regular Java class, so no dependency on any web APIs. And this will have a function public string getMessage, which takes a name from the user and return a customized message. For example, I can say hello plus name plus an exclamation mark. But what if the name is empty? So I can say if name equals to null, then I can say name equals to, let's say, web MVC. Save this. Let's come back to our greeting controller. Now we have the model. We can invoke that by typing greeting service service equals to new greeting service. And then I can say here MSG equals to service.getMessage of name. Now MSG is the return value from here, which is a string. We need to create one. Now once we got it, the third responsibility of a controller is to store that in the scope. Now scope is nothing but a storage location where you can store something and another servlet or JSP can make use of that. Request is one such storage location. All these scopes have a common function called set attribute. The attribute has some key value pairs, so I'm going to give the key as message, but the variable MSG is what I want to store. And the last responsibility is to forward to a JSP. Let's assume that we have a JSP somewhere. We can say get request dispatcher to that JSP. Let's assume that I'm going to keep it under webinf pages folder. Let's call it as greet.jsp. This is the request dispatcher. So I can say here rd equals to, and the request dispatcher has a function called forward, using which I can forward the control to the JSP now. I can say rd.forward request and response. Now notice that when we go to this particular JSP using this rd, we are supplying the request, and in this request we have stored an attribute called message, which this JSP has access to now. So let's go back to our Explorer, and under src main web app, under webinf, notice we don't have a folder called pages. Let's first create a folder called pages. This is a convention. You can give a different name if you feel like. And the name of the JSP I am supposed to create is greet.jsp. Let's do that. Right click and say new JSP file here called greet. When I press enter, it gives me a basic template. What I'll do is I'll display here MVC demo, and in the body I'll add h1, and I want to access this particular attribute that we have got, message. We can access them using $curly bracket message. If you want to be very specific to the request scope, you can always say here request scope dot message. But in our case, it is there in the request scope anyways. By default, it looks in the request scope. Let's leave that as it is. And then let's add a HR, probably a paragraph demo by Vinod /p. Let's save this, save the controller now. This time, instead of running my project, I am going to run the servlet itself directly. So let me right click on the servlet, and then I have an option here called run on server. So now you can see it says greet here. Directly it is giving me some output. Web MVC, if you remember, we did not supply any parameters. So if I go back to my servlet here, this is null. Because it is null, we are supplying a null, and in the get message function, if it is null, we are giving this default value, and the return value comes back to my message. Message is stored in the scope. Now the JSP is the one which is printing it as a H1. There's a HR, and then there is a paragraph. If I want to supply a name, I can say here question mark name equals to Vinod, and you can see that it says hello Vinod. As you can see that the responsibilities have been distributed now. The greeting service is only looking at the parameters and its return value. In this case, it is a pure function, but typically greeting service will have a dependency on a greeting DAO, and it will probably do some validations and then make use of the DAO to get the actual message. That is what we typically do in our MVC. JSPs, however, are simple Java server pages. There is no Spring involved in this case, at this point in time at least. We simply display the data or the model data over here. In other words, we present the model data in the user understandable format, and the controller is not doing any such presentation logic or business logic or data access logic. The focus here is on separation of concerns. So this is a simple example. However, in a large scale application, it becomes very, very complex to manage our own controllers. So that is where Spring comes into picture and simplifies the MVC framework to a very great extent. So in the next video, let us understand how Spring MVC works. In this video, let us understand how Spring MVC works. Consider this is your Apache Tomcat, which is also a JVM. Let's call this as Tomcat over here. The first thing you have to do is to create a Spring container, and this time we will be using something called annotation config web application context. So that's going to be our Spring container over here. This will be loaded with all the beans that are configured in a file called appconfig.java. You can name it anything you want. So this is Spring container. In our example, we have a bean of type called DAO. So we named it as HTDAO. That got injected with a Hibernate template object. That got injected with a session factory. And session factory was injected with a data source. We also had a transaction manager. Transaction manager was also injected with the session factory and few other beans. When you configure Spring MVC, there'll be additional beans from Spring MVC API itself. One of them is called handler mapping. So let's name it as HM. And there's another one called view resolver. The second thing that you have to do is to create a dispatcher servlet and map it to all the requests that you want. So in our example, we're going to map dispatcher servlet, let's call it as DS, to a URL called slash, indicating any request that is coming to your application should be handled by dispatcher servlet. And of course, now we're going to write our controllers. A controller is simply a component that gets automatically loaded into Spring container. And because it is managed by Spring, it has access to all other beans. So my HTDAO can be injected to the same thing. Let's call it as product controller. So if the user or a client is making a request to something called, let's say, slash products of localhost 8080 slash your application name slash products, the client request is received by dispatcher servlet because of this slash mapping over here. Dispatcher servlet will check with handler mapping. Do you have a handler object for this particular request? A handler object is nothing but a function which is annotated with request mapping. So any of these beans have functions which are annotated with @request mapping. They would have been scanned in the beginning by this handler mapping and collected and stored in a map-like object. So when dispatcher servlet checks for a request called slash products, maybe it is a get request, it supplies that request object to the handler mapping. Handler mapping will simply give a handler object back to the dispatcher servlet. In case if the handler mapping doesn't have that mapping, then it's going to give the dispatcher servlet a null value, and dispatcher servlet then will result a 404 error. But assume that your product controller has a function over here that is annotated with @request mapping and its URL mapping is slash products. Then dispatcher servlet is going to go over here because that's the handler object now. And because your function in the controller has access to DAO, it can now get the data from the DB and then give back to the controller, which is the dispatcher servlet. Along with it is also going to give a logical view name. So basically what you have here is a model and view. That information is given back to the dispatcher servlet. While model data is kept in request scope, view is just a logical name. It is now given to a resolver here. It's called the view resolver. So it takes the logical view name and identifies the physical file corresponding to that, which happens to be a JSP in our case. So this is our view. And that view file name is given back to the dispatcher servlet as a physical file. Dispatcher servlet will then pass the control to JSP or the view. View combines the model data which is kept in the request scope with the HTML template, gives the finished HTML back to the dispatcher servlet, and then dispatcher servlet gives that output back to the user. So this is the working of a Spring MVC application. To summarize, you have to configure two things. Number one is the Spring container. Number two is the dispatcher servlet. Dispatcher servlet object takes a reference of the Spring container, so it knows that in the Spring container there is a handler mapping, there is a view resolver. And then we write our controllers to handle the client requests. In this demo, let us set up the Spring Web MVC to our application. So the very first thing that you have to do is to add certain dependencies to your pom.xml. In fact, we need all the dependencies that we used in our previous project. So let's go to our previous pom.xml, copy all the dependencies that we have over here into our current pom.xml, in addition to the one that we already have, which is servlet and JSP. So let's open the pom.xml for the current project. After this, I'm going to paste it over here, save it. Apart from these dependencies, we need one more dependency, that is the Spring Web MVC itself. Let me stop Tomcat for a while, come back over here, copy one of the Spring dependency, paste it right next to it, change this to Spring-Web MVC, save it. The files are getting downloaded fresh. Let's close this and create a couple of classes. As in any Spring application, we first need an app configuration file where all the Spring beans are defined. So let's start by creating a new class called appconfig, and let's change the package to CFG for good practices. Let's click finish. There are two annotations you would like to add here. Number one is @configuration. Number two, @enable web MVC. This will ensure that our MVC is configured. Basically what it does is it's going to set up our handler mapping, view resolvers, and a couple of other such beans. So that is important. Apart from that, we'll also add one more, which is the component scan, which scans our base packages, core.vinod. let's say web.controllers. We don't have this package, but we're going to keep our controllers in this particular package. So let's keep that over there. And any additional beans that you might want to configure over here. One of the key configuration of a Spring Web MVC is to configure the front controller, which is the dispatcher servlet. To do that, you have to create a class that implements something called web application initializers. I can make this class itself implement that. So let's do one thing. Let's say here implements web application initializer, because of which you are forced to override a function called onStartup. Basically, this function gets executed on startup of your Tomcat or your application, and you get access to your application's servlet context object, using which you have to register a servlet called dispatcher servlet. And the dispatcher servlet will take the reference of your Spring container. Now, I don't have a Spring container. If you remember, previously we used to create annotation config application context, and this time we're going to create something called annotation config web application context. So let's initialize ctx equals to new annotation config application context, and then we can register a configuration file. So we'll say ctx.register and then say here appconfig.class. In the annotation config application context, we could supply this directly, but here we have to separately register this appconfig class. Now, once we got this, somewhere we have to close it. We don't have to worry about that because now we're going to supply this to our dispatcher servlet. So how do we create a dispatcher servlet? You simply say here servlet context, this variable what we have here, servlet context dot add servlet, and we supply some name, let's say ds for dispatcher servlet, and we say here new dispatcher servlet, and that takes an argument of web application context, which is our ctx. Let us assign this to a variable called servlet, some name, doesn't matter what it is. We create that variable automatically using control1 or command1. Now that servlet is ready, you can say here servlet.add mapping to / and this is important because now we are trying to say every client request to this particular web application is handled by our dispatcher servlet now. Typically, we also would like to load this servlet on Tomcat startup. So I'll say here servlet.set load on startup to a sequence number. This is just a sequence number representing the order of servlet loading. So 1 means this is the first servlet that gets loaded. To check if our application is ready or not, let's create a controller in this particular package. So I don't have this package. Let's go create a new class under web package. So I'm going to right click this, new class. Let's remove this servlets, make it as controllers. Make sure the spelling is okay. And let's call this as hello controller. Save, finish. But if I want this to automatically be instantiated, I'll have to say @controller, so that when the component scan happens, this class is now qualified for component scan and an object of this is automatically created. Let's just put a constructor call here and see if this message comes up on our console. Let's go and type here hello controller instantiated. Save it, save the app config. So now if I right click my project, run as on server, let's keep an eye on our log here on the console and see if my message is printed. So here is where we saw a message saying that initializing the servlet DS. So DS was the name that I gave for my dispatcher servlet. Dispatcher servlet was supplied with our web application context, which scans for all the components in a specific package called core.vinod.web.controllers. It finds one and it loads that automatically, which means our Spring MVC setup is ready. Just to make sure that it is working, let us now test if I make a request, will I be able to invoke a function over here? So let's get rid of this constructor, add a function public string, which is the return type of our function. Let's call it as say hello and return the path to our JSP. So let's assume that it's going to be /webinf/pages/hello.jsp. This function is a handler for a specific URL. So in order to tell Spring that this function should be invoked on a URL path called as hello, so I can say here something like @request mapping and a path here hello-mvc. So when you make a request from the browser for a URL http://localhost 8080/springmvcbasics/hello-mvc, Spring MVC basics corresponds to your application, but within your application, now we have a mapping for /hello-mvc. The dispatcher servlet will consult something called handler mapping, which has collected all this information in the beginning. And it knows that for /hello-mvc, this function is the handler function. Handler mapping will simply give this function's reference to our dispatcher servlet. Dispatcher servlet will call this function. We are supposed to make use of some DAO or service over here and then get the model data, store it in some scope. We will see how to store the model data in the scope later. But then eventually it should say who is the view that is supposed to be responsible for presentation. And we directly give the entire name here. We will simplify this also to a logical name. But right now it's going to look for hello.jsp. So if I go back to my pages folder over here under src, main, web app, webinf, and pages, you'll see that I don't have a hello.jsp. Let's create a hello.jsp over here, new JSP called hello. And let's change the title to hello. And let's just print in a hard-coded value of hello Spring MVC. We'll put a HR, save this. Also, let's put a console log over here so that we know that the control has reached this location. Let's call it as hello controller dot say hello called. Save this. Let's restart our Tomcat in case if it's not starting automatically. Sometime you can see that the server status says it says restart. Basically, it's asking you to restart. Let's restart our server. Once it is restarted, I can go back to my browser and access here localhost 8080 Spring MVC basics /hello-mvc. If I press enter now, I should get the response from the servlet. This is the JSP's output here, hello Spring MVC. But if I come back over here, you can see on the server, it has said that hello controller.say hello called. So all we had to do now onwards is add either a new class for every controller, or for every handler, write a separate function over here. If I run my project by right clicking on the project, run as run on server, you will see that it comes with a 404. That's because we don't have any index.jsp in our application. So first let's fix this problem and then proceed further. Let's go to our pages, right click and say new JSP. Let's call it as index. Now index is typically a standard name given for a home page, but because we have kept under webinf/pages, so the actual name is no longer index.jsp. Its name is webinf/pages/index.jsp. Obviously, this may not work, but we'll give it a try. So let's call this as Spring Web MVC Demo. That's the title. Let's just put some title here for the time being, H1. Maybe I'll copy and paste the same thing and put that over here. If I right click on the page and say run as on server, sometimes you get this dialog box. It says that the server restart is required. And because this is a mandatory for us to restart, so there is no point in saying continue without restarting. Let's click on this checkbox, remember my decision, say OK. Now when it restarts and deploys that, it will open a URL which has /webinf/pages/index.jsp. Now /webinf is something hidden, which means that anything you store inside the webinf folder, the client browsers cannot access them at all, because of which we get this error message. Even though we have an index.jsp, but it is not in its default location, so I'm not able to see that. So to fix this problem, let's go to our web.xml file here, which has a source tab over here. Click on that, you will be able to see the source. You can see that there's a bunch of welcome file list, which means whenever you access the root of your application, which file should be looked in. And none of this corresponds to our file. We do have an index.jsp, but it's expecting under web app. So let's get rid of all of these and then type here /webinf pages index.jsp. And this is the reason I told that the name of the file can be anything, because you have to mention that over here. One very important point you need to remember is it must start with a slash, and it is case sensitive. So let's save this. And now I'm going to right click my project and then say run as on server. And this time you should see a Spring Web MVC demo as the output. Now let's say we want to style this particular page using, let's say, Bootstrap. So for that, let's create under web app a folder called assets. That's where we are going to keep all our CSS files. Let's call it as assets. And I'm going to create a subfolder here called CSS. And I want to download a Bootstrap theme file over here. So let's go to a new tab, type bootswatch.com and select a theme of your choice. I'm going to select this Yeti. There is an option for download. I click on this download and it's going to ask me where do you want to download. It is under desktop. Spring Sandbox, that's my workspace location. There is a Spring MVC Basics, SRC, Main, Web App, Assets, and CSS. That's the location where I want to download this file, and it's bootstrap.min.css. Let's save that. Once it is saved, if I come back to Eclipse, it doesn't show up here. So I'm going to right click and say refresh, and I will see that file bootstrap.min.css is over here. So what I'll do is I'll add here in my index.jsp a link tab, rel equals to style sheet. You have to say type equals to text/css, href equals to, you can say /assets/css/bootstrap.min.css. To make use of this file, what I'll do is I'm going to just add here a div whose class name is called alert, let's say primary. Inside that, I'm going to have here another div whose class is called container, and inside that I'm going to paste that h1. So we have a banner on our page. Let's save this, and now I'm going to right click my project, run as on server, and this is going to take a couple of seconds. Restart the server. opens that in a new browser tab, but you'll still see that it's not applying the CSS. So if I go to right click and say inspect and go to the network tab over here and then reload my page once again, if you see that it's showing me bootstrap.min.css coming from this particular URL, spring web MVC basics /asset/css bootstrap.min.css is not found. Now the reason for this is, if you go back to your app config where we have configured a slash, every request is now being handled by dispatcher servlet, and dispatcher servlet will check with handler mapping. Do you have a handler for /assets/css/bootstrap.min.css? Handler mapping doesn't have a clue about this bootstrap. It simply says no, and then it's going to give me a 404 error. To solve this problem, you have to add one more implementation of an interface here. It's called Web MVC Configurer. When you do that, you can optionally override many methods from here. One of the method is called configure default servlet handling, meaning if dispatcher servlet doesn't know how to handle, you pass it on to Tomcat. So then Tomcat will look for the static content such as assets, CSS, bootstrap min.css. So now the function you have to override is called configure default servlet handling. So I'm going to press Control space and type configure default servlet handling. As you can see, you get the IntelliSense now. All I have to do is to get rid of these two and then say here configurer, the argument you got, dot enable. So what it does is, if your dispatcher servlet is unable to handle certain requests, then it will pass it on to the default handler, which is Tomcat. And Tomcat, if it doesn't know how to handle that, Tomcat will anyway give you 404. Now that it is done, let's save this, right click our project and then say run as on server. And you can see our page is nicely colored with the Bootstrap CSS. Let's go back to our index.jsp now and add a few other stuff. For example, I'm going to add one more div here whose class is called container. Let's add here something like h2 welcome to product manager app. We'll also add some kind of a footer. So let's add here div class equals to container text center to make sure that it is all center aligned. And then we're going to add here ampersand copyright. So that's going to give a copyright symbol. 2019-20, all rights reserved by, let's say, for example, K Vinod Inc. And I want to surround this with a hyperlink. So I'll say ahref equals to https vinod.co. And this is my copyright information. Let's also give a minimum height for this so that the copyright always is at the bottom. So I'm going to add a style here, an inline style, not good practice, but let's add that as a min height of, let's say, 400 pixel. Save this. If I now come back to the browser and refresh, I should see that there is a h2 and there's a copyright. Now, in order for me to maintain this look and feel common for all our pages, it's a good idea to have the fragments like header, footer, and sidebar in case if you have, as well as the main content area. So to do that, let's go to our pages location. Let's create here a new file. Let's call this as new JSP file, or you can simply say new file. The file name extension can be anything, but as a practice, we can give something called JSPF to indicate it's a JSP fragment. I'm going to give here header.jspf, press enter. It's a new file. I'm also going to create something like footer.jspf. From the index.jsp, everything above this section, I'm going to cut this and paste it in the header.jspf. Similarly, everything after this particular section, I'm going to paste it in the footer.jspf. Save it, save the header. Let's come back to index.jsp. If I now just go back to the browser and refresh, because the index.jsp has only h2 and nothing else, You should only see the H2 without any formatting because there is no CSS applied over here. However, I can say here percentage at, this is a directive called include, file equals to dot slash header.jspf. Likewise, I'm going to go and paste the same thing here, call this as footer. Save this. Now you can see the header is common to all our pages. So every time I create a new JSP, I just have to include the first line and last line in every page and the actual presentation logic in between. So if I come down here, refresh, you can see that our styling has come back. Now that in our application Spring has been set up as well as common look and feel is ready, let's go and get some products from the database and display the same thing over here. For that, let us copy some of the files from the previous project to the current project. But before that, let me stop Tomcat, otherwise it keeps restarting every time I add new files. So let's expand the Spring Basics project. Under src main Java, I have aspects. In aspects package, we have my custom aspect.java, which contains a couple of functions which may be useful. For example, the one that transforms all exceptions into DAO exception, that is useful. So we need this. We also need our DAO exception, Hibernate template product DAO, and the product DAO itself. The dummy product DAO, JDBC product DAO, and JDBC template product DAO, we won't be using in this particular example, so we can omit that off. And finally, we also need all the 3 entity classes that we have used in the previous example. So let's copy aspects, DAO, and entity. I'm holding command to select multiple. On Windows, hold control and click on different packages to copy selectively. Then right click and then say copy. Come back to the Spring MVC Basics, Java Resources, and you can click on this src main Java, right click and say paste. While everything have come, we don't need some of the files from here. Dummy product DAO, JDBC product DAO, JDBC template product DAO. Again, I have used command and click to select individual files and right click, delete. We don't need this anymore, so let's get rid of that. One more thing that we also need is the resources JDBC properties because it contains the JDBC connectivity information. I'm going to again copy that and paste under the resources of the current project. So let's right click and paste it. Now that we have all the files needed, the configuration also needs some update. So if I open the app config of the current project, we may have to add a couple of other packages here. Number one is co.vinod.dao. So let's add that. And second is the aspects. So let's add co.vinod.aspects. Apart from that, we also need to copy a couple of other functions from the previous app config. In the previous project, the latest app config was app config 4. Let's open the same. We need enable transaction management, enable aspect J auto proxy, and the property source. So 3 of these annotations. So I'm going to copy that, paste over here. And now let's copy a couple of functions. First of all, these values are read from the properties file. We need that. We need the Hibernate transaction manager. We need the data source. We don't need this JDBC template though. We need the local session factory bean, and we also need Hibernate template. So let's copy, paste over here, and this one we can delete that from here. Now that our app config is ready, let us see if we have any errors while running the project. So let's right click on our project, run as on server. And we got the output without any error. Let's see on the console if we have any error, and we don't see any errors also. There is our dispatcher servlet, and Hibernate also has been initialized, which means our application is okay. In order to get the products, let's provide a button or a hyperlink over here that says get all products. When I click on that, I want to see the list of products in a tabular format over here. So to add a hyperlink, let's go to the header.jspf. You can press Command Shift R or Control Shift R on Windows to open a resource and type header, and you should be able to see that header.jspf. Let's add a paragraph here, and inside the paragraph let us add a couple of links. A href equals to first one, let's make it point to the home page itself. Let's give it as home, a pipe symbol. We can also add a CSS class here called btn-link. This will actually format it in a better way, even though A itself is a hyperlink, but this adds an additional styling. Let's add one more by copying and pasting this called /all products. And let's just display here all products. We don't need the pipe at this time here. Save this. If I go back to the browser, do a refresh, now you should see a nice couple of hyperlinks over here. Now when I click on this, we will get a 404 because we don't have any controller that maps to this. So let's go back to our Eclipse, go to the controllers package. We have a hello controller. Let's add another one called product controller. Our product controller is going to contain all operations corresponding to our product. So let's go to the class product controller, a regular class, so there's no need to do any extends or implements. But here we'll say @controller, and because of our component scan to this package, this now gets automatically instantiated. This can now have access to all other beans in the container. One of the bean is our htDAO, which is there in the DAO package, which is the Hibernate template product DAO. So I can say here product DAO, which is the interface. I can call it as htDAO or just DAO. htDAO would be better because that's the name we have given here. So tomorrow, if there is another implementation of product DAO is loaded, by name it's going to do a wiring. So that's better. So let's go here and declare it as htDAO. Only thing is I have to say @auto wired. And this time I'm not going to say required equals to false because there is no other conflict. So let's go and add here a function public string get all products and returns a view. So let's give the name of the view as /webinf/pages/show-products.jsp. We are giving the physical file name here, but subsequently we'll convert this into logical name, and the view resolver is supposed to resolve that logical name to a physical name. In order to get the data from the DB, I can say here htDAO.getAllProducts. This throws an exception. Let's press Command 1 and add throws declaration. Windows users press Control 1 and press Enter. So we got the list of products. If I assign this to a variable here, this variable becomes a local variable, but if you remember, a controller is supposed to store this in a scope so the view have access to that. In the case of servlets, we used HTTP servlet request to store this, and the JSPs had access to that. So that was called request scope. But since this product controller has no dependency on our servlet API, we don't have the HTTP servlet request. However, if Spring invokes this, you can ask Spring to give an HTTP servlet request here by typing that variable. So Spring knows that for a given request, there is an HTTP servlet request object, and that will be injected over here. However, instead of asking for a request object or session object, what you can do is you can declare a variable of type model. This is an interface, an object of which will be given by Spring, which is like a hash map where you can store all your model data. And at the end, when Spring finished calling this, Spring will collect this model data back and then stores all the model data in the request scope itself. So this is the preferred way of doing, even though you yourself can store it in the request scope. Now let's store this variable list in the model. So we can say model.addAttribute. The name of the attribute, I can say products, and the variable is list. And if you see, as far as good practice is concerned, the variable list is not serving any purpose apart from just collecting it and passing it over here. Instead, we can actually directly store it over here like this. So we don't need this line at all. So now what we have done, we have actually got the data from the database and we have stored it in the model scope, and then we are going to a view. So this is the responsibility of a typical controller. The only thing that I have to do now is to make sure that our all products link is going to invoke this particular function. To do so, you can say @request mapping. You can say here method equals to request method dot get. This is optional because by default hyperlinks are get method. So if you don't mention this particular element, then this can receive all kinds of requests, even the post request. But I just want to say that only for get request this is a handler. We can also say here path equals to slash all products. This is how we are actually associating the hyperlink with this particular function. One last thing is we don't have this show products JSP in our pages. Let's go to pages and create one file called show products. So let's right click the pages, new JSP file. Let's call it as show products. And the first thing is I'm going to remove everything and add a directive %@include file equals to /header.jspf and copy paste the same thing and change this to footer. Let's also just display here $products. We know that products is there in the request scope. We're just displaying it directly, although we want them to be displayed in a tabular format. Let's go back to our project, right click and then say run as on server. And we got this, and when I click on this all products, we should see some list of products over here being displayed. And clicking on home, let's see what happens. There seems to be some error. Let's say it says 404 for /home. Let's go back to our header.jspf, and it's not ./home, it's just /. Save this, go back to the browser, and let's do a refresh once, making sure that this is going to correspond to the home. Let's click on home and we are back to the home. So all products and home. Now the last thing that we want to do here is to display these products in a nice format, in a tabular format. Right now it is displaying the toString of the list, which contains toString of each of the products. Let's go back to the show products.jsp and delete this one. And then we want to add a table. Let's add here a heading first. Let's say h2 list of all products. Let's use a table class equals to table, table bordered and table striped. These are the CSS classes from Bootstrap which make the table look nice. And let's add a t-head and t-body. T-head is going to contain the header and t-body contains the data. So first the header, let's add few columns there. This is the first row of the header and the only row. We're going to add a th. We'll say here serial number, that's the first one. Second one should be, let's say, the name of the product. And third one, let's make price. So that's the unit price in US dollar. So let's add here /th. One more, let's add here something called quantity per unit /th. Now, in order to loop over this particular products we have in here, we need to use some kind of a programming mechanism. And JSPs by default have something called scriptlets where you can write the Java code itself, which will be very cumbersome, and that's why we don't want to use that. It's an older version of JSP, whereas JSP 2.0 onwards, you have something called JSTL. JSTL stands for JSP Standard Tag Library. There are a bunch of tags. You have to add a couple of jars to our build path and then you can start using them. Now, one other way we have seen so far adding jars to a project is by going to pom.xml, adding some dependencies. But in this demo, I want to show you another way of adding the jars. And this is done by going to the Apache Tomcat distribution folder that we have here. And there you can see there is a web apps, there's an examples, there's a webinf, lib, and you see two jars over here. So these two jars basically correspond to the taglib specification and taglib implementation. And this implementation is from Apache. Copy these two files and come back to Eclipse. And inside the WebINF, you can create a new folder called lib and add any additional third-party jars over here by pasting it. And now these two files will be part of your build path. So to verify, you can go to the Java resources here, and then you can see libraries. And ideally you should see the web app libraries, but it is not showing. In case if it is not showing, like in my case, you can go to the project properties, go to the Java build path, and under libraries, go to add library, and you should be having here something called web app libraries. Click on next and finish, and click on apply and close. And now you see I have the web app libraries. Web app libraries are nothing but the jars that are added in WebINF lib. If you expand that, you will see that the tag libs are there. Most of the time that comes by default, but in case if you run into a problem like I have, this is how you can add. So now let's go here to this T body, and we need to use a tag called for each. But in order to access the tags defined over in these libraries, you have to add one more directive here called taglib. As the name suggests, it is a tag library. And the taglib has two attributes you have to give. Number one is the URI equals to, and if you wait for a second, you should see a list of them. And the one that we want to use is the JSP JSTL core. And the prefix is the second one. So the prefix allows us to differentiate between HTML tags and the JSP tags, and the suggested prefix is C for core. And we come down here, now I can say C:, and if you wait for a sec or press Control space, you'll see that you get a lot of tags over here. So these tags are defined by a logical name here. This is the logical name that corresponds to an XML file called as a TLD, where all the tags have been defined. So I'm going to just select this for each, and that for each have a couple of attributes. Now obviously the for each item in a collection. So what is the item? So I can say here items equals to $products. Now this is the variable or the attribute name that we gave in our product controller here called products. And we are now saying that, hey, I want to loop over each of the products in our request scope, and each one of them I want to name it. I can say here var equals to P. So P will now represent one product at a time. And since P represents one product, inside this now I can use a TR-TD combination to display the same. The first one we want is a serial number, which is nothing but I can use the product ID over here, but that's not a serial number, because in case if I'm doing a filter, then serial numbers won't look like a serial number. So to get the index of the loop, I can say here var status equals to some variable, let's call it as index. Now I have access to the index of the for loop, and I can say index which start from 0. So I can say index plus 1 to get the first serial number. So let's add a tr and /tr. The first TD is going to be our index plus 1 /td, and then I'll say td. The second one is nothing but the product name of this particular product. So let's type here p.product name. Now this corresponds to the product name getter in our actual product.java. And in the product.java, the get product name comes because we have a field called product name. So even though this looks like the field name, but in JSP, this is supposed to be a get product name function. So let's copy this and paste 2 more times. This is going to be our unit price, and this is quantity per unit. Save this and let's click S. Let's go back to the browser and refresh once, and I see an error here. The error says that cannot convert the loop tag support status to a number, and that's because here this is not supposed to be a number, but it is a status variable, and status has something called index. So we have to say status.index plus 1. So let's save this, go back to the browser, refresh one more time, and this time you can see we got the list of products very nicely done. One last thing that we will do in this demo is to make sure that this comes from the controller rather than hard-coded. Let's go back to our JSP here, and we're going to cut this from here, this H2, and let's add here a $page title, Obviously, $page title is supposed to be an attribute in a request scope. We don't have one, and that's why it is giving an error also. But in the product controller, I can go and add another attribute like this, model.add attribute with the name called page title, and the value is supposed to come from here, saying that list of all products. Now that we have here, we should be able to get this directly. And just to make sure that the title is coming from here, let's just change this to all products instead of get all products. Let's right click on our project, run as on server, and we got the output. Home page is displayed. Let's click on the all products, and now we see that the title says all products because it's coming from controller. Whenever a controller returns a view, this is supposed to be a logical name instead of a physical file name, so that tomorrow if you move this particular pages to a different location, or if you rename this pages folder to something else, we don't have to come back and update all the controller functions in our application. To do that, what we want is, we want to say that this is just show products. So I'm removing everything before show products, and the .jsp also, which is after the show products. So basically I removed the prefix and the suffix part from the actual URL. But this doesn't work now. If you go and run your project, it will actually give you a 404 error. So if I go to home and click on all products, you can see that I'm getting a 404 error, because it says that /spring MVC basics /show products is not a valid file name. So that's the reason why we are getting that error, even though it says all products here, but eventually it is looking for something called show-products, which is a logical name right now. So how do we map this logical name to a physical file name? If you remember, we have something called view resolver. So if you press Command Shift H or Control Shift H on Windows and type view resolver, you get an interface, and the interface has got many implementations over here. Let's expand this abstract caching view resolver. You can see that there is something called resource bundle view resolver. That means in a properties file, I can map this path, show products, to a physical file name. You also have something called URL based view resolver. That means whatever the URL we had given, that same thing was used. We also have something called abstract template view resolver, internal resource view resolver. Now this is the one that I want to use over here now. And this actually has functions called set prefix and set suffix inherited from here. You can see here set prefix and set suffix, which means that the deleted prefix and the suffix I can configure over using this URL based view resolver, which is called internal resource view resolver. There's also a couple of others like XSLT view resolver, XML view resolver, etc. Now in order to configure this, let's go to our app config. Create a bean of type view resolver. So let's make some room at the bottom and add here a public. You can say IRVR in capital letters, press Control space. That's internal resource view resolver. Let's call it as IRVR itself, or maybe more sophisticated name like view resolver. It doesn't have any dependency. You simply have to create an object of this class. So let's say here IRVR equals to new internal resource view resolver, and then I can say IRVR dot set prefix to /webinf /pages and a slash, because after that it's the show products, and then a suffix should be like .jsp. So I'll say IRVR dot set suffix of .jsp. So if I'm returning a view name called X from here, then the internal resource view resolver will add /webinf /pages and then x.jsp. That becomes the resolved name. Then we can say return IRVR. The only thing I have to do now is to say @bean, save this, and then restart Tomcat. And then go back to the browser, do a refresh. And this time I should not have any problem in getting the list of products. Similarly, the hello controller that we had earlier in our controllers package, here also I can simply say here that it is supposed to be hello, because right now if I go and access hello.mbc, this entire name will also be prefixed with /webinf/pages/ and then this entire stuff and then a .jsp. So in order for that to work properly, we can say hello, save this, and now I should be able to access even hello mbc also. So let's go back to the browser and access hello-mbc, press enter, and I should get the hello message like earlier. Suppose I want to have a hyperlink here, clicking on which instead of going to a controller, I want to render a JSP. As of now, if you click on this, it goes to a controller, works with a model, and then goes to the JSP, which is a view, and that is how it is printing. But if I want just a JSP to be printed, because the JSP files have been kept under WebINF, which is not accessible to the client, we can't give a hyperlink directly to a JSP inside our WebINF. So there has to be an alternate. Now, one of the method that you can do is you can create a new controller function only to return a view name. But alternately, you can configure something called view controller, and that's what we want to see this time. So let's go and add a new link over here called products by price range. So let's go back to our header.jspf. I also would like to stop the Tomcat, otherwise it keeps restarting. So let's go to the header.jspf and add a pipe here, and then a href equals to /price form. This is supposed to give me a JSP which displays a form to enter mini price and max price. Let's give a class equals to btn link, and then we'll type here products by price. Save this. Let's create a JSP called price form under the pages folder. Right click the pages folder, new JSP, or just a file is also okay. But if you give file, then you have to give the extension .jsp, but here the extension is automatically taken. So I'm going to type here price form, press enter, but delete everything from here and then type %@ include file equals to /header.jspf, and then copy paste the same thing to make it as footer. And let's just add here a h2 saying enter the price range. We will add the form in a bit later, but I just want to ensure that when I click on this hyperlink, it should reach to this particular price form. As of now, it's not going to work like that, so we don't even have to try that. But to make sure that it works, let's go to app config and see that our class has implemented WebMVC configurer. And with this, we also have overridden a function called configure default servlet handling. Like this, there is another one which we can override. So let's go to source, override implement methods. And if you see under WebMVC configurer, we have a function here called add view controllers. So let's select that, say OK. And now you see we have access to something called view controller registry. Let's get rid of the default code that came, and then say registry dot add view controller, where we specify what is the path, and the path happens to be our price form, and this is a controller object. We say dot set view name to the logical name called price form. So let's save this and now restart Tomcat, and once Tomcat is restarted, we should be able to click on the hyperlink, go to the priceform.jsp. Let's go back to the browser, refresh the page once, and we should be able to see a new hyperlink over here. And when I click on this, you should see that it's coming from the JSP without we having to write a new controller. So whenever you want to invoke a JSP using a hyperlink, all you have to do is to come over here and then add another entry for a given URL path, a view name. Obviously, the view name is nothing but the base name or the file name of the JSP, which is supposed to be under our WebINF pages folder. So now that we have got this, let's go to our price form, add a couple of text boxes where user can enter minimum price and maximum price and submit, and we should get the filtered output. So to do that, let's add a form. You can say action equals to products by price range. method equals to get. Let's create a div whose class is row. A row consists of 12 grids, and I can assign a bunch of grids to a particular column. So in case if I want my form to consist of two columns, one for labels and one for text boxes, out of 12 grids, I can assign maybe 4 to labels and 8 to the text boxes, or I can make that as 50-50. So let's go and try something like that. Let's type here label class equals to call. On a medium device, there are 4 types of device: extra small device, small devices, medium and large. So medium device corresponds to our laptop screens. So I'm going to say MD, and how many grids we want. Let's say for example I want 4 out of 12, and then I say here what is the label. Let's say here min price or minimum price, and you can also specify that this particular label is a label for a text box. So that's going to be here. I say div class equals to call md8. So this particular div is going to occupy the remaining 8 grids of the row, where I'm going to have here input type equals to text, id equals to, let's say, min, and then I say name equals to min. Name is important from server side point of view because this is the one that goes as a query string parameter, whereas id is used by this label or some JavaScript code we have. Then I say class equals to form control. This styles my input nicely. Other than that, nothing else is required here. Let's also say that the label here is for this particular min, so that if you click on this particular text on the form, this text box gets highlighted or selected. So that's for the minimum one. Now let's copy and paste this for maximum. So let's change this to max. This is also max here, and one more max. So now we have this min and max. Let's add one button over here. Button by default acts like a submit button. So let's say button class equals to btn primary. So this is going to be our blue button, and let's give a caption of submit or any other text. Save this. Now if I go back to the browser and refresh, we now have a nice form. Let's go back, add one more class here called form group. Copy paste the same thing for this also. Save this. Hopefully this should be a bit different. You can see that there's a little bit gap added over here because of the form group. Also you can see that the minimum price, and there's a huge gap here. That's because the 12 grids are taken from here till the end of it. So if I want this to occupy a smaller space, I can probably say that the whole form should occupy 50% of my screen. So what I can do is I can take this entire form, cut this from here, create a div whose class is a row, and add another div whose class is just call. So indicating that I want to have a column div class equals to call. Now both the divs will occupy 50%. That means this is going to take 6 grids and this is going to take another 6 grids. So if you add one more column, that's going to be divided across like 4 plus 4 plus 4. Now this is going to be a dummy column for me now. I don't want to have anything else inside that, but inside this I'm going to add my form which I earlier cut. Let's indent this a bit, and now we have a nice form. Let's go back over here, do a refresh, and we should now see that the form is occupying only 50% of the entire page. So in any case, when I type here min price, let's say 50, and max price as 500, and click on submit, you see that it's going to change from price form here to products by price range, with min equals to 50 and max equals to 500 sent as query string parameter. Let's click on submit. But I don't have URL mapping for this particular text, so we are not getting any output. To handle this, we are going to write a controller handler function which is mapped to this products by price range. But I also want Spring to automatically give me this 50 and 500 as 2 integer variable or probably double variables. To do that, let's go back to our product controller and we add a new function over here, public string get products by price range, and I want Spring to give me a double min and double max, and then I can simply return show products because ultimately that's where I want to go to. And I'm going to copy this request mapping and paste here, but the request mapping this time is not all products, but it's basically the in the form we have this action products by price range. This is what we want. Let's go back and replace that. This double min and double max, when you're asking Spring to give this, we have to tell Spring where to look for these particular values. And that is, in our case, found in the request parameter. These are called request parameter or query string parameter. The parameter name is called min and max, which coincidentally match these two variables. But in case if the variable names are different than your parameter names, you may have to mention that also. Let's make some space over here. And then we type here @request param, and then automatically it will look for a parameter with this name. But if the name is different, then you can add it as min over here like this. But in my case, since it is the same, I'm not going to do that. I copy this and paste one more time for the max. So there are two variables, min and max, now given by Spring to me, and I can make use of that. So I'm going to copy these two also over here, but the actual function that I want to invoke is not get all products, but it's going to be get products by price range, which takes min and max. Now the title also I can change here. I can say products priced between, and then type dollar plus min plus and dollar plus max. So I'm just giving a customized message for both the outputs. As you can see, I don't have model here. Let's also ask for model so that we can store it in the model. One last thing is the function get products by price range throws dov exception. Let's add that from our function also. So if I check my function now, you can see the function signature says the name is get products by price range. We are asking for three dependencies. Spring knows what to give when you ask for model, but we are also asking for a min, which is coming from request parameter. We are also asking for max, which is coming from request parameter, and making use of those, we are invoking a DAO function and then storing it in a model, going to the same view. So let's save this, restart Tomcat in case if it's needed. It says here restart. Once the server is ready, let's go back to the browser. Let's go access the home page first and see if everything is working. Let's click on all products. Works fine. Let's click on products by price. We got this. Let's type here 50 and 500. Click on submit. And now I should see all the products priced between 50 and 500, just like that. So I can go back to products by price. Let's say, for example, 10 to 20. Click on submit, and now I see all the products between the price range of 10 to 20 are being printed over here. Suppose we want to provide a hyperlink to this particular product name, clicking on which I want to get the details of the product. To do so, let's go back to Eclipse, stop the Tomcat server for now, and go to the show products JSP, where we are displaying the product name. We just want to provide a hyperlink. For that, let's make some room over here. Give a href equals to, and let's say, for example, / product details. We also want to supply the ID of the current product, which I can say ID equals to $p product ID, and then close the double quotes, that's the hyperlink, and close the hyperlink after the product name is given. So that's my a/a inside that the product name. Let's also give a CSS class for this, so it looks like a nice hyperlink. So it's called as btn link. Save this. So when it is run, if I click on a particular product name, it's supposed to go to this particular controller. We don't have a handler for this particular URL. Let's go to our product controller, create a handler function to receive this particular ID, and then go to a JSP which can display the complete details. Let's see how easy it is to do that. So let's go to product controller, add a new function over here, public string, that's the return type, which is the view name. Let's call it as get product details It receives an integer ID as well as model because we want to store the model data. Throws DAO exception. The first thing that we will do is to return product details as the name. So this is going to be a JSP in our webinf/pages folder. We don't have yet. We're also going to do a request mapping. And in the request mapping, we can simply type /product details. That is what the hyperlink says here in the show products JSP, product details. ID is supposed to be received as a request parameter. We have declared that variable over here. We'll say here @request param. And now I can come down here and then say model.add attribute. The name I can call it as PR or any other name you feel like. Here I'll say htdao.getProduct and supply the ID I received. So when I go to the product details page, we can access the product using this attribute name called PR. So let's quickly create a product details page. Go to the Explorer, right click pages, new JSP, and then that's the name product details.jsp. Let's get rid of everything. The first is the include directive. File equals to ./header.jspf and copy paste the same thing for footer. And in between, I'm going to say here h2 product details. And the details of the product, I would like to display it probably on the first half of the page. So I can say here div class equals to row, add 2 columns so that they are occupying 50% of the screen. Div class equals to call, copy the same thing as a second but dummy column. But in the first column, I'm going to add a table/table. So I'll say table class equals to table without any other additional CSS classes. And here I'll say tbody/tbody with multiple rows but only 2 columns. The first one is going to be, let's say, the name of the product, and the value for that is $pr.product name. Let's copy and paste this row multiple times for each of them. The second one is going to be, let's say, for example, category. Now, if you remember, PR is a product that has a member variable called category, which itself is an entity object. It has a category name, meaning pr.getCategory.getCategory name. Let's also add supplier here. And the supplier is also a member variable here. Supplier.company name, that's the member variable. Apart from that, we also have unit price. Let's type here USD and then the unit price. And for discontinued, let's display that as yes or no. So let's just type here discontinued as a question mark. And I can say here discontinued is equals to 1. Then I can say here yes, or I can say no. So this way we are giving more user-friendly output instead of just 1 and 0. So let's save this, start Tomcat once again. And once it is done, let's go back to the browser. Let's refresh or click on all products. Now we see that they are all like hyperlinks. If I click on chai, for example, you should now see the complete details of that product like this. You can also see that there is a product details as the URL, question mark ID equals to 1 as the query string parameter. So if I type here itself, say for example 66 and press enter, I should get the details of the product 66. Now it would be nice if I say product details for ID 66 because that's what actually I'm looking for. So I can go back to the browser here and then display something like product details for ID and then say $param.id. Param is a JSP implicit variable that I can access in the expression language. And ID happens to be the request parameter that I've sent. So I'll save this, go back, let's say go back to all products and then access some product randomly And you can see now it says product details for ID 13. These are the product details. Let's now provide another link here which says add a new product, clicking on which I want to get an HTML form for adding a product with all the default values of the product object, if any. And then when I click on the submit button, the data should be collected back by the server, add the same to the database table, and then comes back with this particular screen again. This involves three different controller handler functions. Number one is a controller that can give you a product details in the form of an HTML form. Number two, when you submit, the data should be collected by this handler, do some validations, add the same thing to the database, and comes back to the browser and tells the browser to redirect to this product details page. To understand the same, let's go back to the header.jspf, add a hyperlink first. So meanwhile, I'm going to stop the server, otherwise it keeps restarting. Let's go to the header.jspf, add a pipe here. Maybe I would like to copy this once, add one pipe symbol, paste over here. Now this is not going to be a price form. Let's call it as add product. Let's give a text add product or new product. Save this. When I click on this hyperlink, this is always going to send a HTTP GET request. So let us write a controller function that corresponds to this particular URL path, but specifically the GET method. So let's go to the product controller and write a new function over here that says public string add product, which takes model as a parameter and keeps a new product object in the model. So we'll say model.add attribute. The attribute name, let's call it as PR. And this is going to be a new product. Let's also import this. And now I have to go and render an HTML form. All I have to do is to say return product form. We don't have this product form, so we have to create one. Let's do that in a minute. But before that, let's be specific about what kind of HTTP method and what's the URL that we want to map to this particular function, which is very simple. We say @request mapping / add product. That's the URL. But if you want to give the HTTP method also, then you have to say here path equals to add product. And then you can say here method equals to request method dot get. Let's go and create this product form under pages, new JSP product dash form. Now I'm naming this as a product form, not as add product, because I want to use the same product form for even editing also. That's the reason I'm giving a neutral name here. Let's click finish. Let's get rid of all these. Add a directive include file equals to header.jspf and copy paste the same, make this as footer. And here is where I want to have an HTML form. Now while I can write my own HTML form here, there is an easier way to associate the product object that we have here as PR to the form so that the data gets automatically copied to the form. Plus when we submit, a new product object can also be created easily. For this, we have to add the taglib directive because Spring comes with its own JSP tags. So let's type here URI equals to and wait for a second. And the last couple of them, if you see, they are from Spring Framework, springframework.org/tags, and there is a tags/form. This is the one that we want. Let's select that and then add a prefix. If you see the prefix that is suggested is form, what I'll do is I'll give SF so that it doesn't confuse us with form, because there's also an HTML tag called form. So let's give it as SF for Spring Forms. And now I can say here SF colon, and if you press Control space, you get a lot of tags. So the one that I want to start with is SF colon form and then /SF colon form. The SF colon form, we generally add or associate this with something called model attribute, and we assign PR here because PR is the model attribute that we stored over here. So this is exactly called model attribute here. Now the PR is associated with this HTML form. What I want is a text box. Let's say for the time being, we're going to just type here SF colon input. Input corresponds to text box. Path here corresponds to the getter and setter of this particular PR, which is nothing but the property of the PR object. So if PR is a product and I want to associate the product name with this, all I have to do is to say here product name. This is the member variable with getter setter in PR. Now automatically the product name would be associated over here. Just for a demonstration, let's go to product controller and let's say we create here PR equals to new product and PR is supposed to be created. Let's add here PR dot set product name, and for the sake of demo, let's type here demo product. So instead of supplying a new product over here, let's apply PR. Save this. This is a temporary fix. I'm going to remove this and come back to the same. So let's go right click the project and run as run on server. Let's save the files. So here we are getting the home page. If I go to the add product, we should get an HTML form with one text box, and the text box shows the value of the product object. If you go back over here, you can see that in the product form, we are only saying SF colon input path is equal to product name. But if I view page source over here and then check the code, the SF colon form has been changed to form. An ID for the form itself is given as PR. That was our model attribute. There is an action that was added automatically, and note the action we did not give. It took the current action itself. This is the current action. So add product. The same URL path is also taken as this, but very importantly, method has become post. Now we didn't give this, but that's the post. So that means if I submit this particular form, we don't have a handler here, even though we have a handler for add product, but this is specifically for get request, not for post. We have to collect the product submitted in another handler function. So we'll do that in a bit later. Let's come back over here. You can also see I gave SF colon input path is equal to product name, but it's converted into an HTML tag called input. ID is equal to product name, name is equal to product name. So when you submit the form, this is what goes to the handler function in the form of post parameters. And there's a type is equal to text by default. We also have the value. This value came from pr.getProductName. So let's go back and create a complete HTML form. This time I also want to have proper formatting using some styling. Before that, let's also change this back to new product over here, and I don't need these two lines. Let's get rid of that. Come back to product form. Now we want to do some styling also here. So the first thing that I want to do is to get rid of this. Let's add a div whose class equals to form group and row. We want to have a label and a text box. So the label is going to be occupying, let's say, 4 grids out of 12. So let's say label class equals to call-md-4. For equals to, let's say, product name, because that's going to be the ID of the text box. Let's give a caption here as product name. We'll also give another div which says class equals to call-md8. That's the remaining 8 out of 12. Inside this, I'm going to have a input, but the input this time is going to be SF colon input. That's the text box. Path is equals to product name. This takes care of ID and name attributes of the HTML text box. Apart from that, I can also say here CSS class equals to. This will be eventually converted into class over here. So that's the way it's going to work. And here I'll say form control. That's the CSS class. So we got for 1. So this is the product name. I want to copy and paste this for the remaining 8 or 9 of them and make the necessary changes. For now, I'm going to have text boxes for all of them, but eventually I want to have some radio buttons and drop downs. Now that the entire form is ready, including the submit button over here, let's go and right click on my project, run as run on server. So we got the home page. Let's click on the add product. And now you see we got a product name category. All of these are being text boxes. I also have the submit changes. If I type some values and then click on the submit button, I will get an error because I don't have a handler for post method for this particular URL. So let's first write this handler function. Go back to the code. Let's stop the Tomcat. Let's go to our product controller. I'm going to write a function here called public string. Let's give a generic name called save product instead of add product, because I want to use the same thing for edit product also. So I'm going to call it as save product. We can ask Spring to give me an entire product object. So this is the beauty of Spring's dependency injection. Let's call it as PR. But first let's add the same request mapping but with the post method over here. But then if I want to reuse this for update also, I have to call this something else. Let's call it as save product instead of add product. However, in the HTML form, if you go back over here and then say view page source, the action corresponds to add product, and it is only going to look for a handler that takes post as the request method and add product as the URL. In order for me to say that the form should have save product, we can simply go back to the form, and then in the beginning where we have SF form tag over here, I can say here action equals to and then say save dash product. Even if I'm reusing the same HTML form in edit also, when we submit, the control goes always to save product, not for edit or update product. So coming back to the controller, we now have a handler for this. Now how does Spring know what to give here? When you give an entity object here as a parameter, what Spring does is Spring is going to create a new object of this class. So PR is equal to new product is done by Spring, and then makes a list of all the properties of this product. The properties of this product is nothing but the member variables with its respective getters and setters, and tries to look for HTTP request parameters with the same name, like product ID, product name, and so on and so forth. And then if it is found, it's going to assign using the setter for this particular newly constructed product object. So Spring basically converts the list of HTTP request parameters into a product object and then injects the same over here. In case if some of the properties, like for example product ID, is not there in the form, it will be left as the default. So in our case, the product ID default value is null, and that will be null. So now that we have the product object given by the end user, we can say here htdao.add and then supply this PR. This actually throws an exception, but for the time being, let's throw it away from the function itself. When Hibernate tries to add this product, we can ask Hibernate to automatically generate the product ID. So let's go to the product.java. This is the primary key mapping over here, where I can say that this is a generated value. Generator equals to increment, and Hibernate automatically tries to find what is the maximum value of the product ID in the table and then increments that by 1, and that becomes the new product ID. Now that the new product ID is generated by Hibernate, this PR will have the product ID. So that means before this particular line, PR.getProductID would give you null, but after this line, PR.getProductID will give you a new product ID. So now that I have this, I can now redirect this to the product details handler. So this is going to be a client-side redirection, which means here when I return the view here like this, we're going to say redirect colon, we say product details question mark ID equals to plus PR.get product ID. When we return this particular view, redirect colon here is like a protocol to Spring. It says that we now have to generate a 302 HTTP response, indicating that the browser should come back or revisit the server to this URL. This could be a URL to a different domain also, but we are actually giving a relative path, which means it's going to come back to the same server application where product details question mark ID equals to the newly generated ID, and that is going to be handled by this particular handler, where the request parameter ID is now taken, which is nothing but this product ID, and then it searches for the product in the database, which is the newly added product object, and then stores that in the attribute, and it's going to go to the actual product details page. So let's give it a try. I'm going to save all the files, go back to the project, right click, run as run on server. Let's go to the add product. Let's give a product name as, let's say, mineral water. Category, I'll have to give an ID right now, so I'm going to give category 1, supplier 1. Ideally, this should be a drop down. I should be able to see the list of all available categories. I should be able to select from the list of available suppliers. We'll do that subsequently. Unit price, let's assume that it's going to be around, say, $8. Quantity per unit, let's assume that it's going to be 5 bottles pack. Units in stock, let's say for example we have around 120 units. Units on order, let's say 22. Reorder level, let's assume 10. Discontinued, no. So I have to give 0 or 1 at this point in time. Eventually this is going to be converted into a radio button. We'll do that in the next video. Let's click the submit changes. Hopefully there is nothing wrong, and we should be able to see this data added to the database. And then the next page that we should see is the redirected product details page. Before submitting, let's also do a inspect element, and instead of going to the element section, we'll go to the networks tab over here, so we can see when I submit what actually kind of requests that go to the server. So let's make some room over here. Let's click on the submit changes, and you can see that the first is going to the save product. Let's go see what's the actual error, and it says that there is a spelling mistake for increment. So let's go back to this, go back to our code. Instead of increment, I misspelled the increment here. So now I think it's okay. Let's go restart our server. So the server is restarted. Let's go back over here and then clear the requests. Let's click submit changes. And now you can see that we were able to go to the save product, but after the save product, the response has been 302. If you look at the save product's response over here, the response says we should redirect this to something called product details ID is equal to 78, and I got the ID equals to 78. One of the things that I can see here, that I gave the category and supplier as 1, but that was not taken. I'll tell you why it did not taken in a minute. But let's go and verify that in the DB also. So we can go to the H2 console. Let's go refresh here and connect it back. Go to the products table. I can also say order by product underscore ID descending. You can see the latest record, that is 78, mineral water, null and null. Now the reason why this has been null is, if you go back to the product.java here, we said that the column mapping for supplier ID and category ID, we said the supplier ID is insertable equals to false. That means the value for this cannot be used for inserting. So the value has come from the browser to this variable, but it was never taken to the database. So alternately, we had to supply the value from here. That we did not do. But if you want to do that, you could probably add in the product form, instead of a category ID here, I should say here category.category ID and supplier.supplier ID. We'll do that when we provide the drop down over here. But for now, this is okay. So we are able to add a new product record using our HTML form. Now let's convert this text box for discontinued as a pair of radio buttons. Let's go to our project, stop Tomcat in case if it's running. Go to the form, which is right here. And the last field here is the text box that we have got. Let's remove that and then provide sf:radio and then specify that I want a radio button for discontinued. That's the name that I want. I'm going to copy and paste over here. So this becomes automatically the ID and name for this radio button. We'll also say here value equals to 1. This is going to be for one of the radio button. And likewise, I'm going to give the same thing for another one with 0 as the value. You can also give a label for this, but what I'll do is I'm going to use a separate label. So I'll add here a label tag. Let me collapse this. Let's add a label /label. And this label is going to be surrounding one of the radio button, so that the label, when we click on, it's going to highlight that radio button. So this is going to be a small circle with a dot. And then I'm going to type here yes. And another label here. for the no radio button, we'll add this label no after the radio button itself. So we have a radio button for yes, we have a radio button for no. Let's save this, start the Tomcat and refresh the browser page what we are seeing over there. So let's go back to the browser, refresh, and now I should see discontinued with the two radio buttons S and no. If I click on S here, you can see that's actually selected because we kept it inside the label. When I click on no here, you can see that the no has been selected. Also, when we click on the submit button, the values corresponding to these radio buttons, which is 1 and 0, will be sent along with the rest of the values. Just to check the same, let's add a record. Let's type cold coffee, category and supplier. Anyway, it's going to be null, so we'll fix this later. Unit price, let's say for example $12, pack of 1. Units in stock, let's say 102. Units on order is 0. Reorder level, let's say for example 5. Let's say for the time being I want to say no here because I just want to check that it's going to be discontinued. If I say yes, it should be sent as 1. Let's give it as no. Click on submit changes, and now you can see when it comes back discontinued, it says no because that's my choice earlier. We can also go back to H2 console and rerun this query. The product 79, you can see discontinued, the value is 0. So we are able to use radio buttons for a toggle values such as S and no. Now let's convert the category text box into a drop down. First, I need a list of category objects. So this is what I am going to do. I will stop the server first. Let's go to the product DAO interface. Let me close all these open files and go to my DAO package. There's a product DAO interface. Let's add a function here to retrieve the list of categories. So I'm going to go at the bottom, add one new function over here. Let's write a public default list of category. Category is from our own entity package. Get all categories. And this is supposed to throw an exception called DAO exception, and let's also add a default body for the same. We have this function now. We don't have an implementation for the same. Let's go to the Hibernate template product DAO, and we'll provide an implementation for this missing function. I'm going to go press Control space, get all categories. That's the one that I want to override. We will create a detached criteria for the category object. So we say detached criteria for class, and the for class is going to be category.class, which is our own entity class. And then I simply say return template.find by criteria and then supply DC. This is going to give me a list of objects, whereas I have a list of category. That's the error message it says. All I have to do is to add cast. So I'm going to do that. Now my function is ready. Now, since this is to do with the categories, you may separately write a new category DAO and work with that. But since this is the only function that I'm going to use for categories, I want to combine that in the product itself. So now let's go to our controller, which is a product controller. Since this is where we are going and rendering a product form, we have to supply another model attribute, which is a list of categories, so that my product form can make use of the same. There is another way to do that, but we will follow that approach a bit later. For the time being, let's go and type here model.add attribute. The name of the attribute, I'll call it as categories or category list. And here I'll type htdao.get all categories. That's what I want to save. This throws an exception. That's why it is giving an error. Let's throw it away from the declaration. Save it. Now, if you go to the product form, in the product form, we have access to categories just like this PR. And to make use of these categories, let's go to the product form, which is right over here. And let's go to the categories. This is the location where I've given the category. Let's full screen this. Let's get rid of sf:"input and add here sf:"select. Path is equals to category.category ID, but the value should come from somewhere. So I'm going to provide the options for the drop down, and I can type here sf:"options because I have a bunch of options that I want to get from. And this is where you can specify some of the attributes. One of the attribute is items. The The items corresponds to dollar categories. This is my list of categories that I stored in the model attribute. In the product controller, we stored here categories, and that's what actually I'm trying to relate. But from this particular categories, what do you want as the label? What do you want as the value? So you may have to add that also, saying item label equals to, I want the category name as the item label. So I can say here category name is supposed to come from here. And the second one is item value, which is nothing but the value corresponding to the category you selected, which is nothing but the category ID. So let's save this, restart our Tomcat, and the server started. Let's go back to the browser, refresh this page once, and it gives me the category as a bunch of options that I have here. And the only thing is that it has selected beverages by default because that happens to be the first one. But instead, what I can do is I can say here, please select a category. So I can provide a dummy value over here. Let's do that by going to our product form. Right before this, SF colon options. Let's give SF colon option singular because we have a single value here. The value is going to be -1, indicating that the user has not done any selection. And then say here label is dash dash something like select, like this. And I should see that this is the first one and the one that is selected by default. And then there will be a drop down values. I'm going to save this, go back to the browser, do a refresh, and I should see now that it says select here. And if I have not done any selection, -1 will be the value for the category. And during my validation, I can actually check if it's -1, display an error message over here. One other thing that you can also see is that it is not styled according to Bootstrap because we didn't add any CSS class for this. And to see what is the styling for a dropdown, you can always go to getbootstrap.com, documentation, and then you can type here select forms, custom forms select menu. And you can see that the CSS class is called custom select. Let's go back to the product form and then say here select CSS class equals to custom select. Save this, go back to the browser, refresh once, and now you can see we have a nice drop down that looks similar to the text boxes, but it's a drop down. The drop down itself may look different in Windows and Mac, so that's okay for us, but at least the form is not looking any different. Let's also convert this supplier box into a drop down. So to do that, let's go back, stop this for a minute, go to my product.dao.java, and I'm going to add one more function over here, public default list of supplier, get all suppliers. And then I'm going to copy this part, paste over here. Supplier needs to be imported. Command Shift O or Control Shift O will allow me to do the same thing. I have to select my core.winode.entity supplier. And now that I have this, I can go back to my implementation, add a very similar function over here. So I'm going to press Control space, get all suppliers is the code. This is more or less the same, except instead of category, I want supplier. So I'm going to copy this, paste over here and paste over here. So the error here says that it has not identified this function in the product DAO. Just save all of them. The error is gone. Now let's go to product controller and let's add another model attribute. So let's call it as model.add attribute. The name of the attribute is called suppliers or anything you want like supplier list. This is going to be htdao.getAllSuppliers. And now that I have the suppliers here, I can go to my product form and then pretty much copy this, replace the text box for the supplier, and then change this to supplier.supplier ID. And let's also say this is going to be the list of suppliers stored in the model attribute. This is going to be company name, and this is the supplier ID. Save this, restart the server, and this time let's add a new product. So server is started. Let's go and add a new product. So I'm going to click on this add product once again. So I see a list of categories. I see a list of suppliers. Let's go give a product name here. Let's call it as Coca-Cola beverages. And let's say this is supplied by Exotic Liquids. And let's say unit price, let's give it as around $80 for a pack of say 15 units in stock. Let's say for example 45 units on order is 0, reorder level is 5. Is it discontinued? The answer is no. I can also make this as the default in the product.java so that a new product always is going to be like discontinued no. When I click on submit changes, you should now see that it comes back with beverages and exotic liquids as the category and supplier details. And all the values have been added. We can also go back to our H2 console, run this once more, and you can see that it says 80 Coca-Cola, supplier ID is 1, category ID is 1, which is the values for the exotic liquids and beverages respectively, and rest of the values have come anyways. In the next video, let us do some basic validations so that when I click on submit without supplying the necessary values or by supplying wrong values, I should not be able to add the data to the database, plus I should also see error messages next to the same. When I submit this form, there are two types of errors possible. Number one, for numerical values such as unit price, units in stock, units on order, reorder level, I may enter some non-numerical values. This is a data type conversion problem because here Spring is the one that is creating an object of product class and passing on the request parameters to the respective setters. Since the request parameters are all strings, Spring attempts to convert a string into a number. So if I have typed here ASDF, then Spring tries to convert this into a number and fails because it's a number format exception. And eventually Spring will collect that as an error and then moves on to the next field, converts this into a string, no problem. But when it comes here again, if this is a problem in converting a string into a number, again that will be collected as an error. So eventually for all the data type conversion errors, Spring would have collected all the errors and then eventually it breaks the application flow. So just to show you, for example, for unit price, I've already typed a non-numerical value. For units in stock, again, I'm going to type some alphabets. Units on order, some other junk character, reorder level, something else. If I click on submit, you'll see that it is going to break the execution of a program by giving an errors HTTP status 400. But if I go to Eclipse and in the console, you can see that it gave an error. There are 4 field errors. Let's take the one for unit price. That was the first one. So it says here field error in object product. So product is the object that it constructed. On field unit price, rejected value is ASDF. That is the value that I have given. And it's looking through some codes. These are the error codes. Have a look at this. It says type mismatch.product.unit price. It is trying to locate an error message for this particular property value. Or if it is not found, it's trying to look for type mismatch.unit price. Since the data type of unit price is double, it's also looking for type mismatch.java.lang.double. And then finally, it's also looking for type mismatch as a property. If none of the properties are found, it's just going to give its own error message. But at this point in time, it's not even displaying the error message. It just gave error 400. And going further here, the error message says, failed to convert property value of type java.lang.string, that's the request parameter, to the required type java.lang.double, that is the parameter of the set unit price function in the product object. And that's what it's actually telling. And eventually it says here number format exception being thrown. But instead of throwing that exception, at that point in time, it collected that as an error and then continued with the next property. Even that also is collected. Eventually, you can think of that Spring now has a bucket of errors. However, since we did not handle the errors, Spring is breaking the application. Alternately, what we can do is we can go to our save product function and ask for the collection of errors that it got, and then we can handle ourselves. So what we have to do, we just have to type here another parameter called binding result, and the variable name is yours. You can give any name you want. Let's call it as errors. It makes more sense. Now we are asking Spring to give the errors that it got. So we are telling Spring that we are going to handle the error. You don't have to break the execution of the program. So this time now Spring is going to give you that errors object and proceeds further. Of course, this will fail now because Hibernate is now trying to insert non-numerical values into numerical columns. So that will be a different error. So just to check that out, let's save this, restart Tomcat. So once the Tomcat is started, let's go back to the browser, click the back button, and then if I submit this now, because Spring is giving you the errors collection, now Spring is not going to break the execution of the program. But of course, our Hibernate, when it is trying to save the data, is going to fail. Let's click the submit changes this time. And now you see you got error 500 because it's an exception. And if you see, it's all about Spring's data integrity violation exception coming from somewhere Hibernate exception, as you can see, that could not execute the SQL. And if you come down and see, proper error message will be at the bottom. It says null not allowed for discontinued. That's one of the error that it came up. And that's probably because discontinued happens to be the first one that caused a problem. But if that was okay, then probably it would have given an error for reorder level and then unit price, units in stock, etc. In any case, we need to now handle this error. So let's click the back button, keep this form like this itself. What I want to do is I want to come back to this particular form in case of an error. And that's pretty simple. We can come here and then say, even before we do anything, we'll say here, if this errors collection has any errors at all, that's obvious because now there are 4 errors in this related to 4 of those numerical fields. We simply have to go back to return product form. Now this has another issue because when this form is rendered, it is looking for an object called PR in the request scope. As you can see, we haven't stored anything in the request scope so far. And apart from the PR, it also looks for categories and suppliers. So if I again save this and restart and go back to the browser, I will get an error related to PR. And if PR is found, then it's going to give an error for categories. And if categories is found, it's going to give an error for suppliers. So one of the way you can do is you can ask for another dependency here, such as model, and then say model.add attribute. So basically I have to copy this and paste over here. But instead of new product, I have to supply the same product object because that contains errors. Alternately, we can simply add here @model attribute. This will ensure that the same object that I receive will also be kept in the request scope as a model attribute. But that's only for PR. How about these two? So for these two, again, I still have to store that in the model. Now this is where, since multiple controller handler functions require these two objects, what we can do is we can remove that from there and then actually write 2 separate functions which will be automatically called, and the return value of the function will be automatically kept in the request scope as model attribute. So the way you do is you write a function here, public list from java.util, category from our entity package. Let's call it as get category list or any name you want, doesn't matter what it is. And then type here return htdow.getAllCategories. That throws an exception. Let's throw it away further. And all I have to do is to add here @model attribute, just like the one that we did over here. Remember, in the request scope, we want this name of this particular category list as categories. So we can give here the name as categories. Here, however, it took the name from this variable PR, but if you want, you can also explicitly type here PR like this, but it's not required because the variable name is matching in my case. Now this is automatically kept in the request scope for every control function of this particular controller. So let's copy this, paste over here. This is going to be suppliers for me, and this is going to be a supplier list or any other name, it doesn't matter over here. This is get all suppliers, and one last is that this is supposed to be supplier 2. Supplier is supposed to be imported from our entity package. Let's do that. Save it. Now you can see if there is an error, it is going back to the product form. But in the request scope, it finds a model attribute called PR. It finds another model attribute called categories, which is a list of categories. And it finds a model attribute called suppliers, which is a list of supplier objects. So since it is going back over here, so this is being skipped. However, we also want the error messages to be displayed right below those text boxes. For that, let's go to the product form.jsp, which is here. And right below the HTML elements that correspond to the respective properties, we want to display error messages. This is common for all of them, so I'm going to give in advance for each one of them. So right below this SF colon input, I'm going to give here SF colon errors and then say here path equals to product name for this. Of course, product name being a string, there is no data type conversion errors here. So this is at this point in time of no use. We also add a CSS class called text danger. This is going to be colored in red. If you want, you can also add additional styling, but for now this is okay. Now I'm going to copy this and paste in each one of them, making necessary changes. For example, this is category ID, so I'll have to specify here that this is category.category ID. Like this, I'm supposed to do for each one of them, and I'm going to do that and come back. Alright, so I have given for each one of these fields with respective property names. But the one that I am right now interested in is the unit price, and of course the units in stock and a couple of others which are numerical values, where if I enter a non-numerical value, this should display the respective errors. So as you can see that Spring would have stored all those errors in some kind of a map, and from where this is going to be read and it's going to display the respective error messages. And the error messages are completely customizable, but we will see that in a couple of minutes. First, let's go and restart our Tomcat. Now that the server is ready, let's go back to the browser, submit this once again, and you will see that for each of the non-numeric fields, you will get a big error message that correspond to number format exception. It says here, failed to convert property value of type java.lang.string to required type as java.lang.double for property unit price. So basically it says that there is a number format exception in converting ASDF into a unit price which is of java.lang.double. So obviously we don't want this kind of huge error messages because this is more of technical type. We want to give a customized error message. Now the error messages can be configured in a properties file. So let's go back to our project, stop Tomcat for a while, and go and create a new properties file under src main resources. We already have JDBC properties. We want to now add another property file. Let's right click here and say new. I don't see a file, so let's go to other and then say here general file. That's the one that I want. You can give the name of the file anything you want because we're going to specify what's the name of the file in our app config. So we're going to say here error-messages.properties. Extension here is important. Let's give this. Now here you can give keys that can be either something that Spring is looking for. If you remember, we had type mismatch.xyz type of key value pairs it was looking for. The other things are customized error messages we can have, so we will do that later. But for now, we're going to just add here type mismatch.java.lang.double. That means if there is any error in converting a string into a double type, this would be the message that is taken. Let's give here something like expecting a decimal value. You can also narrow down to a particular property, like for example, I can say type mismatch dot unit price equals to, I can say unit price must be a decimal value. You can also be specific to the property called product, or in our case it's going to be PR. Type mismatch.pr.unit price equals to and something else. Similarly, for integer types, I can say here type mismatch.java.lang.integer, and I can say expecting a whole number. You can also give a type mismatch as a fallback message. So I can say here invalid type of value. Save this. And now we can go back to our app config where we have to load these properties. Now if you remember, for JDBC properties we used this, but for error messages you will not be able to use this property source or property sources. What we have to do is we have to come down somewhere at the bottom, add another bean, And this bean can be of type message source. So I'm going to type here public message source. That's the return type. Let's import that first from Arc Spring Framework. Let's call it as message source. We need to create a bean of type something called resource bundle message source or reloadable resource bundle message source. So we're going to type here reloadable resource bundle message source, and then I'll call it as, let's say, src equals to new reloadable resource bundle message source. And then we have to specify what is the name of the file. So I'm going to say here src.set base name, or you can supply base names as a varargs. So let's use this so that in case if I have to add one more, that will be easy. I have to say here class path, that's where it is found, and it's called error-messages. This is the base name, so not the complete file name. So we're going to give that just the base name. And in case if it was in a package, then you'll have to give the package name also. So since it is directly under resources, we have to just give error-messages. That's what I've given over here. And if you want, you can also optionally give src.set default encoding to something like UTF-8. This is totally optional because this is the default anyways. In case if you're trying to give something else, it's useful. Let's just say return src and add this as a bean. So the bean that I've defined here will now override the @property source annotation that we have used over here, because of which the JDBC properties will not be read, and these things will now cause a problem. Let's give it a try, and then if we get an error, let's fix that. So I'm going to start the server. So the server has started. Let's go to console, and you see that there is a huge bunch of errors, and all it says is that it's not able to find this particular property called $JDBC driver. It's unable to load this property from anywhere, and that's mainly because, as I mentioned, the @property source has been overridden because of this. So we need both of them. To make sure that the property source also is being read, we'll add another bean. This bean is basically a bean that loads the property sources. So let's add here public static. And the reason why it is static is because this function is called even before an object of this class is created. So we'll say here property source placeholder configurer. Let's give the function name the same, but probably starting with a lowercase letter. And all I have to do is to return a new instance of this particular class, nothing else except that this is supposed to be a bean. This ensures that @property source is also being executed, and this bean will now read the data from error messages. So let's now give it a try and then go to Tomcat, restart Tomcat once. Tomcat started. Let's go back to the browser. And now if I click on the submit changes again, you'll see that the messages have been picked up from the properties files. It says unit price must be a decimal value. That's because for unit price, we gave a special error message. Whereas for others, you can see it's giving expecting a whole number, expecting a whole number, expecting a whole number. But if I want, I can change this and say that, hey, expecting an integer for units in stock. Let's give that one last try. So we go back to our property file now and then say for integer, it says that expecting a whole number, but I can say here type mismatch dot, I can say PR dot, but that's optional, units in stock must be an integer. So save this. Because we used reloadable resource bundle message source, I should be able to now get that new error message, and you can see it says units in stock must be an integer. Also, if I change this to a numerical value, let's say 5, and then say submit changes, now you see the error messages corresponding to that has gone because there's no error over here. So all these errors are server side errors, not JavaScript or the front end errors. So if I type here say 55 and then say submit changes, the errors corresponding to that is gone. However, for example, units on order, if I type here -98, it will still take, because -98 is still a valid integer, there's no problem. But I don't want that to be taken. This is a custom rule that I want to say units on order, units in stock, reorder level, as well as unit price cannot be negative. Plus, the category must be selected as well as supplier must be selected. Otherwise, if you remember, the category ID and supplier ID will take as -1. We don't want -1. And apart from that, product name must be a mandatory field. Unit price is a mandatory field. Product name must have, let's say, a minimum of, let's say, 5 characters. And all these custom rules can also be validated, but at this time we have only taken care of the data type conversion which was detected by Spring. In the next video, we're going to learn about custom validation rules so that wrong values and empty values are not added as fields of a record. By the time we received the errors object, Spring has already added all possible data type conversion errors. However, we can add our own elements of errors to this errors collection. To do so, let's create a class called product validator, and using that we will try to validate our product object. Since we don't have a product validator, this line may give an error. Hold on for a second. So I'll type here product validator PV equals to new product validator and press command 1 or control 1 on Windows to create a class called product validator. Let's go and change the package to core.vinode.validators, a new one. We'll also say it implements an interface called validator from Spring Framework. Click on OK, say finish. Now we see you got two functions over here. Number one, it says what are the classes does it support. So Spring is going to supply this class and say, hey, do I support this product class? You say yes or no. And then there is an actual function for validating. And note the return type is still void. That's because if there is any validation errors that you detected, you have to add an error object to this particular errors collection. And that's all we have to do. So let's do one thing. Let's first get rid of this to do from here and then say return the parameter I got class dot is assignable from product dot class. This is one way to say that, hey, is this class that we are working on is a product class? Then return true, otherwise return false. And let's go and write this function. But before that, let's go back to our product controller and call this function. So we say here pv.validate. We have to supply a target object which is nothing but PR. Remember that we are supplying this PR. The second is the errors collection itself. So which means the validate function receives the product object over here, but it's received as a super type object. We have to now convert this back to product and then check for certain values. And errors is the collection of errors. This may have 0 or more errors. 0 because if there is no data type conversion error, there may not be any errors at all. But if there is any data type errors, then this will contain some errors. To check if there are any fields which are empty or just user has pressed some white spaces, there is a utility class called validation utils. So I can type here validation utils dot. There are two functions that can reject errors. One is called reject if empty. That means it's only going to check if it's a empty string. There is also another function called reject if empty or white space. There are many variants and I'm going to take this one. This says here, what are the errors collection? So we have received an errors collection. We are giving that errors collection. So this util function will add another error to this. What is the field that we are looking at? The field here is product name. Now this is a request parameter name basically. If the request parameter product name is empty or a white spaces only, then it is going to look for an error code in our error messages. We don't have, but we can give it in advance. Let's say here product name dot empty. That's the key it is trying to look for. In case if that is missing, then this acts as a fallback or default message. Let's give here something like product name is mandatory. And that's the error message I want to give. So if you break it down, you can see that the validation utils dot reject if empty or white space takes an errors collection which we received from the caller. The field it checks is the product name. If that is empty or white space, then it's going to look for a key in the messages file called product name dot empty. If it is not found, then this message will be used and it is going to be printed right here where there is a error for product name, which is right here. So let's go back to the product validator. We can copy the same thing and paste it for all mandatory fields and make the necessary changes. Let's say one other field that is mandatory is the unit price. I can type here unit price and probably copy and paste everywhere that makes sense. So this is going to be unit price. Let's type it like this. And now let's add some custom validation rules. For example, the numerical fields like unit price, units in stock, units on order, and reorder level, they cannot be negative. So let's do that. First, let's create a variable called PR of product type, which is nothing but the target that we received. So let's press Command 1 or Control 1 to add a cast. Now we got PR, and let's declare a variable called unit price, which is equals to pr.getUnitPrice. Unit price is supposed to be declared as double. Let's do that. Similarly, I'm also going to do the same thing for others like units in stock equals to pr.getUnitsInStock. Command 1 or Control 1, press enter. Units on order equals to pr.getUnitsOnOrder. And one last is reorder level equals to pr.getReorderLevel. We also want to use discontinued category ID as well as supplier ID also, but we'll do that in a couple of minutes. If unit price is not equals to null as well as unit price is less than 0, then we want to reject this field. So to reject this field, we can say here errors.reject value and select the field. The field that we want to reject is unit price. The error code, which is going to be looked in error messages.properties. If it is there, it's going to use. So we'll say here unit price.invalid. And then probably I can say unit price must be greater than 0. So that's one error message. So I'm going to copy and paste the same thing, make the necessary changes for the other one. Let's say units in stock. Alright, so that's done. Now let's look at a couple of other validations such as category ID and supplier ID. So let's declare a couple of variables for the same. Let me make some room over here. Let's say category ID equals to pr.getCategory.getCategoryID. This is an integer, so let's create an integer variable. Supplier ID equals to pr.getSupplier.getSupplierID. Let's also create that variable. We know that the default value in the drop-down happens to be -1 for this select option. So which means that the category ID exists and supplier ID also exists. But I don't want that to be -1. So I don't have to check if it's equals to null because it will not be null. So I can check if category ID is it equals to null, then we want to reject this category ID field. But the property is not just category ID, the property is category.category ID. Now to show you that, if I go back and right click on this drop down and then say inspect, you will see the name and ID of these drop downs are category.category ID. Importantly, the name is category.category ID. This is the one that is considered as the field. So let's go back over here and say errors.reject value. The field here is category.category ID. The error code is your choice. You can give anything you want. I can say category.not-selected. And then the default value, probably I can say, please select a category. And I'm going to copy the same thing from here and paste it over here. This is going to be supplier ID everywhere. So this is going to be supplier.supplier ID and supplier not selected. Please select a supplier. So I got those error messages now. And one last thing is that in case if you have not selected discontinued, that radio button you have not selected, I want to give that select an option. So we'll create one last variable here. Discontinued equals to pr.getDiscontinued. That's an integer variable, and if this is null, because if you have not selected anything, discontinued would be null, but the moment you click on one of the radio button, it will never be null again. So I check here if discontinued is equals to null, that means you haven't selected any of them. So we're going to say errors.reject value, and the field here is discontinued. And the error code is, let's say, discontinued dot not selected, and then a default error message saying that please select an option. And that should be my validation. So let's right click our project, run as run on server, save all the modified files. Let's go add a new product. So without selecting any of these drop downs, without selecting the radio buttons, without typing any of the text boxes, if I click on submit changes, we should now see product name is mandatory. That's the custom rule that we are given in the product validator. Unit price is mandatory. That is also the correct one. I was expecting an error message over here. Let's see what has happened. So in the product validator where we are doing the category check, so we are checking for category ID equals to null, but if you remember, the drop down with the select option has -1 as its value. So I should be comparing that with the -1. Let's go check this out. Restart Tomcat. Server is now restarted. So let's go back and then do the same thing once again. Click on submit changes. And now you can see it says select a category. I select one of the category and then click on submit changes. You will see that the error is gone. I select one of the supplier. The error is supposed to have gone. Radio button, let's select, is it discontinued? No, that is also gone. Let's also try some product name here. Let's say, for example, let's call XYZ tomato ketchup. Let's give it a unit price. If you give negative, you know that it's going to give some error. Let's give it as, for example, say 12 in negative. Quantity per unit, let's just give it as 200 ml bottle. And units in stock, let's give some negative value. Say 20 units on order, let's give a negative value. And a reorder level, let's give some negative value as well. And these negative values should give me some errors right now. You can see it says unit price must be greater than 0 and all of them are same. Let's remove the negative, check that out, and you see the errors are gone. Let's remove for all of them and see if our validations are going to pass. Let's submit changes now and see if that record is added successfully, which you can see it's added successfully. Let's also go back to the DB here, rerun our select statement. Let's click connect and say select star from products. Order by product underscore ID descending, and check it out. It says product name is there, supplier ID 4. All the fields have taken their respective values from the form. Now let us provide an edit option for this product details page, where when I click on this, I want the same product form that we use for adding a product to load the details of the product that we are trying to edit. To do that, let's go back to our code. Let's stop the project for a minute and let's close all these open files. Let's go to the product controller where we have a handler for product details, and that's going to the JSP called product details. So let's open the product details.jsp. I'm going to press Command Shift R. On Windows, you press Control Shift R and look for product star details. You can see I got the product details.jsp. Click on the open button. So I'm going to add a hyperlink over here. ahref equals to /edit-product. We don't have this. We have to create one handler for this. Question mark ID equals to $PR.product ID. So we are supplying the product ID of the corresponding product. Let's also give a class of btn primary. It would look like a button now. We'll give the caption as edit. Before we can run and test, we're going to create a handler function for this, which receives an ID as a request parameter, which is of integer type, and returns to the product form. So let's go to the product controller, and somewhere where we had given add product, it's almost the same thing as this, but instead of new product using a DAO, we will be retrieving the product for the given ID. So I'm going to write the code below this. Public string, that's the product form. We can say edit product. It takes a model plus it is also receiving an integer ID from the request parameter we have to map. And then I'm going to say here model.add attribute. The attribute name is exactly supposed to be PR, and then the value for that is htdao.getProductById, and that ID is this one. This is going to throw an exception. Let's go throw it away further. And we'll also say here now return product form. So the ID is supposed to come from request parameter. Let's keep that. We'll also add here @request mapping, path equals to /edit product, and method is supposed to be request method dot get. So we'll put a semicolon, save this. When I click on this hyperlink over here, this is the controller that receives the request. The ID is supplied over here. We retrieve the product for that and then store it as PR. When we go here to the product form, these two model attributes are also available. So the product form has access to PR, which is the retrieved product object, and a bunch of categories and suppliers. And the product form is now automatically going to display the product that is stored in the scope. Let's give it a try by right click on the project, run as run on server, and we go to all products, select one of the product that you want to modify. Let's go to chai. You see there is an edit button. When I click on this edit button, we now see the details of selected product in the form. You can see that it has also selected the beverages because that's the category. It's the exotic liquids. For example, if I go back to the previous page and look for a different product, let's select this. You can see it is confections and specialty biscuits. Let's click on edit. You can see that it has selected appropriate category and suppliers. The discontinued also has been selected automatically because this is the value for this particular product. And now that I have this, if I make some changes here and click on submit changes, one problem is that it is always trying to add a new product over here, which is something that we have to change. This has to be conditional now. So when we are submitting, if it contains the product ID already, it has to do an update product. Otherwise, it has to do an add a product. For that, one more small change that we have to do is in the product form, we have to also add the product ID. If you remember, we have a text box for each one of the fields except the product ID. And I don't want a text box for the product ID because I don't want user to change that. What we have to do is within this SF : form, somewhere add a hidden field. So I can say here SF : hidden, path equals to product ID. All I have to do is this. For a new product, this would be an empty string, whereas for an existing product, this will be the respective ID. So let's save this, restart Tomcat if required, wait for it to restart. Once it is restarted, let's go back over here. Let's refresh this page once. And now if I do a view page source, and you can see that right below the form, there is an input, which is a hidden field. Product ID is the name of this particular field, and its value is 20, which is the product ID of the current product. Whereas if I go to add a product and then say view page source, you will see that the product ID still exists, but its value is an empty string. And of course, an empty string is converted into a null value. And because it is null, now I should be calling the add product. Whereas if it is not null, but it is something like 20, then we should update the product. So let's go make that small change. We go back to our product controller. If pr.getProductID is equals to null, then we want to call this. Else, we say htdao.updateProduct of this PR. So conditionally, we are doing add or update. After that, anyway, we are returning back to the product details. Let's save the file. Let's restart Tomcat. And once Tomcat is restarted, let's go back to the browser. So let's now go and select a product for editing. So I should provide some product. Let's go and select this Ikura. There is some details. Let's see if I want to say units on order is something. Let's go and change these values. Let's say the units in stock is around 25 and then units on order is around 3 of them. And if I click on submit changes, you see that it's updated with the product values. And of course, it's coming back over here. We can also go and verify the same thing in the DB. However, if I click on the add product and add something like, let's say, toned milk, let's say this is a dairy product, and let's select some other supplier unit price, let's say for example it's going to be $2. Quantity per unit, let's say for example it's going to be, let's say 500 ml pouch. And units in stock, let's say for example 29, units on order is 0, reorder level is 3. Let's click on submit changes. Of course I have to select this, otherwise it would anyway give the validation error, so I'll say it's not discontinued. I say submit changes, and you can see it has been added as a new product over here, and all the details have been collected properly. So this is how we can use the same product form for adding as well as updating, and we have the same handler function for add as well as update with validations. Now that our application is up and running, let's look at some other scenarios. I'm right now on the home page. I should be able to get the list of all products. I should be able to click on a particular product to see the details. I should be able to click on the edit to load all the details on the HTML form. I should also be able to click on add product, and from the drop down I should be able to select an appropriate category or supplier. All these are fine, but there are a few corner cases to address. Number one, what if I type something here that is not available? For example, if I type here ASDF and then press enter, you see that we got an error page, which is understandable, but the error page itself is produced by Apache Tomcat and not by my application, and the look and feel of that is not matching with our application. Another such situation is when there is a server-side error. For example, the DB connection has been closed, or there is a transactional error. Some exception has been thrown on the server side. We will get a HTTP status 500. Let's take an example. If I go back to my home page, I'm able to see all the products. However, if I go and stop my database server, and then if I go back to a particular link that needs to access data from database like this, you will see that we get an exception, and it results in HTTP status 500 internal server error, and somewhere it's going to say that unable to acquire a JDBC connection. That's the reason why we are getting an error. Again, you can see that the exception itself is printed from Tomcat, and the look and feel of this doesn't match our application. So when such server-side errors take place, generally there are a couple of things that we would like to do. Number one, maintain the look and feel of your application common to the rest of the application. Number two, to log the error details in a logger, so that in the future, if there is a developer who got a ticket to find out what's the problem, he or she can go and check the details of the errors. To do that, let's go back to our application, stop Tomcat for a while, and open pom.xml, because we have to add a couple of dependencies if you want to use logger. The logger service that we're going to use is from SLF4J. So let's go to Maven repository, look for SLF4J, take the first one, which is SLF4J API, select the latest table, copy that, come back to pom.xml and paste in the list of dependencies. Another one is the SLF4J support for Java or JDK, and if I scroll down here, you should see that there is a SLF4J for JDK 14. Even though this is for JDK 14, it supports for JDK 8 also. Let's select the same, copy that, and then come back to our dependency list. Make sure that the scope is not just the test, because we are also going to use this in our application. So I'm going to format this and save. And the latest versions of the jars are downloaded from the net. Now the next thing that we want to do is to handle these exceptions. Handling such server-side errors is a common problem, and Java EE itself provides out-of-the-box support for this. Although we are more interested in the Spring framework, let's have a look at how Java EE addresses the same. For this, we have to go to web.xml file, which is under the webinf folder, and you can go here and add a tag here called error page /error page. Basically, we want to redirect the user to an error page, but the error itself can be caused because of two issues. Number one, if you know what is the error code, such as 404 or 500, you can use that. So the tag here is that error code, let's say 404. And then I can say here location is /webinf/pages/ let's say for example page not found.jsp. And this is supposed to be the file that tells the user that, hey, you reached a page that doesn't exist, and check out some other options. We don't have this file. Let's create one in a minute. The other option that you can do is you can create another error page and say that the exception type is java.lang.exception, or you can be more specific and say code.vinod.dao.dao exception. And then again, you can say location /webinf /pages /error.jsp. Once again, this is a page that doesn't exist, so we have to create one for this also. Let's go and create both the pages, pnf.jsp for page not found. So I'm going to create a new file under pages, call it as pnf.jsp. And to bring the common look and feel, we're going to say %@ include file equals to /header.jspf and close the same. Give a similar one for footer. And in between, I can tell the user that the page that you're looking for doesn't exist. So I'm going to add a h3, add a class of text-danger that gives you a red color. And then I can say, sorry, the page you are looking for doesn't exist. Likewise, I'm going to create another file called error.jsp here. Going to copy and paste the same thing back over here, except that the error message can be something different. Let's say we give here, oops, there was an error while processing your request. Please retry after a while. And if the error persists, please write to, let's say for example, helpdesk@kvinod.com. And to provide a hyperlink to the same, I can type here ahref equals to mail to : the email ID, and then the email ID itself, so it's a hyperlink now. Let's give a ending tag for paragraph. If you also want, you can include the technical details of the error, but we will see that in a few minutes later. Let's save all the files and go to Tomcat, restart the same. Once it's restarted, let's go back to the browser. And again, let's go to the home page. And from here, let's click on all products, and that's going to result into an exception. So we should see now our convenient error message that comes as, oops, there was an error while processing your request, please retry after a while, and so on and so forth. Similarly, if I go here and then type, just like the previous one, some junk character now and press enter, you will again see that, sorry, the page you're looking for doesn't exist. So most commonly, these are the two erroneous situations that you would like to handle. And since we are redirecting to error.jsp for any kind of server-side error, all our error handling is taken care of. However, there is no Spring involved in this scenario, which is what we want to do. So we have more control within our web controllers. So let's go back to the web.xml and comment this one, because this is what we are more interested to handle. Save the file and close that. And let's also go to our product controller by going to navigate, open resource, or command shift or control shift or on Windows, and then type here product controller. And here itself, we can provide a new function to handle all exceptions. So let's go here and create a function. The function is just like any other request handling function. Its return type is going to be a string or model and view. String means it's the view name. Model and view is an object that represents both model as well as the view name. So we're going to follow the same pattern that we have been following. So I'm going to give here a public string, and the return value would be ERR, which is nothing but error.jsp. So let's give here a name called error handler, and then we can ask for what was the exception that took place. So we'll say exception EX, and we can also say here model in case if you want to store this exception object or its error details in the model itself. Let's go and write the body for this. The return value, like I said, is going to be ERR, and because of our view resolver, this is going to be prefixed and suffixed with /webinf/pages/ and then a .jsp as the suffix. Now to add the log messages, so first we have to create a variable called logger, initialize that and then use that. Because we are using Lombok, Lombok also has a support for SLF4J and the annotation is very simple. At the rate SLF4J, you press Control space and you can see we got it. This creates a member variable here called log. If you go to the outline here, you can see that there is a private static final variable called log of type logger, and that's been initialized also. All I have to do is to go and start using them by typing log dot functions like debug, info, error, etc. I'm going to just say here, because there is an error, so we're going to say log dot error, and then I'll say ex dot get localized message, and that's the only thing that we want to do. If you are using something like Kibana, you will be able to collect all the log errors into a dashboard and then analyze that. Let's go and say model.add attribute. Give it a name. Let's call it as EX itself. Attribute is also the EX itself. So the one that we received here, we're going to pass it on to the model. So we know that this is going to be in the request scope. So we can go to our JSP and then say request.getAttribute of EX. Now, since we have to tell Spring that this is an error handler, we're going to say here at the rate exception handler and then say what kind of exceptions this function should handle. And if you're interested in handling all kinds of exceptions, use the more generic exception.class. And now Spring knows that whenever there is an exception within this particular product controller, this is the exception handler for that particular exception that got thrown. Let's save this, restart Tomcat, go back to the browser. Let's click on all products again and see that we do get this time, oops, there was an error while processing your request, and the same error page, even though we have commented the actual code in web.xml file. Also notice that if I go back to the console here, we should see an error that actually got printed because of our log4j logs. One more thing that we also are interested to do is to use this EX in our err.jsp. So let's open the err.jsp. Here I can probably provide a pre-formatted text and then use a scriptlet and then say here exception EX equals to request.getAttribute of EX. Request.getAttribute returns a java.lang.object reference, and hence we need to do a casting here. And now I can use this EX and then say print stack trace, but the print stack trace will be printing on the server side console. In order to say that I want the stack trace to be printed right here, we have to supply the variable out here. But out is a JSP writer, whereas the print stack trace requires a print writer. So we can say here new java.io.print writer of out. Out is the implicit JSP object that represents what is being written over here. So if I save this and go back over here, refresh the page or make another request over here, we should now see a detailed exception stack trace also. However, for a regular user, this might be kind of scary. We don't want to do that. Probably we can give here a button that says click here to view the detailed exception stack trace or detailed technical errors. So let's go back, add a JavaScript code here that can show the initially hidden pre-formatted text. So to initially hide this, let's give a style here and then say visibility of hidden. We'll also give it an ID saying that this is the error details, so that we want to find this error details and then show that because it's initially hidden. And to trigger this displaying of this particular pre-formatted text, let's add a button and let's add a class of btn-link. So even though this is a button, it looks like a link. And then we say on click equals to, let's say show error details, which is a JavaScript function which we are going to write. And then I'm going to type here show technical details / button. Let's create this function as a JavaScript function. This has nothing to do with Spring or JSP. So it's just a helper function that we're going to write, and it's typically a one-liner. Let's call it as a function show details. We have to get this particular element whose ID is this. So I'm going to say document dot get element by ID of this ID dot style. So we're getting a reference to this attribute, and then say the visibility should be changed to visible. Let's go back to our browser, go back to home, click on all products, and we should now see that there is a show technical details, clicking on which we get the rest of the details. Let's come back to our Eclipse. This controller function that we have written handles exceptions only in product controller. Incidentally, we have only one controller that matters, which is the product controller. But in a large scale application, you're going to have supplier controllers, category controller, customer controller, employee controller, and so many other controllers. Obviously, there is no point in repeating the same thing for every other controller. A better way would be to externalize this from the controller. And the way you do is you create a new class here and then tell Spring that, hey, anywhere there is an exception, this class should be instantiated and the function should be executed. So we're going to call this as global exception handler. And then this is a regular Java class. We can cut this particular function from here and then paste inside this. And this is not a controller, but it's an advisor to the controller. So we call this as controller advisor. We'll also need to have this log. So we're going to say @slf4j. And now Spring knows that whenever there is an error, this object will be instantiated and this function would be executed as long as it's an instance of exception or its subclasses. So in the other class, we don't need any of those unused imports. Let's remove that, save it, come back over here and save the file. Now, of course, if I run this code, I should still see the same. Let's go back to our Tomcat, restart once more, and go back to the browser, click somewhere else, and come back to all products. Once again, we should see a similar error message, but this time coming from a global exception handler. So if you add more and more controllers, we don't have to worry about exception handling separately. First, let's try to understand what REST really means. It is an acronym for Representational State Transfer, but if you want to understand in simple English, read it from reverse. It sounds like transfer of state in different representations. The term state here refers to the state of a collection of objects known as a resource. For example, products, customers, orders, users can all be considered as resources. In general, a resource has some information, which is called as state, and the client and servers may exchange or transfer the same in different formats, which is called representations. For example, a mobile application may request the server to provide state of a resource in XML format, while another web application may request the server for the same state in JSON format. Both server and client can bargain for the representation of state from each other, which is termed as content negotiation. This type of communication between the client and the server is carried out using the Web as Transport platform and leverage the HTTP protocol features. While working with RESTful web services, following must be remembered. Number one, a resource is accessed via Uniform Resource Identifier or URI. Number two, the HTTP request methods such as get, post, put, and delete act as verbs or action to be performed on a resource. For example, while the get request for a given URI might get the state from the server, a post request for the same URI might add a new state to the existing resource. Number three, the HTTP header accept is used by a client to negotiate with the server what kind of representation is needed by the client. For example, a value of application/JSON for this header tells the server to send a JSON representation of the resource. And number four, the HTTP header content type is used by a client to indicate what representation of the state is sent as payload by the client via HTTP post or put method. In this video, let us create a resource that can give different representations of a product. For that, let's create a new package called co.vinod.web.resources, and under that, let's create a class called product resource. So I'm going to right click on any one of these packages, new class. Let's call it as product resource, and let's change the package to web.resources. Let's click finish and write a function here that can produce a list of products. So let's call it as public list from java.util, which is going to be of type product from co.vinod.entity. Let's simply call it as get all products. And from here, I want to return the list of all products, for which I may want to make use of the DAO or a service class if we have. So I'm going to create a variable called DAO or HTDAO of type product DAO. So let's create product DAO, HTDAO, and let's auto wire this so that by the time product resource is created, we have access to the HTDAO object. So we'll say auto wired required equals to false is not going to be used here. Now that I have this HTDAO, I can simply say here return HTDAO.getAllProducts. This throws an exception. I'm going to throw it away further so that whoever is calling this, in our case it's going to be Spring, is going to receive this. We'll also look into how to handle these exceptions and errors later. And now let's say I want this particular function to be invoked when the user makes a request called /API/products. In fact, all the functions of this corresponds to the same resource. So let's annotate that over here. So we're going to say @request mapping and then say here /API/products. So /API is a convention to indicate that this is a web API, so people can make use of this API. And products is something that identifies this resource. Also, it is important to understand that the naming convention it's plural, not singular, because we have one or more resources of type product, so we call it as products. Now let's also annotate this as @controller for the time being, although in Spring version 4 onwards, we have something called REST controller. We'll see what is the actual problem with this and then we will use the REST controller in a bit. And now we have to say that this particular function should respond to this URL only if the request is get request. So we're going to say here again @request mapping. And then we say here method equals to request method dot get. So one small problem here is that whenever there is a controller and there is a handler function, the handler function's return type must be either a string representing the view name or a type called model and view, which consists of model data as well as view name. And typically we have seen so far that the view name is a logical name that represents a physical JSP file. We don't want this function to return a view name, but instead we want this list of product itself to be represented in some format and to be given to the caller. For that, we have to add one more annotation called @response body. When you use a response body for a function, the return value is now taken and given to a different view resolver. In this case, the view resolver is called content negotiating view resolver. So what this does is it's going to check the request scope for what kind of content the user is interested in, because this is about representational state transfer. We want to see what kind of data the client wants. Is it an XML or a JSON or any other format? So the content negotiating view resolver will check the request for a header called accept and sees what is the MIME type the user has specified. It could be application/XML, application/JSON, or text/CSV, etc. Based on that, it takes the help of an API such as Jackson or JAXB and converts the list of products into either JSON or XML and sends it back. So this is how the list of product gets converted into XML or JSON. One more thing we have to do before we run that is we have to add this particular package in the component scan, or we can actually say our component scan should scan everything within the web package. So we can go to the app config and probably change this to core.vinod.web. Save this. So now we can right click our project, run as run on server. So the output comes on the browser, but for a better clarity, we install a tool called Postman. So you can go to Google and look for Postman download, and you will get this download Postman app. Earlier, this used to be a Google Chrome extension. Now it is a separate app that you have to install. I already have downloaded and installed, so it's a straightforward procedure to download and install. I'm sure you will be able to download, install without any problem. Let me open Postman. And the reason we use Postman is because it allows us to create new requests. We can specify different kinds of methods like get, post, put, delete. We can add additional headers, query string parameters, authorizations. When we are sending a post request, we can send the request body in different formats. And that is the reason Postman is preferred, whereas in the browser, we can only send the URL, and all the URLs that you type in the address bar will be considered as a GET request. So let's make a request to our resource, which is nothing but this HTTP localhost 8080 Spring MVC basics slash API slash product. So if I'm going to type that over here, localhost 8080 slash spring dash MVC dash basics slash API slash products. Let's say I want to get JSON response. I can go to header and say that I want to accept a format called application slash JSON, and any additional parameters if you want you can send. So this is to say that I am interested in this particular format. So when I click on send here, although I have here a handler for the same, this handler should be able to produce outputs both in XML and JSON, because I didn't mention any specific type here. But let's give it a try and see what happens. So I'm asking for JSON. When I click on send, it comes back with 500 internal server error. If you go to the preview here, you can see that it says no converter found for return value of type java.util.arraylist. So it says that I don't know how to convert an array list into a JSON. And this is because when content negotiating view resolver is trying to look what kind of data the user wants, and it finds that it is application slash JSON. This is the MIME type. It did not find any APIs or any Java code that can convert a Java object such as an array list into a JSON string, and hence it's giving an error. And the error is fixed by going to Maven repository and look for Jackson and add Jackson data bind, Jackson core, and Jackson annotation to our dependencies. So I'm going to open each one of them in separate tabs and copy the latest version of their APIs, paste into our pom.xml along with the list of other dependencies. Format and save it, and it should be downloaded in a couple of seconds. And now that the jar files are ready, let's restart our Tomcat. And once the Tomcat is ready, we can go back to Postman and then just resend the request, and I should be able to see the list of products in a JSON format. So it is started. Let's go back to our Postman, send this once again. And you can see now that we have got the list of products in a JSON format. So let me scroll up and you can see that there's an array here consisting of one product right here. So followed by a second product. Every product also has the supplier details as well as the category details. One of the problem is that if the picture is actually there, then that will consist of junk characters, and if I don't want this picture to be part of my output or any of these fields to be part of your output, you can go back to your entity class. In our case, it's the category entity which contains the picture. So let's open the category, and whichever field you don't want JSON to be included, you can just say here @JSON ignore and press Control space over here to include the annotation. Save this, wait for server to restart, or you can probably restart it by yourself. If I go back to Postman, send it. Now picture should not be part of the JSON output. And you can see that we have an array of products. Each product consists of supplier and category, but the category does not contain the actual picture object itself. Similarly, in the product class, I can say category ID and supplier ID. I don't want that to be part of this because supplier has a supplier ID. We can add the JSON ignore for that as well. One other thing that we will see here now is that every function in our product resource is going to be returning the model data directly so that it can be converted into a different representation. So at the rate response body has to be given, because if we don't give that, then it will assume that this is the name of a view. So it will assume that the toString of list of product is going to be considered as a logical view name, and it will try to resolve for that view name. We don't want that, so every function we should add this response body. But starting from Spring 4 onwards, there is a new annotation called REST controller, which will ensure that response body is added to every other function here. If it is mapped with a request mapping, it is automatically assumed as a response body. So I don't need this response body at all. Let me delete this. Press Command Shift O to remove the unused imports, save my file, restart Tomcat once, and go back to Postman and send the request again, and you should now see the same result without any problem. While I'm able to get the list of all products or a bunch of them, let's say I want to get a single product. Of course, the single product I want is based on the product ID. So the product ID can be supplied in the URL in a couple of different ways. Number one, I can type here question mark ID equals to, say for example, 12. So this is called as a query string parameter. While this is perfectly alright, but suppose if I want the supplier for this particular ID, then I'll have to come up with a different URL. Whereas the preferred method is something like product/12. So this would be a single product whose ID is supposed to be 12, or the primary key value is supposed to be 12. But with this now, the same URL can be extended to say, hey, give me the category information related to the product 12. So if you look at this, it says there's a list of products. I want a single product out of the 12, but within that product 12, I have a category. I want that particular category. You can even go and say, no, I want all of the products within that particular category. So you can see that I'm narrowing it down to a different kind of resources using the URL. And that is why we follow the parameters such as this 12 or category or products as part of the path instead of supplying it like a query string. So in this case, I want to supply this 12 as what is called as a path variable. And another way of sending this 12 would be to add an HTTP header over here and then receive it as a HTTP header in the controller handler function. So at this time, if I make a request, it's going to come back with 404 because I don't have a URL mapping to /API/products and /something over here. This could be 12, 20, whatever. We don't have that. So let's go back to our code, stop the server for a while and write another handler over here. Let's make some room and then add another handler over here, public. This time I want a single product. Let's call it as get product by ID. And let's also say I am supposed to receive an integer ID. And then I can say here return htdow.getProduct with the ID that I have got. And this throws an exception. Let's throw it away further. But how do we map this, right? By default, this function is also mapped to /API/products. But to say that this is an extension of this request mapping, you can simply come here and say @request mapping. And then say here path equals to /. So it is an extension now /API/products/. But if I type here ID, something like this, then it is considered like a hard-coded value like /API or /products. This also is /ID. But in our case, this part is something that is variable. So to indicate that this is a placeholder in our request mapping, you simply have to say curly bracket ID like this. This can be any name, your choice. It doesn't matter what is this. But this has to be now mapped to my variable and say that, hey, in the path, there is a variable called ID. So we say here @path variable and whose variable name is ID here. So this is the ID. If this name matches with this variable, this part is optional, so you don't have to give it. Let's save this. Now our new handler function is ready in just one line. So let's go start the Tomcat server. Let's go back to the Postman, send the request for /API/product/12. When I click on send, I should get a JSON output for that particular product. You can see that I got a single product now, and the single product has all the information like supplier and category. And if I want to send a different one, instead of 12, let's say for example, I can say 56, send it, and I got the product details whose ID is 56. And let's try one more. Let's try here something like 34, send it, and I got the response as well. But suppose I send an ID here which is non-existing, let's say 349. I have only products from 1 to 77. Probably I added few more, but 349 is an invalid product ID, and I will be actually not getting any output. When I click on send, you can see that it comes back with status 200, but there is no response. Now in the concept of REST, we want to say that this particular resource is not found by sending a response status of 404 because this is invalid now. To do that, you can go back over here. Let's stop the server for a while. This is where you collect the return value from this particular function and conditionally return a response. Since the response status changes based on the return value of this function, let's change this from product to what we call as response entity. This is a class from Org Spring Framework HTTP package. We say that it's a response entity that can produce, if you don't know, you can say question mark. For example, if you want to give a response with a JSON message saying that the data for this is not found, you can actually respond it with a map. But this time I just want to say either a product or no product. I'm going to say here product. And let's assign this htdio.getProduct to a variable called PR and create that PR to be of product type. We check here if PR equals to null. We need to return a response whose status is 404. You can say here return response entity dot, and you can see that there are different functions. One of the function most popular is not found. If you select this, that is equivalent of responding with a 404. And then you have to call here the build function so that an actual response entity is being created and returned. And in case if PR is not equals to null, then I can come down here and then say return response entity dot OK, and then supply the PR because OK corresponds to 200 and PR is our response body that we want to send, and automatically it will convert that into JSON because the client is asking for JSON. So let's save this, restart Tomcat and go back to Postman. And now if I say 349, it's going to come back with a 404 because we are responding with 404. You can also respond with some message saying that it is not found. I'll show you that in a minute. But if I say here, no, it is, just say 44, which is found, I will be able to get the actual data corresponding to product ID 44. So in case of the data not found, if you want to send a message, you may have to add an entity also along with that, but that entity has to be product. So since it is not a product in this case, you can say here question mark to indicate that I don't know what kind of response I may give. Let's create a variable of type map from util. A key is going to be string, value is going to be object, or it could be string also if you're only talking about messages. And then let's create a m new hash map. Let's put some key value pairs there. We'll say m.put and then say the key here is, let's say, message, and value for that is no product found. And you can also say here m.put product ID. That's the one that we want to give it as an object. The user supplied me an object. I'm giving the object back. And now to make use of this map, let's return a new response entity object. We say here new response entity, and you can see that we can supply the body as well as the HTTP status. A body is nothing but this map, and status is nothing but HTTP status dot not found, and that's basically like equivalent of 404. and just have to remove this T, saying that the object can return a different type. Alternately, you can also say here it is returning a map object like this. That's a lengthy way of doing, so I'm just going to remove that. So this is also automatically going to take it from here. So now that our response entity is ready, let's go save our files, start Tomcat again, and go back to the Postman, send this 444 again, and you can see we got the 404 as status, as well as we got a response body that consists of product ID 444, message is no product found. So this is how you can respond with a different status code other than 200, as well as with a custom body. Now let's write a handler for /API/products, but for post method. For this, let's write a function called public. Let the return type be response entity of, let's say, question mark. On successful adding of the product, so let's return the product object with the product ID. Whereas in case of an error, let's return a map, and let's call the function name as add product. Let's also take an argument of type product. Let's call it as PR. And then we have to say htdao.addProduct of PR. This function throws a DAO exception, but unlike the previous ones, let's surround this with a try catch. In case if this is successful, PR is a product with a primary key now, and let's return the same thing as a response entity by typing return response entity dot OK, and then supply the PR as the body for that. In case of an exception, let's get rid of this one, and then let's create a map just like the previous one. I copy this and paste over here, and then I type here m.put a message key, which is nothing but e.getMessage. If you want, you can add additional stuff, like for example, what is the product that you are trying to add, such as m.put, and then let's type here product, or you can say the input data, and then PR itself, so user can refer whether the values have come properly or not. And now let's give here this return statement, but with a different HTTP status. Let's copy paste over here and then change this to dot internal server error. Let's also do a mapping. This is going to be @request mapping. We don't have to give any path because the path is same as /API/products, but we will specify here method equals to request method dot post. One small problem is when you ask for a dependency of product, Spring attempts to convert all the request parameter names into product properties and then tries to create a product object. We have seen this in the Spring MVC demo when we were trying to add a product using an HTML form. But this time we are sending XML or JSON data as a request body, and we have to tell the data is not in the form of a name value pairs, but whatever the data is there in the request body has to be converted into a product object, assuming that it is XML or JSON. We simply have to add an annotation here called @request body, and then Spring will convert automatically the entire request body into a product using either JAXB or Jackson, depending on the type of content that we are sending. Now this is where the HTTP request header called content type comes into picture. So if the user has some kind of request body, but the content type header indicates that it is an application/JSON, Spring will make use of Jackson instead of JAXB. But if the content type happens to be application/XML, then Spring uses JAXB to convert the request body into a product object. Now that we have got this, let's give it a try. Let's also do a restarting of server. The server is now ready. Let's go back to Postman. And before sending a product, let's first make a request to the product. You can see that I've already made a request to product/12. It's a GET request. Accept header says application JSON. So when I clicked on send, I've already got a JSON version of this. And I'm going to copy this entire response. Copy this, go to a text editor, and then paste over there. I don't need to send an ID because ID is automatically going to be generated. And let's change the name of the product to, say, for example, mozzarella cheese. I don't need this supplier ID because that will not be used for insertion or updation. In the entire supplier, the only thing that is required is this. The rest of them are not required, so I'm going to get rid of this. Likewise, category ID is not required. Category ID is the only thing that is required inside the category. And the rest of them I'm going to keep it as it is. So when I send this as a request body, we want to see a new product being added. So I'm going to copy this now and go back to Postman. Let's say we want to send a post request, but the post request is only for /API/product, so there's no ID to be sent. And this time, along with accept, you may also have to send a content type indicating what kind of data you're sending. And since we are sending JSON, so we'll say here application/JSON. But this can be automatically added here by going to the body and then say that we are sending a type of body which is raw, and then paste that over here. But you can see when I paste it, it just shows it as like regular text, but there is an option here to say what kind of data is this, and I can say that it is JSON, and you can see now it is color coded. Plus, if I go back to the headers, you will also see that the content type application JSON has already been added. So when I click on the send button over here, a new request is sent and is received by Spring, and Spring knows that this is the function which is supposed to be handling that request because of the method equals to request.post settings over here. And it takes the request body and tries to convert that into a product object using Jackson, because we said that the content type is application/JSON. And also we are returning a product object or a map. It tries to convert this product object into a JSON string because the user is asking for application/JSON here. So let's click send and see what happens. And you can see that the new record has been added with ID 84, product name mozzarella cheese, supplier ID null here because we did not supply the supplier ID. Supplier details, again supplier ID is 5 because that's what we sent. These things we did not send, so they are all null. And category ID is 4 and these two are null here. But if I go and get this 84, you'll see that all these details exist. So let's go and send a request to product ID 84 with a get request and see what happens. So I'm going to change this to get and add here /84. That's the new ID. When I click on send, you'll see that the actual product object comes with all the details. So these were all nulls because we returned the same object back. Alternately, we could have got a new object by typing pr equals to htdao dot get product and then say here pr dot get product ID and then send this. You will not have that issue. So let's save this and restart Tomcat and then come back to our Postman. Let's select the post request and make the same request again with content type application JSON. Body is the same. Let's send the same data again. Click on send and this time you should see it should give the complete product details after adding, and this time you can see it is 85 and the product supplier as well as category details also are coming because this time we pulled the data from the DB after successfully adding the same. If you want to modify a resource, we send a put request instead of post. Also, we indicate what is the ID of the product that we are actually going to modify. And then we supply the modified version of the resource that may even contain the product ID, but we are going to ignore that in case if product ID already exists. But the rest of the details should be updated or should replace the existing resource. So essentially, if I have got this data here, let's say I copy this and imagine this is the body that I'm sending, but we're only interested in updating the product resource as well as probably supplier details also in case if you want to modify. So we will be changing this to put request, but we also have to say here API/products/85. So we're going to ignore this particular entry, but we will update this product 85 with the rest of the details. So to write a handler for this, let's go back to Eclipse, stop the server for a minute, and then come back here and write a function called public request entity of question mark. And then we say here update product, that's the handler. Once again, we're going to write two parameters here. One is the integer ID that corresponds to this 85 that we are supplying. And then we are also receiving a request body, which is going to be converted into a product object. Let's call it as PR. And the annotations go like @request mapping, method equals to request method dot put, and then we will say here that this is supposed to come from a path variable called id. So we haven't received any path variable because by default this maps to /API/products. We also have to say that this is supposed to receive an id. So we can say here path equals to slash in curly bracket some variable. This is a placeholder id. We have to map it to this by typing @path variable. And this one is going to be @request body. So let's write inside the function. We are going to pretty much copy paste the same thing over here, but instead of add product, we're going to actually call htdao.update product of PR. But to ensure that the product ID of this is ignored and the product ID of this is taken, so we're going to say here pr.set product ID of ID. So basically we are overriding the ID that is already there in PR, or in case if PR didn't have an ID, we are setting that over here. And I believe there was a typo here. It is not a request entity. It's supposed to be response entity. So I'm going to copy paste that over here. And now my function is pretty much ready. So we can go and test it out by restarting the server and then going to our Postman and sending the put request. So let's go back over here. I've already got this. Let's say the product ID 85. I want to change this from mozzarella cheese to, say, for example, cheddar cheese. And I'm going to keep all of them as it is. Maybe the price from $38 to, let's say, for example, it's $27. Units in stock, say, for example, we have 100 of them. 10 of them on order, and reorder level is 5. Let's make this change and send this via put request to 85. Even if this is something else, that doesn't matter because product ID is taken from the path variable, not from the product object itself. Let's click send and see if you are able to get the result. So you can see that we got the response back. 85 is the product, cheddar cheese. And if I come down here, the unit price has been changed, units in stock is changed, units on order is also changed, as well as reorder level. Now let's also go back to the DB and verify the same thing. So I'm going to go back over here, select start from products, where product underscore ID equals to 85, and control enter will give the result. And you can see that we change the name, and then of course the unit price, units in stock, units on order, reorder level, and discontinued. So this also have been updated. Now had we modified the supplier name, for example, that might not have updated. That's primarily because in our product.java we are having a many to one relationship for supplier. So modifying the product will not modify the supplier. If you want that to happen, then you have to add a cascade option here called cascade type, and then say here dot, you can say here either merge or persist or all. Better specify two of them at least, merge and persist. You don't want to really do a remove because deleting a product will try to delete a supplier, which we don't want to do. So we're going to say here merge as well as cascade type dot persist. This is how you can tell that when a product is modified, a supplier, if in case if it is changed, you also have to change the supplier. And likewise, you can also do the same thing for the category over here, and save your code, go back to Tomcat, restart the server, wait for Tomcat to restart, come back to Postman. So this time when we are sending the data, let's change the product unit price from 27 to 30. As well as we will add some entry to the description here saying that milk, curd, cheeses, etc. And supplier, of course, what we'll do is we will give the same number as the fax number, copy and paste over here. And if I send this now, the unit price for the product, description for category, fax for the supplier must change. So let's hope that's going to work and click on send. And it has been sent. Let's go verify that over here. You can see that new fax number has been updated to supplier, new description has been updated to category, and the unit price is also updated to the product. So let's verify the same category 4, supplier 5 in the DB. So I'm going to add here select star from suppliers, where supplier underscore ID equals to 5, select star from categories, and a condition where category underscore ID equals to 4. Let's press Ctrl Enter and see all the three of them. You can see that description has been updated, fax has been updated, and unit price has been updated. As far as the resource is concerned, we should also be able to delete the resource by sending an HTTP delete request. However, in our case, when we say we want to delete a product, we basically want to change the value of discontinued to 1 from 0. This is what we want to do. And of course, we also have written our product DAO to do the same thing. So let us see if we can send a delete request and make sure that the product gets discontinued. So to do so, let's go back to our Eclipse, stop the Tomcat server for a minute. Let's go back to our product resource, add a new entry over here, public response entity of, let's say, question mark, delete product. We're going to receive an integer ID, and this is the one that we want to do a soft delete for. So first we're going to say try. So there are a couple of things that we can do here before actually deleting. Number one is that we want to see if that ID is valid. So I can ask for a product and then check if product is null. Then we return a 404 saying that this is not found. To do that, let's say here product PR equals to htdao.getProduct, and we supply this ID. If PR equals to null, we already have this somewhere earlier. We had used this. If PR equals to null, we can actually copy this whole thing and then paste in place of this. So that's actually going to say that there is no product for this given ID. But otherwise, now I want to delete that. I can say htdao.delete product, and this delete product will take a ID as a parameter. We'll supply that. After deletion, we now have to retrieve the newer data because this is an old data which has got probably discontinued as 0. And after this discontinued is 1, but this is a stale data. So we're going to make this request once more. And this time we don't have to check for null because we have already found out that it is not null. But this is the modified version of the data. We now have to return this as a response entity because now we have successfully deleted that. So I'm going to copy this return statement and paste over here. And in the catch block, in case of any exception, we're going to simply copy this and paste just like that. Except that we don't have the product object over here. Let's get rid of that. We don't need that. We just send the message. That's good enough. One last thing is we have to annotate this as @request mapping. Path equals to /ID, which is what actually we have to map it over here. And then we say method equals to request method dot delete @path variable. And our function is ready. Let's restart Tomcat and see if we get the result for deletion. So let's go back to Postman and copy this URL, create a new request with delete as the method. This is the same URL 85, and header I can say I want to accept JSON as the response and click on send, and we should be able to get the product 85 and the value for discontinued must be 1. We'll also try for one more and then check that in the DB as well. Let's go back and change this to 84. Before sending the request for deleting this product's 84, let's go check the DB for the same. So I'm going to say here this is 84. Let's get rid of these select statements. And you can see that 84 has discontinued as 0. But as soon as I send this request, when the response comes back, if I go back over there, make the request again, you can see that discontinued is now 1 and it has been soft deleted. Here is the response for API/product/12, and accept has application/JSON as its value. When I click on send, we got this JSON data. But how about XML? So the MIME type for XML is application slash XML. If I send this now, and I'm hoping that if I get an XML, you see that I got an error. The error says 406 not acceptable. That means the content negotiation is failing because server is unable to produce the XML content. But for JSON, it's working because we added the Jackson APIs in our build path, and Spring is able to detect that and then give the output. For XML, Spring tries to use JAX-B. However, we don't have to add any additional jars to our build path because JAX-B is part of core Java itself, starting from Java version 6 onwards. To make this work, as an author of the product class, you should give the permission to JVM to allow a product object to be serialized in XML format. Since JAX-B is an official Java standard library, that needs your permission so that an object of a product class can be converted into an XML, just like how serialization works. So to do that, I have to go back to my code. I'm going to stop the Tomcat for a minute. Go to the product.java under entity. This is the one that we are responding. The way you can specify that it has to be serialized is, if you remember, you would say public class product implement serializable. But for XML serialization, you have to annotate this as @XML root element, and now magically everything will work. However, we have seen in the past that, for example, for supplier ID, I don't want to include that in my output. For JSON, we would probably say that it is @JSON ignore. And like that, for XML, you will have to say that this is a transient as far as XML serialization is concerned. Typical Java I/O serialization, you would declare this using a keyword called transient. Here we have an annotation called XML transient. The same thing I will also give it for category ID. As well as if I go to the category class, we have picture where we are given JSON ignore, along with we'll also give that XML transient, so that even in XML we don't want this to be output. Now that we have done, let's save this, go back to Tomcat and restart the same. And while it's restarting, let's send this request again and see if we get 200 with some XML content in it. So let's click send. So you can see now that we got the product with category and the rest of the details along with the supplier details in XML format. While this worked fine, how about getting the list of all the products? So I can say here API/products without the /12. And if I send this, I should be getting a list of products in an XML format. And that's what I'm hoping for. But when I click on this send, you'll see that it comes back again with 406 not acceptable. And the reason for this is very simple. Just like how product object was not serialized into XML because we did not have this @XML root element earlier. Likewise, now in the product resource, when you're actually asking for all the products, we are sending a list of products. Let's assume that it's an array list. So the class that implements list of which an object is being returned over here does not have @XML root element in its class definition. And since it is not our class, we cannot go and do any changes to that. So to solve this problem now, we have to create another class, which is a wrapper for the list, and return an object of that class instead of a list. So let's understand this by creating such a class. Let's go to the entity here and then say new Java class. And the class name, I'm going to call it as product list or any other name you want. And then click on finish. This is my class. I can say that, hey, this can act as a XML root element like this. Let's also add a default no argument constructor. We'll also add here @getter. We add @setter too. And let's create a member variable called products of list type. So let's type here private list from java.util. Product is our entity and let's call it as products. And because of the getter setter, we will have getter setter for the same. This will be automatically exposed as an XML element because the problem is only for the root element, not for the members. For example, if you see category doesn't have @XML root element, there was no problem in converting that into XML when it was part of the product because only for the root element that problem exists. So let's go to the product list. Now here XML root element automatically converts this entire list into an XML, and the root element will have this as the tag name, like product list. If you want to change, you can say here name equals to something else. Each element inside that will have products/products representing one single product. So to change its name, we say here @XML element, and we give a different name to that, saying it is a product and not a products. So let's save this. Go to our product resource. We say that it's a response entity of product list type. I'll delete this. I'll say here response entity of product list. Let's import product list. And what we have to do is we have to create an object of product list type. So product list, let's call PL equals to new product list. PL.set products of this htdo.getProducts, and then we say here return response entity dot OK, and then supply the body, which is PL, and save this. Restart Tomcat. Let's go back to Postman, send the request again. So I got an error 500 internal server error. Let's see what's the error. So if I go to the preview here, I see a readable error message. It says the class has two properties of the same name products. That's what actually it says. And I think it is in the product list. If I go back over here, the actual problem is the name product/product uses this variable. And because of this getter over here, Jaxby also tries to convert the get products into an XML element, and that is why we are getting that error. If I had not given this name equals to product, this problem wouldn't have come. But since I have given this and I want to retain this, so we have to tell Jaxby not to use anything other than the fields to convert into an XML. And to do that, all I have to do is to say @XML accessor type, and then we say here we want to use only the fields, not properties. Properties means getter setters. And as a good practice, let's also copy this and paste it in all our entities. That's one here. And go to the category. Let's also add that in the category, and one in the supplier, so that we don't run into problems in the future. Let's save all the changes, restart Tomcat, and go back to the Postman, click send again. So we got the status as 200. We are seeing the preview because previously when the error message was there, we clicked on preview. Let's click on pretty. And now we can see there's a product list. That's the XML root element coming from product list class. And this is the modified XML element name for each of the product. We have this product/product. If we had not given name equals to product, this would have been products/products. That's the reason we are using that. We may run into one more issue. Let's try this. First, let's get product number, say 12, get the details, and we got the response, no problem. But if I say product 122, which doesn't exist, now there is going to be a problem, because now our function, the handler function, is going to return a response entity of type map, just like how the array list did not have the @XML root element. The map implementation like hash map also doesn't have XML root element. So this will cause a problem now. So again, the same error, 406 not acceptable. So to solve this, we also have to have one more class for all these messages. So instead of map, we have to have a class that represents an error object. Probably I can call this as error response. And then instead of a map, I have to construct that and then send it across. So that's going to be applied for wherever I've used map. So let's go and create one more entity class here. Let's call this as error response. And that's just a regular Java class. No need to do anything addition. We only have two probably members in that. One is going to be called message, and that's the message that we want to use for sending. The second one would be probably a data associated with the error message, such as the product probably, or the ID, etc. So we'll call it as data, generic name. This is supposed to be of string type, and this is supposed to be of object type. And now let's add here @no arg constructor. @getter, @setter, and we'll also add @XML root element, and one important, like previously done, @XML accessor type. It's only going to work with fields, and that's important. And now that we have the error response class, let's go to the product resource and see if we can convert this into an error response. So what I have to do is I have to say first error response er equals to new error response, er.set message to this no product found, that's the message, and then we say er.set data to that id, that's the product id, and instead of sending the map here, we're going to say here er. So the same thing probably I can copy and paste in a couple of other places. For example, if I scroll down here, we have one more here. The data is going to be PR and message is the e.get message. So let's make these changes. So I'm going to copy this, paste over here. That's the message part. And PR is the actual object instead of ID. And we don't have this map requirement. And this is not required because we already have given over here. So one more place, probably here we have exactly same thing. I can copy these 4 lines and paste it. One thing is that it's supposed to be internal server error, not the 404. So I'm going to change this to internal server error. Same thing, I'm going to copy and paste even here also. And one other place I think is here where we are having a no product found. This is 404. I can copy this from here. Come down to this location, paste it. Whereas for this one, we are having a message. We're going to copy this one and paste over here. We don't have the product object though, so we can remove this one. And our application now is ready. Let's save all the files. Go to Tomcat, restart our server. And now the server is ready. Let's go and send the request. So I'm going to send it for a non-existing data. So let's send it. And we got an error response. Message is no product and there is a 122. Whereas if I say that I want it in the JSON format, it still should work because any object can be converted into JSON without any problem. Same as earlier. If I'm getting a list of all products as JSON, we are able to get that. So we get a products as an array and we have the array of products over here. We also checked out for XML. Let's give it a try once more. Click on send. We get an XML data as well. One last thing is, if you want to be specific about what kind of content that this can produce as well as consume, in the request mapping, you can always say that, hey, this function produces XML and JSON. We add another element over here saying that produces equals to an array of MIME types. You can say here it is application/JSON as well as application/XML. This I can copy and paste for all the get methods. For example, even over here. Another one is this where I'm trying to add a product. So since this is add, the user is also sending some data. We are also returning some kind of response entity. So while producers determine what kind of responses are given to the user, what kind of request body can be sent from the user can also be restricted by using something called consumes. So I'm going to add here consumes. And producers will now take care of the accept header and consumes will take care of the content type header. The same thing goes with the update. So I'm going to copy and paste this for update. And delete, of course, delete doesn't consume anything. It's only going to produce a result. So we don't need this part over there. And with this, our product resource is completely ready.